Καλή σας μέρα και φέτος από την Infocom 2023. Συνεχίζουμε αυτή την προσπάθεια που έχουμε ξεκινήσει. Είμαστε εδώ για ένατη συνεχή χρονιά, προσπαθώντας να παρουσιάσουμε τις δραστηριότητες από τα σύγχρονα ερευνητικά προγράμματα στα οποία εμπλέκεται ο Όμιλος ΟΤΕ και η Κοσμοτέ ειδικότερα, καθώς επίσης και ερευνητικά προγράμματα στα οποία έχουμε αναπτύξει συνέργειες με τρίτους φορείς, από ακαδημαϊκά ιδρύματα, ερευνητικά Ινστιτούτα, εταιρείες του χώρου πληροφορικής τηλεπικοινωνιών, οργανισμούς κλπ. Θα μου επιτρέψετε, επειδή το live streaming, η διαζώση ζωντανή μετάδοση στο διαδίκτυο γίνεται στο διαδίκτυο για να έχει απήχηση και εκτός Ελλάδος, να μεταφράσω και να μεταφέρω μάλλον τη ροή του λόγου στην αγγλική γλώσσα, χωρίς να σημαίνει ότι υπάρχει θέμα υποτίμησης της ελληνικής, τουναντίον, για να δώσουμε τη δυνατότητα σε ένα ευρύτερο κοινό διαδικτυακά να συμμετάσχει αφενός, αφετέρου έχουμε και κάποιους διακεκριμένους ξένους ομιλητές που θα εμπλακούν στη διαδικασία. Θα μπορέσω λοιπόν τώρα, θα μου επιτρέψετε να περάσω προλογίζοντας στη χρήση της αγγλικής γλώσσας. So once again, after the Greek introduction, good morning ladies and gentlemen. Actually, this is the 9th annual event we organize on behalf of the Hellenic Telecommunications Organization in the scope of the Infocom series. This year, we have a very important event which comprises of 12 distinct sessions, as you will find out. We comprise a total of 43 presentations. All of these are coming from ongoing European projects. And so, although the agenda is somehow strict, the aim is to provide information about what is actually going on regarding modern research and development activities, and most importantly, to correlate all these R&D activities to the market. Because sometimes there is the estimation that all these are theoretical works that have nothing to do with real activities, what is going on in practice. This is not the reality. We will try today to prove that R&D activities do provide feedback for scenarios, use cases, development of network facilities, applications, and so on. But after all this, now it's time to start. We pass to the first session, which, as you can see, is dedicated to the scope of the OASIS project. We will see in more details with the two presentations the scope of this project, which promotes an innovative continuum. And now it is time to pass to the first presentation. So we pass to presentation 1, please, which is a presentation intending to provide an overview of the OASIS project. This is a joint activity organized by me. I'm Ioannis Kokliouros from Hellenic Telecommunications Organization in cooperation with Dr. Michalis Alexandros Kourtis from National Center for Scientific Research Demokritos, who is also the coordinator of the project. So it is time to pass sequentially, okay. These are the contents of my presentation, as you will find out. We start with an introduction. We identify the fact that we have an extended growth of diverse intelligent processing services which create challenges for the market. In particular, as mentioned here, the most powerful data processing takes place in a centralized way at the cloud, which implicates for opportunities and capabilities, in particular about allocating involved and available resources. Actually, the practice till today is about promoting centralized data processing, which implicates for collection of data to a single centralized storage area and processing upon completion of a single computer. This is somehow an option which can be beneficial for the involved actors for the reasons you can see here: reduction of costs, more enhanced data security, and better handling of the case. However, this is not the panacea of all activities, because practically during the last years, I see that this goes up and down. Please try to stabilize the screen. Yes. So we have the option of cloud hosting, which makes applications and websites accessible by dedicated cloud resources. The related solutions are not deployed on a single server as in the previous case. On the contrary, we have a network of connected virtual and physical cloud servers that host the application or the related website. Here, some features implicate for the fact that applications and solutions are deployed on a cloud network. Resources can be scalable. The entities can pay for those they practically use, which is a very important economic or financial option. And cloud hosting also offers flexibility and reliability solutions, which provide many benefits. However, taking this also into account, centralized processing and cloud hosting can limit the services or the applications, because these may rely on large entities to offer authentication, data storage, data processing and connectivity, or virtual local environments for development and orchestration, a set of requirements that have to be taken into account for any activity. Practically, this is a sort of limitation for the users from their data governance and identity management, because this prevents users from efficiently managing their identities, restricts user visibility, does not help users to implement any of the related controls. So we come here for a challenge which practically is introduced by the scope of the OASIS project. And so, taking into account the parallel development of the 5G networking, or even the beyond 5G era, we propose the option of edge processing, which takes place when the combination is carried out directly in the smart sensor node or the gateway of the network. Actually, here the aim is about saving power consumption and ensuring that we have data confidential. We put basic computational as close as possible to the physical system, which is practically a benefit. So this option implicates for some benefits like confidentiality, cost reduction, a very important one, and lower latency, which is a fundamental feature in the scope of 5G activities. So, continuing our discussion, we propose the option of edge computing, which is an emerging computing paradigm referring to a range of network and services at the user or close to the user. And the term edge is quite important, implicates about processing of data closer to where the location where the sets of data are generated. And this creates opportunities for processing of data at greater speeds and volumes, and also activities that take place in real time. We go a step further, and with the aim of exploiting the potential of the edge processing we just mentioned before, a more holistic solution is about the scope of what we call as compute continuum. This has also several beneficial uses, as you can see: allows exploitation of hybrid IoT, edge and cloud infrastructures with high flexibility. We can have guarantees for performance, and includes both central infrastructure, that is clouds and public clouds and network, and smart devices. Some commercial solutions are already existing in the market. However, these have a closed profile, restricted to specific deployment scenarios, and so the option here is to promote a new solution. We have some parallel challenges about edge orchestration and security that are taking place in the scope of the OASIS concept. Now, summarizing the previous information, we have identified that in modern network developments, we have a massive increase in device connectivity and generated data. The most powerful data processing operates in a centralized manner at the cloud. However, as we mentioned before, centralized processing and cloud hosting may implicate for limitations. Limitations are set to the users regarding options about data governance and identity management, and related solutions for edge device authentication require a centralized entity, which is a very important option, to trust and authenticate these solutions. So we come actually to the scope of the OASIS project. This is a new project. It proposes a decentralized and secure swarm programmability framework for edge devices, taking into account artificial intelligence and machine learning opportunities, and supports a privacy-preserving object ID federation process. The actions of the project, the aims actually, it's about managing the life cycle of services across the compute continuum, promote the development of decentralized machine learning and artificial intelligence edge services via the development of a software development kit, and this takes place in the form of decentralized applications. So, another important option is the multi-tenancy, because it proposes involvement of multi-actors in multi-domain deployments. This takes place in parallel with enforcement of security and trustworthiness via the federation with peer operational system instances and in other administrative domains, and also capabilities and resources in third-party marketplaces, like, for example, including the one proposed by the European Open Science Cloud. Very briefly, I will pass the intended research topics of the project. Practically, the first challenge is about programmable frameworks for swarm and edge computing. Here, the aim of the project, based on aspects coming from cloud management, the NFV manual, which is a very fundamental one, SDN-based control, and IoT edge platform. Here comes the project, intending to go beyond existing control systems and application programming interfaces into an open programmable swarm framework. So the target here, based on the state-of-the-art of activities like the TOSCA, the well-known TOSCA framework, the aim of the project is to employ a transactional model for the life cycle of services. The second research topic is about what we call enhanced platform awareness, EPA. This is a well-known capability regarding resource management and orchestration systems. Here, the project comes to enable the discovery and pooling of edge platform acceleration capabilities, aiming mainly to create a holistic view of all different capabilities and to optimize placement decisions. Here, the action intends to leverage the proposed OSIS agents and collect device capability information in parallel with running customizable optimization algorithms. The next one is about option in research is about edge infrastructure sharing and monetization. Here the project realizes sharing of services across distributed edge-based infrastructure. We consider the already known Mosaic 5G initiatives, and so the project comes to combine the existing state-of-the-art technologies to develop an end-to-end cross-domain service framework. The importance is the option of providing a neutral host paradigm, allowing many market actors to participate. The next research topic is about AI-enabled data processing for hyper-distributed applications. Here, the project intends to rely on secure data spaces for storage and privacy-preserving machine learning technologies by promoting federated learning. Here, we adopt a machine learning operation set of principles in order to ensure continuous monitoring, treating machine learning assets consistently with other software assets. Another important option comes about from security and trustworthiness. Here, the project intends to use only nodes with a trusted hardware, firmware, and operating system, so that to provide assurance about these challenges mentioned above. And we also have a pillar covering blockchain-related governance. Here, the project intends to present an appropriate architecture to support heterogeneous technological devices. And using smart contracts, the project will enable decentralized autonomous software agents to play a critical role in certified edge and cloud devices. Now, very quickly, we will see what actually the project does regarding specific use cases. I will cover very quickly, because time is running, each one, giving some idea, correlation to the market. First one, the first use case is about e-health application. It's about Parkinson's disease. Doctors have identified voice alterations and oral communication disorders in a percentage of between 40 to 80% of patients with Parkinson's disease. So the option here, the challenge is to analyze voice by appropriate mechanisms, and the project will develop intelligent edge device capable of sensing, recording, and analyzing the patient utterances. The edge devices will operate and be monitoring over the decentralized autonomous organization, which is the fundamental feature of OASIS. And these will operate in the form of swarm and be able to be updated automatically. The second use case is about the electricity grid or the smart grid. Congestions can take place in an electricity grid. This may create difficulties, significant malfunctions that have to be avoided. So the aim is to avoid abnormal operations, and so to have the opportunity to electrical vehicles to offer to them a dedicated fleet platform to match their charging needs with network time and space requirements. So here comes the project covering another vertical, intending to demonstrate capability of deploying and coordinating the operation and management of swarms of IoT-based devices, in our case, electrical vehicles. These will be requested to be charged when surplus of photovoltaic generated power is available. And this is an important option regarding the energy grid. The next one, which is closely related to the telecoms, is about drone swarm over 5G for high-mast inspection, which practically affects telecom operators or other companies that practically develop masts. Here, the project intends to develop a dedicated software that will gather data using drones and will generate accurate 3D models in a 360-degree panoramic view of the antenna location. So the involved operators, market actors, will be able to see what is in the loss of sight of the location, identify obstructions, and establish the distance from existing antennas. The opportunity here is that the proposed solution can be beneficial because, on the one hand, considers various options of networking, joining together with edge acceleration technologies like SNN, and this is beneficial for the system for both options. The next use case is about safety assessment for buildings. Here, the OASIS intends to promote a new solution for collecting data from local sensors, and these data will be collected in appropriate databases, and the option is to integrate an installation of edge devices close to sensors and have a composition and deployment of distributed decision support software applications via the dedicated SDK of the project. The next one refers to industry of the fourth generation. Here the focus is about developing a finishing machine to satisfy medium and large companies requiring the highest quality. The aim is to implement automated manufacturing processes for semi-finished wood panels using automated guided vehicles. And the challenge is about incorporating this functionality for the so-called human-in-the-loop decision-making for the Industry 4. And the final one, trying to be within the prescribed time always, is about smart swarm energy harvesting and predictive maintenance wind turbines. Actually, the option for maintaining these turbines is a remarkable amount of their total maintenance costs. We consider the blade acoustic monitoring system, which is a new system for inspection and predictive maintenance of wind turbine blades. And this can be used in order to identify failures of ice, corrosion, or dirt on blades. The project comes to develop a new IoT-based, meters-based solution to support on-the-fly programmability. And we expect that this will also be beneficial for the option of the project. So, we have seen very quickly that the OASIS project promotes a holistic approach for edge data processing. The aim is to disrupt current practices and push artificial intelligence training and interference at the edge of the network. The project has several measurable objectives correlated with dedicated KPIs. Summarizing, we intend to design a decentralized, agile, and secure architecture to build a secure, trustworthy, and decentralized edge ecosystem. We will develop appropriate kits for an open programmable framework across different smart edge nodes. The project practically, and this is the high validity for the market, is oriented towards fulfilling 6 different vertical use cases, and this will maximize impact and will support market viability. And finally, for the participated users, these will be able to discover and select the available platforms, services, and capabilities, develop AI services in automated way, deploy and manage AI workflows, configure service performance constraints, explore data, and verify the integrity of infrastructure and services across the cloud continuum. And so this is my presentation, ladies and gentlemen. Thank you for your attention. We will pass now, thank you, to the second presentation, presentation 2. Please provide not the PDF file, but the PowerPoint, because this was the PDF file. I had some effects that have not been presented, unfortunately, but in the other presentation, we may take care of that. So please select the PowerPoint versions, and I would like to invite my colleague, Mrs. Vasiliki Vlachodimitropoulou, Vasiliki will present the Gaia-X framework and correlate this to the activities of the ongoing OASIS project.
Hello, my name is Vasiliki Vlachopoulou, and I will present the Gaia-X framework correlation and relevance to the OASIS project. I am a research and development engineer in OTE group of companies. I will present in brief the European strategy for data, the Gaia-X project vision and mission, framework, ecosystems, federation services. Then I will present the OASIS project, the major issues and challenges, objectives and scope, architecture, the data federation framework of the OASIS project, and the use cases of OASIS project, focusing in the relation with the Gaia-X project. Data is a vital resource in every aspect of our lives. The huge amount of data create economical opportunities, and the European strategy for data aims to create a single market for data. The key pillar of the European strategy for data is Data Act. The main objective of Data Act is to make Europe a leader in the data economy using this data. The data economy depends on a shared framework of trust that allows the creation of common data spaces. The Gaia-X project is a significant step for strengthening the data economy. In 2019, Gaia-X project was started by the German and French Minister of Economy, make sure that companies would not lose control of their industrial data when it is stored in cloud service providers outside the EU. Gaia-X provides the next generation of data infrastructure. It is an open, transparent, and secure digital ecosystem where data and services are available, collected, and shared in an environment of trust. Gaia-X aims to provide opportunities for innovative data-driven business models in the European single market. Gaia-X connects the data and infrastructure ecosystems. It is built in three basic pillars: federation, data exchange, and compliance. Compliance aims use decentralized services to enable objective and measurable trust based on the standards and rules of Gaia-X project. Cross-sector data sets and services are interoperable and portable. The data exchange is a process for accessing and use of data based in contract. Data spaces form the foundation of data ecosystem. Data spaces are a secure and privacy-preserving infrastructure, a clear and practical structure for accessing and using the data. The European rules and values, such as personal data protection, consumer protection, legislation, and competition law, are fully respected. Data owners will be able to share and grant access to specific data, and this data can be used for free or for payment. Participation, it is open in a number of organizations and individuals. On the right, you can see the current Gaia-X ecosystems. The GAIA-X infrastructure ecosystem is created by establishing portability and interoperability between network and interconnection providers, cloud solution providers, high-performance computing, and sector-specific clouds and edge systems. GAIA-X develops mechanisms to find, combine, and connect services from participating providers to enable a user-friendly infrastructure ecosystem. GAIA-X supports distributed use cases that spanning from on-premise apps, cloud-hosted infrastructures, through edge computing and cloud. GAIA-X addresses the complex technical stack, including infrastructure and existing network interconnection requirements of distributed use cases. In GAIA-X, the ecosystem is a virtual set of participants, service offerings, resources fulfilling the requirements of the GAIA-X Trust Framework. The usage plane represents the interoperability in the technical domain. The management plane is an extension of the digital governance provided by the federation of its ecosystem. The trust plane is a global governance of all the GAIA-X ecosystem. GAIA-X Federation services represent the minimum technical requirements and services that are needed to operate a federated GAIA-X ecosystem of infrastructure and data. The technical implementation of these federation services focuses on the implementation of secure federated identity and trust mechanisms in sovereign data services, which makes sure the identity of source and receiver of data and the access and usage rights towards the data. GAIA-X provides easy access to the available providers, nodes, and services. Data will be provided through a federated catalog. The federated catalog keeps self-descriptions of the providers and the services so that can be chosen from the consumers. The establishment of a compliance framework and certification and accreditation services. The OASIS project was launched in January 2023. Its main objective, it aims to create an open, transparent, and edge framework, programmable intelligence edge framework for swarm architecture and applications. The consortium consists of 21 partners from 9 countries. A swarm of robotics, vehicles and drones. It is a group that collaborates for a specific task. A huge amount of data are produced from IoT devices, and the intelligent processing services are used to generate insights and exploit data in various ways. By using centralized processing and cloud hosting, organizations restrict the resources that can be allocated to their services and applications. Authentication, data storage, data processing, connectivity, and vendor-locked environments for the development and orchestration are used by organizations that depend on large single entities. This also restricts the user's ability to administer their data governance and identity significantly. The need to use a central entity require the trust and authentication in a central cloud, thereby establishing an identification process that is not portable. The objectives of OASIS project is to design a decentralized, agile and secure architectures for collaborative smart nodes at the edge using DAO, decentralized autonomous organization integration. The second objective is native device support by integrating self-sovereign identity for a portable digital identity. The third objective is to build rapid development kits for an open, programmable framework across different smart edge nodes, while including efficient cloud-to-edge continuum intelligence across heterogeneous target environments. We'll demonstrate the framework and programmability toolkit in a set of different vertical use cases and evaluate the benefits across different sectors. We will maximize the impact of the OASIS results by the creation of an open source community around the OASIS solutions, engaging a diverse set of stakeholders. OASIS vision is to provide the open tools and secure environments for swarm programming and orchestration in various fields in a completely decentralized manner. OASIS targets the implementation of a portable and privacy-preserving ID federation system for edge devices and services with full compliance and compatibility to GAIA-X Federation Trust directives and specifications. OASIS provides a secure data exchange mechanism through GAIA-X framework for data exchange across actors in the same or different OASIS instances. OASIS will contribute to European-level projects like GAIA-X that aims to maximize the benefits from the use of data in order to benefit the European economy and society. OASIS also will use the GAIA-X data formats to ensure interoperability, provide feedback on the use of its technologies, and investigate how AI and machine learning models are compatible with their data formats and can be distributed to the OASIS platform. This is the high-level architecture of OASIS project. It consists from programmability layer, swarm organization and identity layer, the deployment and execution layer, and the data federation layer across all these layers. The OASIS project, like the GAIA-X project, is built on the core principles of data democratization, shared governance, secure data exchange, and trusted data sharing. Adopting a decentralized architecture will create a low latency environment for various applications and services, ensuring data privacy, security, cost-effective storage, and data availability. Programmability layer. This layer consists of portals and tools that interact with data, identity, and trust services. The components of OASIS SDK are used for the programmability and orchestration of the swarm of IoT devices. Swarm organization and identity layer. DAO as a service. Decentralized autonomous organizations are blockchain-based communities that are designed to bring a new, more open and democratic management structure. Swarm self-sovereign identity identity introduce a new approach in which the users and devices manage their identity themselves with increased end-to-end security and data privacy by controlling what it is shared, with whom, and for what purpose. Deployment and execution layer includes application deployment, cloud edge accelerations, and network provision. OASIS, like Gaia-X, enables combination of services that range across multiple providers of the ecosystem. OASIS authentication features guarantees that only nodes with a trusted hardware, firmware, and operating system are used. The infrastructure ecosystem has a focus on computing, storage, and interconnection services. Interconnection services enable various providers to offer services, ensuring the performance of single provider network on a multi-provider composed network. The OASIS Data Federation and Sovereign Framework will use the Gaia-X identity and trust plane for authentication, authorization, and trust services. We'll also use Gaia-X and IDSA data exchange tool for data sharing. We'll evaluate if we will use Gaia-X federated catalog instead of developing a specific broker within OASIS. We will evaluate also if Gaia-X F tools are suitable for an OASIS-specific implementation of Gaia-X projects, and we will include the OASIS instances and infrastructure providers within the Gaia-X ecosystem. We will demonstrate the implementation of the Gaia-X framework and other technologies across a variety of ecosystems, like e-health, mobility, real estate, industrial, and energy and security. These were described before in the previous presentation. Thank you.
Thank you so much, Vasiliki, for this excellent presentation. I feel that this second one has perfectly identified the scope of the Gaia-X framework and has correlated explicitly to the OASIS project. So you may be able to have an idea of what this project intends to realize, and most importantly, which the domains and the use cases or the verticals are where our intended activities are to be focused. And we will pass now to the second session of our presentation, which is based on the scope. Please, the next slide for the second session. If not, no. Leave it, we go to the presentations. This was not the proper one. Session 2, please. We are running out of time, and it would be a pity if this is due to our faults. Okay. Session 2, please. Okay. We are still looking for this. This is a session dedicated to the activities of the Smart 5 Grid European funded project coming from the ICT 41 European Call. Here we have the honor to invite 4 dedicated presentations, one from the project coordinator and some other by partners participating to the project. So we will see actually how 5G correlates to Smart 5 Grid activities. However, we want just to ask the speakers to have a slide modifications. So the first presenter will be Michalis Randopoulos from OT Greece, who will provide information about the vertical use case, because Michalis has to leave and come back. And I apologize this in particular to our colleague, Mr. Daniele Porcu, who is the coordinator, but this will not disturb the proper sequence of the presentation. So we pass to presentation 4, please. We will see a dedicated use case relating to a common infrastructure between Greece and Bulgaria. This is not the proper one. Please go to P4. This is not P4. This. Go to the presentations and select the file P4, please. I will not say this for third or fourth time. It was quite clear on my behalf. Okay, and as I said, we prefer the PowerPoint, not the PDF presentation, please. Michalis, the stage is yours. This is the PowerPoint, please? Okay, thank you.
Thank you all for attending this presentation. I'm Michalis Randopoulos. We have prepared this presentation with Ioannis Chochliouros. It is regarding Smart 5 Grid's vertical use case, real-time wide area monitoring between Greece and Bulgaria. We'll give a particularly focus on the creation of a complete testing plan for the developed field platform validation metrics, as we'll explain in more detail later. Okay. The aim of the Smart 5 Grid project is to provide an experimentation environment for third-party developers to implement, verify, and validate energy vertical applications. More particularly, it's about fostering the introduction into the energy vertical market of startups and SMEs. An overview of the real-time wide area monitoring. The scope of use case number 4 is the monitoring of a geographical wide area where cross-border power exchanges take place. This is between the border area of Greece and Bulgaria. There are two critical elements involved in this procedure. We call this a virtual PMU PDC scheme, and more particularly, the phasor measurement units, we call them PMUs, they measure voltage and current phasors in the power grid network and broadcast them at a high granularity to the rest of the elements involved, more particularly to the virtual phasor data concentrator, which is developed in the scope of this project, in a central location, geographically in Sofia, Bulgaria. This is the data gathering process, it's important to notice, that takes place according to C37.244 standard. The motivation of real-time wide area monitoring, we could not omit to say that it has a direct environmental impact, since as we see a higher share of renewable energy sources in the energy production mix, significantly reduce the usage of fossil-dependent conventional power plants. As we all understand, this leads to CO2 emissions reduction. However, there are some concerns raised, since the high penetration of renewable energy sources increases security issues due to their stochastic nature and inverter-based grid connection. We cannot predict really the amount of power produced at every given instance as more and more renewable energy sources are integrated in our system. This causes inter-area frequency oscillations, which potentially can lead to system instability for the whole European network. The scope of our project, generally speaking, large and interconnected power systems are the backbone of the critical infrastructures of our society. And as telecom providers played little or no role so far in this communication infrastructure. We expect this status quo to change drastically in the smart grid era. Fifth-generation communication networks provide the features allowing the power grid to incorporate service requirements of large bandwidth, end-to-end latency, high reliability, and massive connection type. I have to state here that two features are of critical importance, which is the end-to-end latency and the high reliability. We are not so concerned at this stage for the large bandwidth features of the 5G systems. This is an overview of our field implementations, focusing on the call flow paths. There are a few critical elements that should be highlighted in this diagram. First of all, the interconnected systems on the left part. This is in Bulgaria, in Blagoevgrad more particular region. And the other system is at Thessaloniki's IPTO substation. The two PMUs, of course, which gather, collect, and broadcast the measurements from both Thessaloniki and Blagoevgrad towards the rest of the infrastructure. In both cases, for the Greek demo and the Bulgarian demo, the 5G non-standalone public commercially available networks of Cosmotes, which is Greece's primary mobile operator, and Vivacom for the Bulgarian demo are utilized. One can notice easily here that there is a peculiarity, a special challenge, should I say, for the Greek demo, since the measurements are broadcasted towards the edge cloud server in a different country. The measurement starts from Greece and they're broadcasted to Sofia, Bulgaria, where the edge cloud server is hosted. This causes some extra interconnection, may I call them, challenges, which I'll briefly go through them later in the presentation. This is a diagram of the power grid interconnection lines from ENTSO-E. Initially, it was, we were expecting to operate from Lagadas IPTO substation. However, due to many issues such as insufficient 5G network by public network within the time frame of the project, was not available. Therefore, after good collaboration with our colleagues from IPTO, we decided to move to Thessaloniki substations and monitor there the power grid interconnection line. This is, we performed a site survey with at IPTO substation at Thessaloniki. This will give some indication of the challenges imposed, because although by design we were supposed to have sufficient 5G network availability, when we reached the exact location, we had serious issues. We were forced to use an Android device at the top of where the PMU is hosted for to get the optimum signal. However, after investigation, we see that it was not possible to obtain 5G connectivities, but only 4G. There were many discussions with Cosmotes radio access department. They helped us a lot on troubleshooting this issue. We can see that most definitely the signal was obstructed by the pylons and its metallic construction. However, the problem was tackled by speeding up the rollout process of the commercially 5G available Cosmotes network. A brief indication of our installations at IPTO substations. One has to notice the GPS antenna, which provides the time stamping of measurements, later exploited in order to create field platform validation metric 2, as you will see, which depends only on application part. The XyXL router, 5G gateway router, is placed outdoors, as we have been instructed by radio access department. There is a local connection, according to our testing plan for the Bulgarian demo. We have installed a Zabbix monitoring server which at all times produces an ICMP ping response and measures the latency. And the roaming interconnection scenario, according to our testing plan, which involves the international carriers, which causes an additional delay in our broadcast of data. The field platform validation metrics are produced according to the methodology shown in this diagram by decomposition. And there are two important factors considered. The first one is to satisfy the deliverable 2.1 requirements, as we have clearly done at the beginning of the project, and the availability of resources. There is no need to go into much detail for the final list of field platform validation metrics. One has to notice that network latency is of critical importance, and the communication network reliability, it has to reach 5 nines requirements. The first measurements from the roaming scenario, we had a manual intervention which caused problems which have been solved. And the delay of the GRX interconnection network is highlighted in this part of the graph. Last slide is the lessons learned. It's too many people helped us, the construction sections of Cosmote, the packet core implementation section, the provisioning section to provide the testing SIM card for the trial MPNs, and as I have said, the radio access planning and support department. Thank you so much for your patience.
For this presentation, which practically has covered and overviewed in full detail the use case 4 of the Smart 5 Grid project activities. I think it was, even for the non-expert, easy to understand what we are doing, and most importantly, the key performance indicators, the measures you have mentioned, saying that these are closely related to other 5G initiatives coming from the ongoing European issues. Thank you again for this excellent presentation, and now we have in sequence 3 colleagues. We will pass to presentation 3, please, or we will give the stage via remote connection to Mr. Daniele Porcu from Enel, Italy, who is the project coordinator of the Smart 5 Grid effort. Daniele will give us a more detailed view of the actions of the project. So if we are ready, we can realize the connection and invite Mr. Porcu on the stage. I would like to thank him for his kind will to support this action, and Daniele is always at the forefront and supports all the actions of the project, giving the excellent paradigm.
I hope you can see my screen.
Yes,
hear me?
Yes, Daniele, go on.
Okay, thank you so much, and thank you for hosting me in this event. Let's move ahead. After Michalis introduced specifically what the colleagues from OTA, together with IPTO and Infocom Bulgaria and the other partners of the pilots did. Let's see together what are the opportunities for developers offered by our project. Before entering in detail, let me give you an overview on the energy vertical. In this schema diagram, we see the electric power system, how it was like till 20 years ago, more or less, what we all studied in our school book. There is somewhere concentrated power generation, then a transmission system operator, the TSO, that transports the energy from one side to the other, some transforming power plant substations, and then starts the distribution grid till reaching the final users. This system was working, we can assimilate it in an IT language to a waterfall system. So it was working pretty much well till the approach and the arrival of distributed generation. The distribution grid, in particular, was not equipped by any communication equipment because it was too costly for that time. And then it's been like more than 20 years that distributors started to catch up with this, filling this gap. In this schema, we can see the grid, the power grid, in different level. So the transmission power grid, it's covering cross-border many countries. Even if we have different operators in usually it's one per country, the power lines are crossing the borders. And the use case that Michalis just explained is covering this issue of guarantee the stability of the pan-European transmission power grid, while in the medium voltage and low voltage power grid, we see that distributed generation. To manage such a criticality occurred with the arrival of these new actors, a reliable communication grid is needed. Moreover, we have new actors in this system, like the aggregators, that are working remotely, and they are relying only on data. So the communication is very critical, especially when we talk about operation, because we are talking about real-time implementation. So usually everything related to real-time has been done so far with local computing and a connection to a control center. In one word, what is needed for changing from a normal or traditional energy grid to a smart grid is digitalization. But what kind of digitalization are we talking about? So let me see how, till now, more or less, all the actors in the energy industry, including power generation, are using the telecommunication infrastructure. So we have, as I told, a control room, a field site, and in between this black box where some data is entering and some data is reaching the other side, without entering in detail in what the telco infrastructure is doing. And it's a complex infrastructure. Nowadays, with the implementation of 5G, as soon as we will have the core network, for example, we will be able to make a change, because the telco infrastructure is a digital infrastructure. So, in theory, but also practically, we will be able to adjust the telco infrastructure to the need of the vertical. So this is how we used to describe our approach as a 5G-based cloud edge computing. So moving the computational power through the virtualization inside a Mac server, we are able to implement this edge computing. That means that we can merge some part of the computational power to execute our algorithms in the field with some other function to adjust the digital telco infrastructure to our need. How we are doing this? We implemented a platform layer that is actually a platform to support developers in developing and testing network application. We will see later on what a network application is. This platform is interconnected with the virtualization inside the telco layer, where the network application is executed, and the network application itself is bridged between the energy layer and the telco layer. Inside this platform layer, what we have, what do we have? We have a network application open service repository that is acting as a single entry point for the developers who will be able to create a structure of the network application, insert their code inside, and perform a test that consists of automatic validation and verification. So checking if the code is properly structured, and the verification at runtime level if that specific network application is able to be executed in the edge. So, besides defining the network application, modeling and implementation, we also have those powerful tools that are, of course, interconnected to a series of other components to allow us to perform such a testing platform and operating the network application. So, in brief, the network application, it's a way to simplify the 5G complexity. Okay, so let's see inside how a network application descriptor is structured. This is a generic description, so we are here just to give an overview. I'm not entering in technical details, but we see the network application as a chaining of microservices. So I was inserting like a few examples of, for example, virtual field devices. As in the previous presentation, Michalis explained, we virtualized a field device that is able to perform some activities connected with the field devices. We can virtualize automation algorithms and other stuffs, together with, for example, some advanced routing algorithm, or as the core network will be available, a slice manager, for example. So there are pieces or components that I'm able to implement because it's my business core. Like I'm, for example, an expert on field devices. I can virtualize that field devices, but I don't know how to build a slice manager. In this sense, the idea is to foster a cooperation or a future creation of a market of components, so that I will be able to find a slice manager or the best ever slice manager without entering inside the problem. So I can focus in my core development and combine them with some other better performing components that supports me in the realization of this network application that, again, bridges the needs of the vertical with the opportunity of interact with the telco infrastructure. And then inside the descriptor, we can have computational requirements, communicational requirements, and also other requirements, or for example, a series of tests to be performed by the application. Okay. So what are the key features of the network application? We can see again fostering the integration of the core network features. I'm not mentioning Camara, for example, but the telcos and the vendors are working together to standardize the API. So network applications are going in that direction. So on one hand, we are simplifying the 5G complexity and allowing to focus, as I mentioned, on the core development, but are also giving the opportunity of combining multiple microservices to realize more complex applications. Then comes the orchestration and operation. We will see later on my colleague Nicola from Nearby Computing will explain the centralized management, and the topic is that this paradigm it's fostering scalability and replicability. For example, next presentation will be from my colleagues from Entra Energy. They own a power plant, and they implemented a network application to monitor distributed generation. So the day when the owner of this company will decide to purchase a new power plant, they just need to purchase some simple device to interconnect the power plant with the 5G infrastructure, replicate the application, and that's it. So scalability and replicability of the same experience is more fast done by a new pile of servers to be installed on field, and also new pile of server to be installed in the control room. And then leveraging on a flexible infrastructure, because compared to optical fiber, it's a new dimension. Okay, and then accelerated implementation. So as I mentioned, the open service repository and the integrated validation and verification feature will support the developers in focusing on their development. Besides the Greek and Bulgarian demo, what we see together with Michalis, and the Bulgarian demo about distributed generation management and the predictive maintenance that we will see in the next presentation, we also developed an IP monitoring tool for smart grids integrated in Italy, where this network application is supported the advanced grid automation, that it's able to identify, isolate, and repower a portion, the portion of grid in less than 1 second. So you can imagine a series of devices that has to interact without energy in less than 1 second. So in millisecond time, they have to find a way how to solve the issue in the grid. In Spain, we implemented actually, because all the pilots are working, and all the pilots are in real grid using a real infrastructure of telecommunication. In Spain, we implemented real-time safety monitoring for operators working in a primary substation. So again, these 4 pilots are an example on how to use a network application in real implementation, but this is not the only way how to use network application, and we are opening our testbeds for everybody who wants to use our platform to build their own network application. So the opportunity here is to build and test your own network application using our platform, and we have a series of tools, as I've described before, OSR and VMV, together with a contact desk that we already implemented to perform our to support the developers who have problems with whatever issue with the implementation. So let me ask you to join our group, our community, and have the instruction on how to reach the platform follow us on the socials, because we need all your support, and please spread around the messages. The project, as a general overview, will end in April 2024. We are covering 7 United States, European countries, and we are implemented, as I mentioned, 4 demos. And last but not least, let me give a big thank you to all our partners in the consortium. As you see, more than half of them are SMEs, but we have 2 energy distribution operators, 2 transmission system operators, 3 telco operators, so infrastructure owners, 3 research institutions, 3 technological companies as a big players, but together with a smaller company like my colleagues today, Entra Energy, that it's operating and working in renewable, and Nearby Computing, who are expert in orchestration. We will see their amazing tool that has been adapted to host our network application. So thank you everybody for your attention, and don't hesitate to contact me or contact us as a project for any doubts.
Thank you so much, Daniele, for this excellent presentation.
Thank you, Ioannis.
That has given us the layout of the project, the expectations, correlation. You have mentioned everything. The use cases, the objectives, why it is beneficial for the market, why we invite partners, what we offer. I think this is an important view for this important project, because this is among the few ones correlating 5G with the smart energy grid, and brings together the energy and the telecoms market. Thank you again. Thank you so much.
Thank you. Thank you all. Thank you.
We will pass now to the next speaker, Mrs. Ralitsa Rumenova from Entra Energy in Bulgaria. I hope Ralitsa is with us.
Yes, hello.
Okay, Ralitsa, thank you for joining. Nice to see you. And we are looking forward to hearing your presentation, which is about use case 3, the Bulgarian demo. Thank you for joining.
Thank you for the invitation, and welcome. Hello, everyone. I'm just waiting for my presentation to load. Okay, in the meantime, I can present myself. My name is Ralitsa Rumenova. I work for Entra Energy. Entra Energy is an SME company that acts in the renewable area field. We own and operate 4 megawatt wind turbine park and a small hydropower plant. But our main focus is within the digitalization and transformation of the energy sector. And we develop some hardware solutions and IoT, machine learning and artificial intelligence based devices and platforms that facilitate the digitalization of the energy sector, monitoring, controlling, and exchange of some flexibility services. I can't see my presentation. Is it loaded? No. Can you hear me? Hello?
You already have the presentation. Is the one provided you as presentation 5? Ralitsa, will you share it or we can upload the presentation and you can comment, but normally you can put on the bottom of your screen the share button, and normally you can see your presentation. If it is a problem, we can upload the one you send us and...
Okay, you want me to share it? Is it that?
Yes, if possible. Because
okay.
I don't know if we have an updated version or any...
Okay, okay. Okay, give me them.
If it is difficult for you, just right now, for the sake of the economy, we can upload this and you can comment.
Okay. I didn't realize that we need. Yeah. Okay. Can you see my presentation now?
Yes.
Yeah. Okay. Does it run on slideshow? Yeah. Okay. Okay, I got it there. And today I'll be presenting use case.
Can you pass to full screen? If you
Say, excuse me?
You can select full screen option.
A full screen. I haven't. Wait a second. I think I did.
Really, it's Daniele speaking. Maybe you could remove the sharing and restart from after you start the presentation and share the presentation screen.
Okay. So yeah, let me just do that.
It's nice that we have this accident live. It's as normally.
Okay, so it's a new share. Then I'm sharing. Okay, wait a second. Wait a second. Okay. Is it better now? No.
Yes, you can.
Yes.
Okay. So sorry about the technicalities. So I'm going to present the use case 3, which is a millisecond level precise distribution generation monitoring and control application. That, as Daniele has mentioned, deals with monitoring of distributed energy resource assets. Before going into detail about the application, I want to just touch upon the challenges that we try to address with the application that we are demonstrating under use case 3 under Smart 5 Grid project. So as Daniele mentioned, the energy sector is transforming on a fast pace, moving from centralized to decentralized, democratized, but this means volatile because of the highly increasing share of renewable resources, energy production developed by renewable sources, having both ends of the energy sector changing. On one hand, we have the production coming from renewables that are more and more in terms of number and smaller in terms of size. They are democratized, not only geographically spread, but they sometimes are owned by some non-professionals. So we have a huge change on the production side. But on the other side, the consumption side is also changing. Having some industries going electrified, like transportation, industry 4.0, etc., etc. We have some of the consumers building some renewable capacity, becoming prosumers. So all these changes make the sector more democratized, with a lot of roles changed, but put an enormous pressure on the grid operators, for example, and not only, to be able to forecast and manage and control the grid. So, in short, what is needed for the transformation to happen in a controlled manner is increased visibility of what's going on the network, increased predictability, thus controllability over the grid, for balancing, for congestion management. On the production side, and specifically speaking about the renewable energy assets, we need to have increased availability, improved operational excellence, And all this is done by digitalization of the energy sector. But so the change is driven by the advancement of the technology advancement, like IoT, like machine learning, like artificial intelligence, etc. But this puts some how to say, stress on the compatibility, on the security, and we need to find a solution that is both scalable, secure, compatible, smart enough, and at the same time costly, cost-wise reasonable, so that to help this democratization happens. So in short, what would be the first steps? So the first steps toward this happening is to get the players connected in a secure and scalable manner, because it's going big, and to gain, as a very first step, visibility on what's going on these parts of the grid. And this is what actually the millisecond level precise distributed energy resource monitoring network application is doing, the one that we demonstrate in use case 3. So what we do is we demonstrate a network application that runs over 5G for real-time monitoring of renewable assets. We developed the application so that it covers and demonstrates how different kind of resources, energy produced from different kind of resources, could be monitored. So we have the wind park, that is the main case demonstrated in the monitoring application. We had a hydropower plant, that is actual hydropower plant that is monitored through this application. And we demonstrate how this could be done for a photovoltaic park, running some real data that are simulated. So we have real-time monitoring with millisecond level delay of the communication. We have the multi-technology devices and system support. And I'm going to show you in the next slide how the overall infrastructure is. So we monitor different performance parameters like electrical, reduced power, etc., environmental and technical. And we support multiple users. Currently, it is the asset owner and the grid operator, but on further step, we can have, for example, the support team, third parties. And at the end, which is last but not least, we develop and demonstrate an innovative 5G solution, because getting all these devices connected and working securely and smoothly over 5G is a challenge. And actually, this is the solution architecture. What you can see is at the bottom, we have the energy infrastructure. So we have a set of signals that we collect from the wind farm, SCADA system. But as I said, we have multiple system and devices support. So apart from the SCADA signals, we have installed some additional IoT-based sensors, like variable sensor, for example. Speaking about hydropower plant, this could be some other sensors that are outside of the premises of the hydropower plant, like some sensors for humidity, for rain collection, for the level of the river, etc. So the solution is innovative because it gathers the signals from different kind of sources, devices, and technologies. So this signal list is collected and is communicated over an IoT device that creates something like a digital replication of all the collected signals, and through a 5G modem makes a private APN connection to the mobile networks architecture and cloud. In this case, it's Infocom, Bulgarian telecom operator, that provides the 5G infrastructure and all the knowledge and technologies behind. So the application runs on the cloud. It is deployed and connected with all the elements of the smart 5G grid infrastructure that are actually making, as Daniele mentioned, the virtualization of the telco layer. So it makes possible for this particular application and some similar applications to run and take all the advantages of the 5G infrastructure. And at the end, least but not last, the different customers, in our case, it is us, the asset owner, and the grid operator, that is the system operator in Bulgaria, have access to this monitoring application so that they can see in real time what's happening. So the monitoring application has been enhanced. So apart from just getting the signals and make them visualized, it has developed some simplified alarm functionality. As Daniele also mentioned, we developed an additional virtual function on the same application that acts as a predictive maintenance enabler. In addition to allow some third-party sources like, for example, I don't know, battery management system or any kind of other type of distributed energy resource to be connected and use the infrastructure and the application that has been already developed. We created as an additional virtual network function the MQTT broker that makes it easier for different streams and IoT devices to connect and get visualized by the application. But all this that we have developed really proves and finds the way on how such solution could be connected over 5G. And it wasn't easy because just getting IoT device connected over 5G took us many attempts, a lot of research, etc. We went through many devices, finally choosing the one that will both work as a connection, as an opportunity to create the private APN and being secure enough. But to be honest, this application could run over 4G and deliver the same value. When the value for 4G is actually demonstrated and really needed is when it comes to either scale of this solution, when it comes to having a lot of devices or a lot of assets connected like this, some of them located in a very busy area where when a lot of other connections are happening over the 5G network. So we need the 5G functionalities to secure the needed level of service, etc., etc. Or in case it comes to some critical energy infrastructure. And when it comes to the energy sector, critical infrastructure is very often the case. So in order to demonstrate the actual need and the very need of the 5G, we have developed, well, actually, University of Cyprus has developed an enhanced control application that showcases in a hardware-in-the-loop demonstration controlling functionality. So this is a schematic of the hardware infrastructure. So in order to demonstrate this control application for coordinating the fast frequency support by distributed energy resources, you see why I developed this scenario. The scope was to compare if there is an impact of the type of the mobile connection, 3G, 4G, and 5G, chosen for this type of application. So because this approach is very invasive, it couldn't be demonstrated in real life. That's why UCY created this solution that demonstrates advanced test-bed infrastructure consisting of digital twin of a power plant system, including distributed energy resources, participating in a wide area control service. Also a hardware network emulator, which replicates at macroscopic behavior of the communication infrastructure, such as 3G, 4G, and 5G, and a hardware controller which actually implement the wide area control service. Specifically, and these are the results, benchmarking for the power system's stability, considering different communication responses, it was shown that 3G is inadequate to support the wide area control schemes, and 4G can only provide marginal improvement. 4G is actually, marginal improvement for the grid stability compared to the baseline, which is no frequency support. However, significant improvement can be achieved when 5G communication is involved. And as you see, we have the improved stability in frequency by 77% versus the baseline and by 69% versus the state of the art, which is the droop and virtual inertia scenario. So, in conclusion, the energy sector is transforming on a high speed, and it really changes the roles of the players, the technologies that are used, and the way the overall sector is actually performing. What, in order to have the smart 5 grid in the future that works efficiently, securely, stably, etc., we need to find a solution that is scalable, cost-effective, and compatible with the current technologies and infrastructure that has been built, that guarantee the needed priority and security of the critical infrastructure and operation, and that is scalable and cost-effective enough so that to make possible for the different and multiple players, like distributed energy resources, to be connected, visualized, monitored on a further stage, forecasted and controlled, and to be able to being connected and having information about the actual status of the resource is a must-have element so that these players can contribute to some flexibility exchange in the future, for example. So this is what we try to demonstrate. So it is very simplified, but as Daniela has mentioned, the application that we have, the very first step towards monitoring such kind of resources, it's really easily replicable, because one needs just to take the application, install the needed equipment that is very that is not costly at all because it's IoT based. Start collecting some information from the newly joined asset, and the solution is done. So again, I join my colleagues in the invitation to join us, follow us, because we have a lot more to come. Thank you very much. I hope I fit into the time slot.
Thank you very much, Danica, for your presentation. You have provided a good overview, a detailed overview of the Bulgarian use case, which is quite important, especially regarding the use of renewable energy sources. I would like now to invite the next speaker, Dr. Nicola Cadenelli from Nearby Computing, for the final presentation regarding this Smart 5 Grid dedicated session. One favor, Nicola, if you can be within the prescribed time slot of 15 minutes, you will facilitate us for the proper running of the project. So, Nicola, the stage is yours.
Thank you. Good morning, everyone. I cannot share, by the way. It says it's disabled. Because someone else, Ralitza, is still presenting. Can we?
I think I've stopped sharing. Wait a second, just a second. Okay, here we are. Okay.
All right. Okay, good morning, everyone. So I'm Nicola Cadenelli. I'm a senior solution architect at Nearby Computing. We are a company that provides and offers a product which is called Nearby One, and it is an automation and an orchestration system. And in this presentation, I will see why this kind of tool is needed for the smart grids, and how it was, how it fit into the context of smart 5 grid. So the motivation of the project of Smart 5 Grid was, well, as we saw from my colleagues, there is a paradigm shift. There are new challenges on the communication network, but also the grid itself, the energy grid itself is evolving. And the companies are going to need new tools to monitor, operate, and add extra services in the smart grid. But this poses a new problem, because now we have two worlds, the telco worlds and the power grid, that are coming together, plus independent software vendors. And how are you going to manage all these services together? You're going to need a tool so that you can manage the infrastructure and the status of the services as well. And the kind of services also is different. So one use case, in particular, the Smart 5 Grid ones, is about smart substation, adding new services like real-time monitoring of the area, because you can add now cameras and you can monitor the workers at the substations and so on, or what Ralitza just explained. And we saw how all that is interconnected with the 5G infrastructure. So you have these network applications that are interplaying with the UPF and the core and everything else. So it really becomes complex from someone that has to monitor and operate. And there is the fear of who is going to control that, who is going to help us to control that. Another use case is the virtualized substation. So again, these are services that you are putting inside the substation. This is software services that you have to orchestrate at the micro level to have performance in a real-time fashion. This is like really 2 milliseconds, real time, and there's an hour deadline. Otherwise, the system goes down, and you have to react. But at the same time, you are also playing a game with the 5G core and the 5G network. So how do you operate, and how does it look like from a central point of view? So from a central point of view, we could call it digital substation, so virtualized and smart. And the way it looks like is something like a tree, where you have usually the central controller room of the operators. And here the operators might be the telco operators, it might be the power operator, and the power operator might have their own private network, right? So the two worlds now have completely overlapped, because you have the operator that operates the network, the power network, but also the communication network. And you have infrastructure, as we saw in the previous presentations, that is spread around the countries, because you have to operate the power grid, which is spread, and you have devices, and you now have multiple kinds of services. So it really becomes complex. And what we do, our product, is a tool that allows you to operate the infrastructure and to am I still sharing? Okay. So you can operate the infrastructure, but also the services. Someone is... Can you see the screen or not? Hello?
Now, yes.
Yeah. Okay. But someone is removing me. Now, no, right?
No, you're still presenting.
I'm still presenting? Okay. Sorry. So as I was saying, you now have a tool that you can measure, you can monitor the infrastructure, so the hardware, You can monitor the network functions, so the UPFs and the core and the radio, but also the applications that you are deploying, alongside, and they are distributed. And this application, by the way, most of the time they have a component which is at the edge, but also they have components in the cloud most of the time to maybe store data in a data lake and do post-processing in a different time. Or it can be the corporate data center, because you don't want to go on the public clouds for whatever reasons. So you really need these new tools to be able to see, to offer you a view of the full picture. So the tool was adapted for the Smart 5 Grid project. It was adapted so that it can orchestrate and manage this concept of network application. And but the view, the UI itself is the usual one. So what you have is now you have this network app controller that allows you to show the infrastructure of the use cases, as you can see here, both in Italy and in Bulgaria. So this is one instance of the tool that was running in AWS in Ireland. But at the same time, we were monitoring the infrastructure, so some Kubernetes clusters in Bulgaria and some in Sardinia, and all from one tool, right? So you can check the status, and you can see if the node goes down. You can trigger alerts and so on. And obviously, you can monitor the status of the network application. You can see the logs and everything that is related to the application itself. Regarding monitoring, you can also extend it so that you can actually do trigger events and basically fire alarms when something goes wrong, because this is very crucial in running operations that are, for example, the smart grid. So you can extend it by adding observability with other tools like the usual Prometheus and Grafana, so that people can add on top of that, can do analytics and so on. And the tool allows you to do all this, but at the same time, as I was saying, is connected to the Smart 5 Grid system, so that can interact with the validation and the verification process of the application. So not only it helps you to manage things in production, but also it allows the developers to do the testing, and actually, we have a platform where you can push the network application. The network application is tested and validated all together. Finally, the tool is touching many technologies, because when you go to the infrastructure, you usually, the company already have their own infrastructure, and they don't want to change an infrastructure just because now there is a new tool, or just because there is some software. So the tool is vendor agnostic and can manage applications on top of a variety of hardware and software vendors. And we have an open model that you can extend the APIs. And this is exactly what we've done with the Smart 5 Grid. We created a plugin for the application, for the tool, so that it can actually understand the grammar of this network application and manage them and report back their status. So I think I can conclude this way. I was quicker than expected, but I think that is fine, right? Because we are a bit late. So that's it from my side.
Thank you, Nicola, for this presentation. So we have completed the session dedicated to the Smart 5 Grid project. I would like to express my thanks again to all four presenters. In particular, Daniele Porcu from Enel, as the coordinator, has given the full layout, the full scope, and the intended actions of the project. And
thank you,
we have seen, thank you, Daniele. You always support and you always give the good example, at least among the partners of the project, and I do appreciate this. We have seen two use cases, one in Bulgaria, presented by Rarica Rumenova, and one in between Greece and Bulgaria, presented by my colleague Michalis Rantopoulos. And we have seen via Nicola's presentation the importance of orchestration and automation platforms for the smart grids. For the sake of flexibility of time, because the program is strict, we do not have the possibility to start the discussion. However, and this will be the case for all sessions, everyone who may want to ask for anything or set a question, he or she is free to do so and send us either to the presenter directly or to my attention any comment, any question. We will collect all these and take care in order to provide feedback to the partners. Thanks again for this Smart 5 Grid session, and we are still in time, I suppose, unless Christos, you want 5 seconds as a short break, so we will pass to the next session in 5 minutes from now, which will be about the Datamite European project. And okay, by the way, I would like to express my profound thanks to Dr. Christos Gizelis for his support. He's always present in the scope of Infocom events with dedicated sessions with detailed presentations. And I feel that in 5 minutes we will all have the opportunity to hear about this new challenging project. So Christos will be the moderator, but let us have a 5 minutes short break.
Hello, good afternoon. My name is Christos Gizelis. I'm Principal Innovation Analyst at OT Group, and more precisely at the IT Innovation Center of the group. On behalf of Datamite, I would like to welcome all of you in this session. Special thanks to my colleague, Mr. Yannis Koklouros, for organizing this session and giving us a floor to present our achievements. Of course, I would like to thank the event organizers, Infocom, and Mr. Nostis. Let me say a few things about data to reveal to you a discussion I had last week with a colleague from Datamite. He reminded me a famous quote of a movie. It was a movie with Tom Cruise. And the quote was, "Show me the money." This was actually, and still is, a question that a data provider will ask. Show me the money. He needs to know where is the money in data being an asset. Data can be sold or shared or offered not only directly, but indirectly. And what I mean by that, before any organization moves forward and share its data, the best approach is to create services based on data. Most of all, to get the benefit of its own data, get insights of the benefit that, that his organization already has. But enough about the data story. Let me introduce you the speaker of this session, starting by the project manager, Mr. Santiago Cáceres from ITI Spain, Ms. Vaso Apostolopoulou from OT, and Savas Manikas from HEDNO, and finally, Mr. Savas Siopidis from CERT. In this session, we will have a blend of business and technical presentations. We designed it like this in order to get better insights of what Datamite is about. So that's it for me. Thank you all. And Santiago, if you can listen us, the floor is yours.
Yeah, I can listen to you, Christos. Thank you very much for the nice introduction. And thank you for inviting us to this event and to have the opportunity to present the project and our outcomes here. So I'm going to share my screen. A second. Okay. So I think you can see now my screen. Okay, so my name is Santiago Cáceres. I work in ITI, which is a research center in Spain based on all technologies around the data. I am project manager and I am the project coordinator of Datamite. So in this first presentation, I'm going to introduce you the project and why we are working on data monetization, how is our proposed solution, so our contributions there. And I will briefly go into some details of the framework that we're going to create and on the pilots that you are going to listen later on. Okay, so let's start and talking about data accumulation. So I don't know if you have smartwatches. I do have, and this records lots of data about you. So you can check the number of steps you make during the day. They check your heart ratio. They extract lots of figures and lots of nice graphics of your activity. But I don't know if this happens to you, but at the end of the day, you don't know how to use this information or how to extract value out of it, okay? Because sometimes I check the steps I have made and I say, well, I have to do more. But for the rest of the graphics, I simply do not take a look. So each one of us is generating lots of amounts of data, and sometimes it's really hard to extract value out of it. If we look a more broader picture over the internet, so this is the number of information or the amount of information generated every minute of the day on the internet, and the numbers are really overwhelming. So this happens at personal level. This happens in the world in general, and it is not the exception of the companies. So companies stores lots of data, organizations stores lots of data, but what we have seen is that even if we have more data available than ever before, there are still some things that we have to consider. First, studies show that up to 95% of the organizations suffer from the data decision gap. That means that they cannot relate on data to make accurate decisions. That's 95% of the organizations. Only 32 of them, of the European companies, can realize tangible and measurable value from data. And similarly, reports state that between 60 and 73% of data is never used for analytics. They never use analytics for their day-to-day activities. And last but not least, and similarly, poor quality data is estimated to be costing companies around 10–30% of their revenues. So that's quite a lot of money if we think in a European dimension. So we believe that the impact is high, and companies are losing the opportunity to get a better understanding of, for example, their customers or make better pricing decisions because of all of this. Okay. So yeah, summing up, data accumulation is only enough if data has value and can be valued. So we may have big data lakes with our organizations, but if we don't know how to manage this and how to extract value out of it, it serves nothing at the end. And we have observed that the capacity of companies to monetize data is connected to the trust you have in your data. So if this is reliable or not, and the quality features of the data. So in this context is where Datamite borns and stands. And if I have to make a summary of what the project is about in just a few lines, so I would say that the final aim of Datamite is to help EU organizations to better govern and monetize their data, so they can take better decisions and take value out of their databases and the data sets. So how we are going to achieve this? Well, we are providing something to the community And the main thing is to deliver a modular open source framework to boost monetization. This is composed by both software tools, I'm talking of software tools, web applications, but also some materials to help the decision makers in the organizations to carry out their task. So one of these is, for example, the research on business models strategies for data monetization and the approaches for the quantification of data value. So putting a value to your data is nothing trivial, but very complex. So we are doing some research in the project about this. And last but not least, we plan to provide models, indicators, and especially training materials to upskill personnel. So not all in life is technology. You have to have the right people with the right skills in place to take value out of the money. So we are putting these training materials there to upspeed things, okay? So some metadata about the project. This is a 3-year project. We are starting this year, January, so we will be running 2 more years. It's quite a big project with a 12 million euros budget, more than 1,400 person months, and 26 organizations. So you have here the organizations that the project is led by ITI, and we have a complementary set of organizations with very different skills to have all the knowledge in one place, in one team. Okay. So to give you more information about how this is going to work at the end, I think the best is to show you a little bit what is the DataMite framework, what are the modules that we are designing and we are developing. So I would say that DataMite framework is something that the organizations can take and can use. And first of all, it will not interfere in their current storage mechanisms, in their data sets, in the way they are structuring information. So thinking on our organization A, for example, that we have here, so they have the current storage system with all these data sets and so on, but they want to extract more value out of it. So I will go module to module, just showing up the high-level features in each one of the modules that they can deploy within their institutions to extract benefit. First of all, is what we call the DataMite data governance. So with this module, they can create a catalog of their data sets that will include also a data glossary and dictionary. And they will be able to create also a metadata repository with lots of information that they can use about this data. Also, it will provide some features of data lineage. So the organization A will be able to track and visualize their data in a very easy way. Okay. The second module is the data quality module. This basically what it does is to take some samples of the data sets that are in the catalog and execute the evaluation of a set of KPIs. And these KPIs include generic ones. So some of them that are related to the data. So they can say, well, your data is completely crap because it has lots of whites, it's corrupted and whatever, or can say it's fantastic, but only generic, or it can be even domain specific. So if we are in the energy sector, for example, they can check based on the input of the people who is in charge in the organization of setting up these KPIs, if the data makes sense or not based on the business knowledge that the operator may have. Okay. Then we have the data support tools, which is a set of tools that complements the rest of the modules. And here we have a very heterogeneous set of tools in place, just to give you a flavor of the things that are there. So we have a metadata harmonization tool, for example, data discovery connectors, or even data bias detection tool, among others. Of course, we have a layer of security. This is a range of security-related functionalities like access control, authentication, authorization, roles management, etc. Everything comes with user interface, so you can select only the modules that you want to use, and you will always get a user-friendly user interface. Okay. And then we move to the data sharing. So all these components are mostly to be used at internal level within the organizations. For the data sharing module, what we want is to communicate with the outside world, with the outside data community. So in this case, what it does is it's for the different organizations that use this data sharing module, they will have a way to publish data, retrieve data from the most common EU portals and data markets, like for example, it's Gaia X, AI on demand, etc. Additionally, it will act like it's a clearinghouse, if you are familiar with the ITSA architecture model, where all the logs related to data flows are stored there. And of course, it will ensure the data sovereignty of the data. So it will enforce all the policies where the data owner can say who can access, for what time, for which purpose, etc. So this will be the technical part of the DataMite framework with all the modules that we are offering. But this is not only about technical. We will be also offering training material based on the tools that will serve to upskill personnel within the organization. And we also plan to publish all the business model strategies that we are researching now within the project, and this will come by the end of the project. Okay. So all these technologies are going to be tested and assessed in different use cases. We have 3 different use cases and 6 pilots. The first one is the data exchange within large corporations, where you have normally a group of companies with different databases, with different offices, different servers, etc. So how can this framework work there? How can they help them? So today, after my presentation, Baso will present the pilot 2, the one of OTE, the intracorporate data exchange in telecom. So we'll have details there. The second use case is the energy data spaces, where we can see the particularities of the energy sector. So this is a very particular way where there's huge amount of information being stored. And my colleague Sabas will present the pilot 3, offering data to service providers with data spaces. And last but not least, the last use case is the interaction with other initiative, where the focus here is to communicate with different data markets. In this case, it's connecting Edwin to data markets, to the different data markets that are relevant to them, and also connecting Mistral, which is a weather forecast platform, Italian, to the EU on-demand platform. So with this, I finish this brief presentation of DataMite. You have here my contact details, and also I invite you to follow us in all the social networks that we are present. So thank you very much. I think I stick to the time, Christos.
Santiago, as you all have seen, Santiago presented 6 pilot use cases in different sectors, different verticals. You can understand that data is everywhere. And to sum up what Santiago present to you, DataMite not only creates the tools for all organizations to prepare their data for monetization, but also offers a strategy that they can follow. Let's now hear Vaso Apostolopoulou, my colleague from IT Innovation Center of OTE, to describe you our pilot use case, an intra-corporate data exchange. Vaso, please.
Thank you, Christos. So, ladies and gentlemen, very happy to see you all today. Please allow me to quickly introduce myself. My name is Vaso Apostolopoulou. I have a background in business administration and data analytics, and I'm an innovation engineer at OT Group. So let's see some facts about the OT Group. So we are a subsidiary of Deutsche Telekom. We are an organization with more than 11,000 employees, and the OT Group has numerous subsidiaries, as you can see, with separate data lakes communicating to each other, and somewhere in that landscape, the form of our pilot is taking shape. So let's examine the current data landscape. We have a situation that each subsidiary usually acts independently, and they have multiple systems to communicate between them. These systems do not communicate to each other. They're not in a unified storage system, so this creates a big challenge to us. The challenges are that it is complex and fragmented data landscape, and creates an increased need to combine the data across the organization. While combining data, we are complying to the privacy and security standards, of course, which is a very complex process. And also the data exchange is very lengthy in time, which is making the structure and the resource demanding in financial. Moving on, we can see the pilot that we have as an OT group and how Datamind aims to solve these problems. So going from the bottom to the top, we can go from the technical side with the security to start with, which has the access controls and the monitoring that are implemented across all systems. We have the privacy, which is demanding the increased data hops. We have the quality, which means the data quality and the reactive checks, the semantic interoperability, the different sources that have different models, which we have to handle. We have the governance, which makes difficulty to identify the data owner for each case. And on the top, we have the business, which has the usage of combining the data from different sources and different granularity that is not very straightforward. So let's see how this pilot can support what we want to do with our data. Again, going from the bottom, in terms of security, Datamind aims to have a uniform and fine-grained and rule-based security control. In the privacy sector, we have a dynamic anonymization and de-anonymization. In the quality, the global point to define the data quality rules. In semantic interoperability, the Datamind helps to have a unique data model across the organization. For the governance, the metadata is located in a centralized repository, making it easier for interoperability. And in usage, for the business owners, we have the ability of the data to create it straight from the freshness of the data itself. So to sum up, what this pilot can help OT. First of all, the intra-corporate data exchange between different subsidiaries of OTA Group can enable the combination of information in numerous data sources. We are aligned with organizational privacy and security standards for data governance. We operate on production in an efficient way, and we can support the BAU and ad hoc needs of the users. So the roles that have been identified for our pilot's needs, and some of these roles have been modified because we are doing with a complexity in the environment that we have as a telecom sector. So let's give some emphasis on the first three, having the data owner as a business user, who is responsible for the data set that is providing, authorizing that data sets will be shaped to whom and for how long. For the data consumer, the business user, who is the user who will have the access to the data to use the data for the business-related tasks. The data provider, who is responsible to prepare, make available, and integrate the data. The system administration, who is responsible for the operation, management, and maintenance of the installed Datamind instance. The security and privacy responsible people, and the data governance responsible, who develops, consults, monitors, and has the data quality checks. Moving on, we can see in a high level the user stories. Beginning with the first one being the sharing policies. So the Datamind aims to define which data sets will be shared to whom and for how long. We have the authorization and the authentication of the users. We capture and monitor the usage of the data by consumers. And we are having the alerts for suspicious behavior, which is very important to us. Moving forward to the governed data. We capture all related information concerning the metadata. We centralize the metadata in a data catalog, and we are enabling the interaction to share or capture the update with external systems. For this, Vasilis Siopidis will tell us more, who is the main architect of the project. And moving on to the data quality, this pilot aims to define the key data elements It tracks the quality of the data at each phase. It monitors the quality of information through the reports, and it informs the users for the data quality issues, improving the data reliability and their reusability. So let's see what we desire as an utmost goal from the data mine. First of all, we want to share across different data repositories of the organization, both on non-sensitive and sensitive data. The consumers use reliable data that are ready to be consumed, covering freshness and data synchronization aspects of the information. The consumer can develop the solution based on reliable data using a solution that handles privacy-related aspects seamlessly and effectively. We can monitor and control the access, enabling reviewing them and which type of the data has to be accessed. The users can understand and utilize the data through a unified data model with a common data catalog. And we can minimize the time to market using quickly integrated and accurate information. So thank you very much. And back to you, Christos.
Thank you, Vaso. As you could see, the telecom use case was quite challenging. And by the help of the partners in DataMind, the tools that will be created, the strategies that will be created, we believe that will be capable to lead in the future the monetization. Not only telecom have data, also energy sector. So I would like to call to the stand my colleague, Mr. Savas Manikas from HEDNO, to present the pilot in the energy sector. Savas?
Thank you, Christos. Hello, everybody. So, I'm from the data management department of HEDNO, and I'm going to present you pilot 2 of DataSpace. We're leading this pilot in close collaboration with our partner CERT. Vasilis is going to present later from CERT. A few words about the electric power systems so that we can follow the presentation. Some years ago, a decade ago, the public power company, PPC, was doing everything, but nowadays the electric power system is quite complex with a lot of stakeholders. We have a lot of key players in the power generations, and but we have a unique transmission system operator. That's the blue. So it's mainly everything that has to do with the high voltage transmission. And we from the DSO, from HEDNO, are responsible for maintaining and operating the green part, which is the medium voltage and low voltage network. For our Greek audience, it was the E, now it's ADMIE and the DIE, so to be more familiar names. Some other key players. It's the Regulatory Authority for Waste, Energy and Water, which regulates everything that has to do with energy. I'm mentioning a few things about HEDNO. We have 5 regional departments for operating the 5 different regions that you see on the map, and our main responsibility is the maintenance, the development and the operation of the medium and low voltage network in the whole of Greece. The network consists of about 250,000 kilometers. We have more than 5,500 employees and about the same number of external contractors. And we have more than 7.5 million users, mainly in the low voltage and a few thousands in the medium voltage network. Yes. Okay, thank you, Christos. But except for these key players, the scene is even more complex, and you can see that data has to be exchanged not only between retailers, traders, there are also equipment manufacturers, R&D, performers, financial institutions, different policymakers. So there is a lot of need to exchange data between all of the stakeholders, and that's why data might is for us so important. In the frame of the pilot, we will be acting, we are the distribution system operator, and we will be sharing data with an energy service provider, in this case, CERF, which is also our technical partner, to form a use case scenario. The data sources, as we mentioned, we have a lot of data and a lot of clients. They're coming in this pilot. The data sources are coming from three different data sets. Mainly, at first, we have to share a part of the network. So we will be sharing the network diagram with all the details, all the electric characteristics of the lines, the electrical equipment, in a power factory model. And after our partner models this, has available the model, we have to provide him the operational data. We will be extracting this from the SCADA, from the SCADA systems, where the main state variables of the networks, like reactive power, active power, current, voltage of all the medium voltage lines is being constantly monitored. And we also will be sharing data about consumption and production of our producers or consumers in the medium voltage, in this specific medium voltage lines. We have a telemetering center that collects every night data of about 100,000 medium voltage clients and the biggest of the low voltage clients, collecting the energy and power curves of these clients. All of this, so as you see, on the left, we will be extracting data from these three production systems. Probably some of the data mine modules are going to be implemented inside the internal company network for safety and because of security policy reasons, because the data of the consumers and the productions are sensitive data and have to be anonymized before they will be shared for research purposes. A dedicated virtual machine where the data to be shared will be stored. The data mine modules mentioned earlier by Santiago that are going to be used are going to be installed there. And we're going to share our data through Data Cellar. That's the aim of the project. Data Cellar is an IDSA data space with its own data log, where our data will be being along with our with the metadata will be made available. It will be findable by every interested party in the energy sector. So data clients through the Data Cellar are going to have access to our data as we're going to be the data provider. So that's the basic pilot architecture that you're seeing here. We provide data through Data Cellar. CERF is taking this data and it runs simulation, proposes improvement, solution, makes forecasts based on this data, and that's the energy service that it actually, that's of the importance of us. More specifically, CERT was going to develop in the frame of this pilot 3 different tools. Let's talk about the first one. It will be a tool that will give a solution of optimal sizing and siting of renewable energy sources, EV chargers, battery storage systems, with the aim to decrease the network's total energy and the network's congestion in the duration of a day. Also, some other tasks like that are going to be performed. And as you see, these are quite complex tasks. It's not that we're going to just to share a table of, let's say, the consumption of some clients. It's the data sets that are going to be shared for this reason are quite complex, because we're using totally different data sources, and we have to combine probably in a data product that's going to be provided as such to the data consumers in order for them to make these complex simulations and run their AI algorithms to provide some service of interest to us or to other energy stakeholders. So the benefits, by just summing up, the benefits that we have by sharing our data in a data space like Data Cellar is that our data is findable, and it's being accompanied by metadata that makes this data usable by potentially every data consumer out there without that's prior unknown to us. The case until now is that somebody asks data for us for a specific purpose. We have a personal discussion with them, so we can provide and exactly know what he really needs. But in the frame of this data sharing mechanisms, this will be more impersonal, and data has to be accompanied by metadata that give the potential users the ability to make use of the data as needed. The data quality tools are of interest for us. Also, the personnel upskilling having to do with the data spaces and the data governance and data security policies is of great importance. There are also a few risks that have to do with the compliance of the project components that are going to be developed with the company's security policy and the company's data governance policy. The interconnection with other projects like Data Cellar that are also in a developing phase is a point of concern. And data consistency issues and other data quality issues concerning our data being ingested from the productive systems to the data space is something that concerns us. So that's all. If you have any questions, thank you very much.
Thank you, Savas. You have seen that telecom and energy share a lot of common challenges, but also many opportunities. The next speaker is a data mine architect. It's Savas from CERT in Thessaloniki, and he will present us remotely. Savas, are you here? Vasilis.
Hello,
sorry.
Good morning.
Yeah, the floor is yours.
Thank you, Christos. I guess that you can see my screen. Good morning to everybody. My name is Vasilis Siopidis. I'm a research assistant at CERT. Welcome to session about the architecture to reach monetization. Moreover, I apologize because there was a sudden problem with my camera, so you cannot see me. So let's delve further to the technical perspective of DataMite. What is DataMite? Is it another data market? No. DataMite is a data sharing enabler designed to meet the needs of multi-domain data origins, integrated with various data destinations. Our data destinations are divided to two different main categories. The first one is the IDSA data spaces, and the other is a series of European portals. Now, in DataMite, our primary goal is to develop a versatile open source framework that transforms how companies manage and share data, ultimately enhancing monetization opportunities. In DataMite, we emphasize the creation of a dedicated data sharing module equipped with tools that prioritize data and data interoperability and sovereignty. It is understandable, as we are talking about data, which is something sensitive. Our approach is not to provide a centralized platform, but a client-side framework. Our main objective is to ensure security, privacy, fine-grained access control, and to offer comprehensive support, guidance, and user manuals. For sure, our design adheres to 5 principles. First and foremost, our aim is to enhance the findability of data and metadata. We achieve this by defining a rich metadata model and providing robust queries in our metadata registry. Moving to accessibility, we define a precise set of access permissions, policies, ensuring that data remains exclusively to authorized user only. Interoperability is a key focus for us. We provide data and metadata translating plugins, incorporating common models and schemas to foster seamless data and metadata exchange. Finally, for the reusability aspect, we ensure a well-described metadata model, facilitating the effortless republishing of data and metadata to a variety of destinations. Now, let's explore the key components of the DataMite architecture. Beginning with data governance, our focus is on efficient management, access, and enrichment of data. This module includes a robust metadata repository, a comprehensive data catalog, a glossary, and advanced data lineage capabilities. Moving on to data quality, we provide essential tools that allow versatile approaches and access the quality of datasets. The security module encompasses critical functionalities such as data sovereignty, access control, and a suite of comprehensive security measures. In the realm of data sharing, our goal is to facilitate secure data publication to various IDSA data spaces and a series of European portals. The data support tools provide a range of supplementary capabilities covering the interoperability aspect, security, the data quality, and data harmonization. Finally, our front end serves as a user interface for the DataMite modules, ensuring a user-friendly experience. Now, regarding our data sharing mechanisms, they are divided to 2 different main categories. The first one is the IDSA and GAIA-X initiatives that aim to create data spaces that enable data sovereignty and data sharing in Europe. For the second category, about our European portals, we will use two different protocols. The first one is the REST API, which facilitates the seamless transfer of metadata through a standard API, ensuring the efficient communication and integration. And finally, we will use also the metadata harvesting protocol, which provides a structured approach to metadata harvesting, streamlining the process of collecting and sharing metadata across different platforms. Something crucial to DataMite also is the data sovereignty. Data sovereignty is important on the one hand for the data provider and on the other hand for the data consumer. Our data destinations in DataMite are categorized to two different categories based on the access policies. On the one hand, we have the IDC data spaces, which use machine-readable rules. And on the other hand, we have a series of European portals that usually adopt human-readable access policies. Consequently, our goal is to compile all rules to a human-readable format within a comprehensive rulebook. Moreover, we intend to deploy a policy engine to dynamically evaluate and enforce these policies. Something important, it is the logging tool, similar to the IDSA clearinghouse, that will log all the transactions with the external system in order to enhance the transparency. Moreover, from the stored information, we will generate statistics that will be beneficiary to the DataMite users. In conclusion, for the DataMite data sovereignty aspect, we have the payment tool that supports a variety of accounting functionalities and charging methods, ensuring transparent and efficient financial transactions within the framework. Now, I think that it's understood that on the one hand, we have multi-domain data origins that they manage data and metadata with their standardized processes. And on the other hand, we have a variety of data destinations that they adapt a variety of data and data formats and structures. So we should solve this interoperability issue. Our goal in DataMite is to automate data sharing processes, streamlining the communication across diverse systems and domains by providing the appropriate data and the data translating plugins. By achieving interoperability within our system, we facilitate the seamless exchange on both data and the data across all those different systems. Now, as Santiago explained previously, many organizations have valuable data that they never realize how beneficiary they could be, or they never transformed to a data product. Another goal in DataMite is to provide a series of mechanisms and tools that will transform those valuable data to a data product. For that reason, we will provide a series of tools that we will parse and extract information from the data and will be stored to our metadata model in order to ease the internal processes within the organization. Moreover, we explore the measures taken to uphold and enhance the quality of the data, ensuring the reliability and the accuracy. We uncover the methodologies employed for data anonymization, safeguarding individual privacy in the data products. Regarding the harmonization process, aligning disparate data sources to create unified and coherent datasets. Finally, by addressing the critical aspect of fairness in databases, we examine strategies to mitigate biases and ensure ethical data practices. So, this is a simplified flow regarding the data sharing process with the DataMite framework. The first step is to transform the data to a data product. For that reason, as I explained previously, we will provide a series of mechanisms and tools in order to create a valuable data product. The DataMite data preparation includes all those tools regarding the data quality, anonymization, normalization, or data biases. Moreover, we aim to provide guidance and to assess the data based on thresholds if they are appropriate to be published or not. So, as we have transformed the data to a data product, a data might user is able to publish the data or the relevant metadata. Data might user chooses the appropriate data destination, one of those that is integrated with a framework. In the backend, runs an automated process about to prepare the data and the metadata in order to be published to the data destination. Moreover, we have the data sovereignty submodule that provides explanations about the data sovereignty aspect in the data destination, as I explained previously regarding our rulebook that will provide all the access rules, the relegations to a human readable format. So as we have the data, the metadata, and the access rules, we are ready to publish to a data destination. So when we receive a request about the data agreement, we have the logging tool, and which is a submodule in the data sovereignty that we will notify the data might user about the incoming request. Finally, the data might user is able to query the incoming request, or it is able to query a series of statistics that we will provide in our logging tool. So thank you all. Christos, I'm open to answer to any question that you might have.
Thank you, Vasilis, for the very detailed information. Just to conclude, as a project, we have finished the requirements collection and analysis phase. Now, Vasilis and his colleagues, the technology partners of Datamite, are building the components, and we're about to start testing them within the 6 pilots that Santiago mentioned in his presentation at the beginning. I would like to thank you all for being here. I hope you find our presentations very interesting. And I would like also to thank the presenters and, of course, Yannis Chouchouliouros for giving us the floor and the opportunity to present Datamite and its achievements so far. Thank you all. Have a good day.
Thank you so much, Christos, for the interesting session, giving the added value of a new view how to benefit from the creation and the management of data, which is an innovative action for numerous market actors, including, of course, the telecom operators, among others. And thank you for supporting us, and hopefully next time we will have more concrete material and results to present. Thank you again. Thank you. Thank you again. Although some of the previous presenters in previous sessions have overrun their prescribed time slots, hopefully we are still according to the agenda, so we can have a short 5-minute break. I would like just to ask for our technicians to upload the session 4 slide indicative, just to have an idea of what we will see. And in 5 minutes' time, we will continue with a series of presentations covering the aspects of the Nancy project. We will see the expectations, the visions, the actions, but let us have a short 5 minutes break. Now it is time to continue our sessions. Hopefully we manage to reach to the 4th intern session, which is about the ongoing NANSI European project. Actually, NANSI is among the scope and the framework of the SNS European activities, Smart Network and Services, which is the continuity of the previous 5G PPP framework. Just to let you know, this is an initiative, and it is very important to understand the scope of the project towards creating, designing, assessing the first requirements for what we will call as 6G. So it's some levels higher compared to the actual 5G infrastructures and solutions provided by the network operators. This session will be chaired and controlled by my colleague, Mrs. Maria Bellesiotti. As you can find in this introductory slide, we have, in fact, 5 presentations, 4 directly related to the scope of the NANSI project, which is about promoting an AI-aided unified network for secure beyond 5G long-term evolution, or for secure beyond 5G towards 6G infrastructures. And we also have an additional presentation by Dr. Olga Segu, a related project that will give some aspects within the same framework. But this was enough. I will let you enjoy, if I may say. Please let me use this term, because what we want to do is just to give the initiatives for the ongoing activities. We have a dedicated project, and we start with Dr. Dimitrios Pliatsios. Dr. Pliatsios comes from the University of Western Macedonia and represents the coordinator of the project. Maria, if you want to say something, in any case, the coordination is fully yours. And we thank Dimitris for his presentation today.
Good morning, everyone. Thank you very much, Dr. Hochliuros and Ms. Maria, for organizing this event and for inviting us to present the NANSI project. So, my name is Dimitris Pliatsios. I'm a postdoctoral researcher at the University of Western Macedonia, and I will present this in this session the first slot, which is an overview of the NANSI project, which is a project funded by the 6G SNS and the European Union. Okay. So some brief remarks about the project. The project coordinator is the University of Western Macedonia. Professor Panagiotis Arianidis is the project coordinator, and I act as a deputy project coordinator. The European budget contribution is about 6 million. We started the project as all SNS project in the 1st of January 2023, and the duration is 36 months, sorry. The consortium consists of 22 partners from 8 countries. We have a well-balanced mix of research institutes and small-medium enterprises. And also we have 5 industrial organizations, for example, OTE, Thalys, Intrasoft, NEC, and Ericsson. Now, the aim of NANSI is focused on the radio access networks, and it aims to design and develop a secure and intelligent architecture for beyond 5G networks. To do so, it utilizes artificial intelligence and blockchain in order to enable intelligent resource management, flexible networking, and orchestration. Among all the technical components that will be developed in ANSI, we'll also develop a theoretical framework for mathematically validating the project results. This is a high-level overview of the NANSI concept. First, we have identified the key performance indicators. both the technical ones and the ones that are mainly associated with the business perspective. They have to do with the security of the network, the low latency, the high reliability, the coverage expansion, and the improvements in terms of energy efficiency and cost ownership. Some fundamental characteristics include the blockchain modeling. So we aim to mathematically model the blockchain interactions among the various network entities, model the cyber attacks in order to quantify the potential impact of attacks against the Nancy architecture. We will develop cell-free and grant-free access schemes towards improving the capacity of the network as well as minimizing the latency. The semantic communications is another important aspect as it aims to reduce the information that is transmitted over the network. So by reducing the information, we reduce the network load and we also improve the latency. And of course, for providing incentives to the network entities to participate in this architecture and the blockchain, we will also develop some smart pricing policies. Some key technology enablers include the multi-access edge computing, blockchain, post-quantum cryptography towards increasing the security, caching and offloading policies, and all this will be supported by artificial intelligence techniques, software-defined networking, network function virtualization, and AI virtualization. All this will be integrated and assessed in 3 usage scenarios. The first one is the front-haul network fixed topology, which investigates scenarios where multiple mobile users are served by one or more base stations, and the base stations may be from the same or from different operators. The second scenario is the advanced coverage expansion, which aims to investigate the utilization of the end users, the end devices, as operators. So extending instead of having an operator that transmits the data through a base station, we can have the user equipment, the end devices, acting as relays, and this improves the energy efficiency and also the coverage range of the network. And the third scenario has to do with the connectivity of mobile nodes, being vehicles or UAVs. So Nancy has 3 phases. The first phase, the fundamental research, has to do with the identification of the scenarios, the requirements, the KPIs, and the development of the theoretical framework. Phase 2 has to do with the design development of the technical components of the BRAN architecture, these being the network functions, the AI algorithms, the security mechanisms, etc. And in the phase 3, all these components will be integrated, deployed in the demonstrators, and evaluated. This is another grouping of the Nancy in 3 pillars. We have the blockchain-enabled radio access network that aims to support dynamic scalability, high security, and privacy. In this direction, we will leverage several outcomes, such as the modeling of blockchain and cyber attacks, the smart pricing policies, cell-free and grant-free access mechanism. The second pillar is the wireless orchestration of the radio access network using artificial intelligence towards having reliable connectivity and high energy efficiency. So these have to do with using AI and machine learning techniques for optimizing the resource allocation, for optimizing the network slices, as well as for anomaly detection, self-healing, and cyber attack protection. And finally, the third pillar is the utilization of the multi-access edge computing towards shifting the computational resources closer to the end devices in order to mainly minimize the introduced network latency. And again, we have some resource scheduling algorithms and also some offloading policies and other algorithms that try to predict, using AI techniques, the availability of the end user resources towards optimizing the whole orchestration of the network. All all this will be demonstrated and validated in 3 large-scale pilots and 2 laboratory testbeds. For the large-scale pilots, we have a massive Internet of Things environment that has critical network traffic. This will take place in Italy. We have a high mobility scenarios involving UAVs that will take place in Spain. And we have a scenario that involves offering multimedia services to end users that will take place here in Athens in the OTE premises. And we have 2 laboratory test beds, one at the University of Western Macedonia and one in Kozani, Greece, and one at Italtel in Italy. These test beds are focused on basic research and developing prototypes. And also through these prototypes, we will generate data sets in order to train the AI algorithms that will be later used in the large-scale pilots. So thank you very much for your time. Nancy is active in all social media platforms, so I have provided the links here. If you want to learn more information, please visit the website and also the social media. So again, thank you very much for the invitation.
Okay, thank you so much, Dimitrios, for this excellent introduction to the scope of the project. Now, the next speaker is Mrs. Maria Belesiotti from OTE Greece. We pass to presentation 12. Maria will provide some information about market opportunities and will present the intended use cases of the project.
Hello from me. Okay. I am Maria Belesiotti from R&D department of OTE, the fixed section. Together with Ioannis Chokliros, we participate in Nancy project. We are the key, let's say, partners in the third demonstration and in the part of use cases. Okay, I will make a brief introduction how all this began. In the beginning, we had only 2G. It was the initial phase of mobile communications, and that it could only provide us with voice and SMS messages, short messages. Then, when 3G arrived, data and let's say internet started to appear in our mobile phones. So the community, the scientific community, identified the need for better speed, throughput, and so as to have better data rate in our phones. And then 4G came. 4G managed to give us better latency, better speed, 4G together with LTE, so as to make the access from mobile phones to internet and the use of data something of high importance in everyday lives. Currently, we are in the 5G era. Most operators deploy 5G networks. It's something that is in the process. And 5G has promised to bring us better latency, better connection density, better speed. That is something that is going to ease in our lives. The next step, although 5G has not, 5G deployment has not been finalized yet, is 6G. We will try, with our research, to contribute to the gap that has been identified. from 5G, mainly in the space of the applications, in the field of the applications, to make them better and faster, and 6G has promised to bring a fully digital and connected world. Of course, 6G will have a new spectrum, and combined with artificial intelligence, and as far as Nancy is concerned, with blockchain, has promised to bring more disruptive technologies, self-free networks, and energy efficiency. 6G also will bring, let's say, a massive applications in other fields as well, as such as drones, such as medicine, mobility of cars, and the new thing that has introduced is the societal business demands that have been posed, which is what exactly has the technology to offer to society and environment. We will talk about this later. So, in the process from 5G to 6G, as it is obvious, the use cases have been evolved as well. The original family of 5G use cases, the MBB, MMTC, and URLLC, which provide a certain peak of speed, 1 millisecond latency and up to 1 million connections per square kilometer, have now been enhanced, and so as to be, I would say, 5G ready. In 6G, there will be use cases that demand extreme requirements. These use cases will be enhanced with AI and sensing functionalities, and currently are called EMBB+, URLLC+, and MMTC+. It will support use cases like augmented reality for industry, telepresence, security, distributed computing and automation, wireless data centers, zero-energy devices, swarms of robots and drones, and biosensors and AI in medicine. Some of these cases are currently supported by 5G, but not in the scale that 6G is expected to bring. So, in this respect, Nancy has a Beyond 5G project that has his eye on 6G, has identified the plus 5G use cases, and it is focused to bring use cases that will be piloted in the end of the project that will have enhanced requirements similar to 6G, because it cannot be 6G requirements since 6G does not yet exist, but we will try to be as close as possible. To this respect, Nancy's vision, it is combined, it is based on AI and blockchain, and it is to introduce a secure and intelligent architecture for the beyond 5th generation wireless networks. These networks will be called BRAN networks, and will offer intelligent resource management, flexible networking, and orchestration. We will have 3 usage scenarios, as it was mentioned in the previous presentation. The first scenario is front-haul network of fixed topology. The second is advanced coverage expansion. And the third is advanced connectivity of mobile nodes. Also, we will have 3 demonstrators, meaning 3 large-scale pilots. The first one will be in Italy. Ericsson is responsible for this, where an IoT simulator will simulate traffic lights like IoT devices, and so as to have reliable and resilient connectivity. And here we will test PQC functionalities, trying to improve end-to-end data communication security. The second demonstrator will be in Spain, and it will deploy MEC capabilities so as to validate AB-based BRAN orchestration mechanisms. This is a URLLC use case where we will try to prove that we can the proposed architecture, the proposed Nancy architecture, can offer latency of a few milliseconds. The previous one, it was an MMTC plus use case. And then we have the third demonstrator that will be held here in Greece in an OT testbed that is deployed between our premises, OT premises, NTUA and Demokritos. And we will be demonstrating AR/VR applications in an urban environment. This use case needs extremely low latency, while at the same time is able to provide high security and privacy. Again, here, the BRAN architecture of NASI is supposed to be used. What 5G has more to offer, I see my time is over, so I'll be very fast, has introduced in our research is KVIs. KVIs are derived from UN Sustainable Development Goals that has been adopted in 2015 and should be met in 6 years from now. There are 17 Sustainable Development Goals and many sub-goals. And the main, let's say, business scenarios of 6G use cases in business that are expected to grow in the future should have a notion, let's say, of sustainability. These business scenarios should be either economic, social, technological, environmental, so as to be considered that are 6G related, because at this point, technology should start offering to society and environment, and this is something that 6G supports. Until 5G was not considered for these issues mainly, but now and hopefully in the future, all these will have other impacts as well. Okay, thank you. I was 2 minutes late. Thank you very much. The next speaker is Dr. Stelios Trevlakis. He is the CEO of InnoCube and the technical manager of Nancy project.
Hello, everyone. It's nice to see you. Thank you, Maria, Dimitris, and Yannis for creating this opportunity for Nancy. And I will focus as a continuation of what the previous two presenters said on the architecture that is envisioned within Nancy. As Dimitris and Maria said, in this slide we can find the key performance indicators that are targeted by the Nancy project. We can see the fundamental characteristics, which include blockchain, modeling of attacks and networks, self-free access and semantic communications. And we see what technologies we use and what are the key modules that enable the blockchain run architecture. While on the down right, we see the 3 usage scenarios that were mentioned before. Here we can see a layered architecture of the blockchain run. We see that we span from the cloud to the edge until the user equipment, and the main technologies that we have are color-coded, with AI being represented with a yellow color, while the network functionalities are highlighted with red, and finally with a purple color we see all the security components of Nancy. A bit of more technical details about the 3 use cases that we have, starting from front-haul network of fixed topology. We have 3 more specific use cases here. So we have the direct connectivity between the user equipment and the base station, access point, or antenna. And this is the most simple case. However, we also investigate the COMP scenario, cooperative multi-point access for the network. And in this respect, we start based on a simple COMP scheme where we have the 2 base stations, the user equipment connected to 2 base stations that belong to the same operator, while we envision a different scenario that is based on the Open RAN architecture, where the 2 base stations belong to different operators. However, we can enable, through the security of blockchain, the interconnection between the mobile and 2 different operators. Next, we have the advanced coverage scenario, where we have 3 sub-cases: the multi-hop connectivity, ad hoc mesh connectivity, and point-to-multipoint connectivity. The multi-hop connectivity is covered by the fact that we can set up secondary networks that through an intermediate node of the network, and this way we can provide some extended coverage. For example, we can use a computer, and through this computer connect to a base station that will enable a mobile phone outside of the coverage area to connect. In the same sense, we can create ad hoc mesh connectivity scenarios with multiple devices, either in the intermediate level or in the base station and mobile, in the 2 edges of the network. And also in the point-to-multipoint connectivity, this is, let's say, in collaboration with the ad hoc mesh, where we have multiple devices connected to a single point in the network, a single node. Moving to the 3rd use case that we are investigating, it is the mobile connectivity of vehicles mainly that travel through the infrastructure. And in this case, we are trying to provide self-free access to the network independent of the operator that is providing this access. We're trying to enable this both in a vehicle-to-base station scenario and in a vehicle-to-vehicle scenario as well. And this is very interesting because we have to ensure the security in such cases and also handle any financial and smart pricing policies that will be covered by the next presentation. All in all, this comes down to the architecture that is presented in this slide, where we can see 1 operator infrastructure being deployed on the right side and the infrastructure of a 2nd operator being deployed on the left. What is the heart of Nancy is the interoperator domain, where we host multiple AI modules and security through the blockchain and the marketplace, and each operator interconnects with this interoperator domain in order to have joint service provisioning in the network. I will go briefly about the technologies that we use. And because blockchain is one of the key technologies used in the project, we see that it is interconnected with the financial aspects that exist in networks. It is interconnected with the orchestration and SMO, management and orchestration of the system, which handle the topics of when a device gets access, what resources are available for this device, what services are available in combination with the pricing that the user has agreed upon. And of course, it is connected with all the user equipment devices through PQC in order to enable even more secure environments. In this respect, the orchestration functions in order to enable the intelligent management of resources, enabling elasticity, and it is combined with various technologies that we use in the project, like offloading, caching of data, and all of these technologies are based on AI, and they are interconnected in the AI model repository, which hosts all the models that we use, and it will continuously retrain and adapt these models in order to ensure that as new data, as new input is presented to the system, it can adapt upon it. I have have more details in the slides in order for, if someone is interested, to be able to go over them after the presentation. We are using in the Nancy project, in order to enable the correct utilization of resources, virtualization, and which is tightly bound to the orchestrator and offloading and user-centric caching that we see in the next slides. But I don't want to devote any more time into how this, because I expressed how it interconnects between everything. And a very interesting case is the mobility management in the Spanish demonstrator of our project, where we use cooperative and self-free access mechanisms in order to ensure and enable the constant and uninterrupted connectivity of the vehicles. And we have some preliminary results that are very promising about this use case specifically. So finally, we have some safeguarding technologies that are mainly focused towards ensuring the correct functionality within the network, identifying attacks, and in this respect, we are developing anomaly detection, self-healing, and self-recovering mechanisms. In addition, we are developing some energy and data preserving and energy and data efficiency augmenting technologies with regard to goal-oriented communications and semantic communications, where our main goal is to reduce the traffic of the network in order to enable higher quality of service. And finally, since we use a lot of AI technologies, we are trying to explain as much as possible of the decision-making that is happening in the network and all the intelligent procedures that take place. So that would be all from me. Thank you very much for the time.
Thank you very much, Stelios, for this detailed overview of the architectural aspects. And now we invite Mr. Alexandros Dimos from 8 Bells, the next speaker. He will present smart pricing policies within the Nancy framework.
Thank you very much. Thank you for having me here today, and a very special thanks to OTE for hosting this event. I'm Alex from 8 Bells. We're a company based in Nicosia, Cyprus, and Athens, Greece, and we specialize in a wide variety of research fields and deploy a strong arsenal of technical capabilities with a more than competent personnel in order to support them. Now, moving on to Nancy. Nancy aims to create a secure and intelligent architecture for the beyond the 5th generation wireless networks. And one of the main components that will contribute towards this goal is Nancy's smart pricing framework. But in order to understand the smart pricing framework better, we need to take one step back and look at the current state of radio access networks. We see that they comprise of many different providers and their infrastructure elements inside the network, as well as their customers and their smart devices moving freely inside the RAN. Of course, despite being in the 5G era currently, flaws still exist. For example, let's say that the smart devices move out of the coverage area of their provider into areas of low coverage or covered by other providers. Unfortunately, these situations lead to inconveniences, such as poor quality of service, high latency, low bandwidth, etc. Of course, inconveniences everyone here has encountered at some point or another. Network resource sharing schemes already exist that allow the cooperation between infrastructure elements in order to cooperatively cover an area more efficiently. But of course, none of the existing schemes so far and mechanisms consider the coordination between infrastructure elements of different providers. This is what Nancy aims to change by allowing every provider and even customers to be active parts of a unified network. Of course, this does not come without challenges. For example, why would an internet provider release his equipment to attend to another provider's customer? Or why would customers lease their equipment in order to enhance the current infrastructure? This is where the smart pricing comes into play by introducing new monetary incentives, both for providers as well as for users, customers. So to summarize, Nancy brings forward two great innovations. These are the cooperation between providers' infrastructure and the utilization of customer equipment as active parts of the network. For example, this could be your personal smart devices like smartphones, personal computers, laptop, etc. And these new features lead to a more unified, dynamic, and cooperative radio access network. How we plan to implement this, I want you to please elevate this scenario into a this image into a game theoretic scenario where each player taking part in the transactions tries to find a strategy in order to benefit himself. By benefit, I mean with financial profits. For example, let's say I'm a provider and I'm leasing my equipment. I want to increase the price for the network resources I'm sharing. And on the other hand, the party paying the bill wants to lower that price and set some requirements on the network resources they want to receive. Smart pricing is responsible of finding a deal, an equilibrium between the two parties that suits and benefits both. And when this deal is sealed, it is transcribed to Nancy's blockchain in order to create an accurate and secure transaction history. Of course, blockchain technology is ideal for such an environment because the number of contracts and transactions between multiple providers leads to a very dynamic and decentralized ecosystem within Nancy. I think we should also answer the question on why we didn't go for a simpler static pricing policy. This is because of the dynamic nature of Nancy's radio access network with multiple infrastructure elements of different providers cooperating together, as well as the user equipment moving from access point to access point and always requesting different amounts of data. These factors create a very complicated project for any static pricing model we have nowadays. So it raises the need for a new, novel, and smart pricing model. We should also answer the question on why would any customer want to be part of the network and enhance the current infrastructure. Of course, monetary rewards from their providers are a very strong motivations for more customers, but we also plan to enhance that by establishing a tier system based on each person's contribution to the network. For example, people with higher contribution could receive higher monetary rewards. And we believe that this strategy also benefits the providers because it will allow them to grow their network by growing their customer base and without the need of constantly laying down new and expensive equipment. Finally, the impact we expect Nancy and smart pricing policies to have are the transition to the new B5G and 6G era, the new financial opportunities both for providers and for customers, and finally lead to a more decentralized and unified network. This was all from me. Please follow Nancy to the social media platforms and monitor their website. Please feel free to ask any questions. Thank you very much.
The next speaker is Dr. Olga Segu, a senior researcher at Intrasoft.
Okay, thank you kindly for the introduction and the invitation. It is always a pleasure to be here at Infocom, which is more or less one of the legendary conferences here in Greece. It is always a pleasure to be here. So today I would like to bring some focus into another area of critical infrastructures, the area of resilience. So of course we have a lot of projects that we are going to see here today that deal with the increase of capacity that we have seen is very important these past few years due to the effects of the pandemic that I believe everyone in this room has felt that effect during the past years. And it highlighted this need for increased capacity and increased capabilities in the digital infrastructures. However, one aspect that we also need to focus upon is the resilience of such infrastructures in cases such as the pandemic. So today I would like to speak a little bit about how to achieve better resilience in the critical infrastructures. So at this point in time, we are still recovering from the effects of the COVID-19 pandemic. And it becomes quite apparent that we also need to make the lifeline structures and the really critical services that we use to be future-proof. So the effects of the pandemic to our everyday life has made it quite clear that we need to reassess the way we view critical infrastructure resilience, what kind of services are actually critical for everyday work, and also to shed some more light on the cascading effects that are caused by failures in critical systems. So it also underscored a need for smarter infrastructures and more connected infrastructures, not just in the telecoms area, but across any sort of critical infrastructure like energy, water, and health. So to that extent, Intrasoft is participating and is actually the technical coordinator of the EU-funded Sunrise project that deals with ensuring availability, reliability, and continuity of critical infrastructures and related services in Europe. So basically, our main objective is first to develop effective strategies and technologies to ensure this availability, reliability of services. We need first to have a very good understanding cooperation across borders and among public and private entities. So our objective is to facilitate this collaboration among CIs within European borders, to identify which services are vital in terms of handling the pandemic, what are their interactions, their dependencies, any common risks that could lead to cascading failures, cascading effects, and how to develop a comprehensive strategy to address these problems of CI resilience across Europe. So this is currently a running project. It started in October 2022 and will run towards September 2025 with 41 partner organizations across Europe. That also includes 18 public and private CI operators and authorities. So we have quite a big user base across different types of CI operators. So our approach starts from collaboration. We need to be able to better identify the needs of the critical infrastructure operators, and to that extent we are organizing a lot of national workshops across Spain, Slovenia, Italy, all the major sites of our pilots. And these workshops are performed in the local languages, which is quite important so as to get a lot of attendance and a lot of feedback from infrastructure operators. The second part is to strategize and try to learn as much as we can about how the pandemic has affected workflows, operations, and VCIs. And at the end of the day, we are going to be developing a very specific toolkit to enable this day-to-day management, starting from risk-based access control that helps reduce risk in terms of accessing critical infrastructures in a privacy-preserving way, in resource demand prediction that is mostly AI-powered and is trying to ensure that changes in the demand of CI resources can also be managed and met during emergencies. We take a look into cyber and physical resilience of such infrastructures, so we do take a look at the digital side and the physical side of such infrastructures. And of course, last part is the remote inspection of the physical infrastructures themselves. So in terms of the telecommunication world, it would be masts and base stations that need to be inspected for faults, etc. So just a few preliminary results in year 1 at TRL 5. You can see pictured the risk-based access control tool that checks not just the access credentials of a specific worker, but also takes temperature and checks fit of the mask, etc. So there are quite a few factors that this access control system can check for. The cyber threat anomaly detection tool that is used to enrich the MISP platform with additional threat analytics that come from AI-powered tools. The future forecasts in terms of resource demand. In such a case, we rely on historical data and also pandemic data in terms of resource demand. And finally, the remote infrastructure inspection tools that leverage technologies such as UAVs and AI models in the area of semantic segmentation to identify landslides or faults and ruptures and rust in specific infrastructures to also help manage the exposure of the workforce to COVID. For example, in an area where there is a very strict lockdown, we can use more remote infrastructure inspection and make sure that the infrastructures are up to par. So in this project, our role is that of a technical coordinator, as Intersoft is a leading IT solutions and services company. So we are active in a variety of domains, including critical infrastructures, telecommunications, security, etc., and participate with our capabilities in key emerging technologies such as data analytics, blockchain, artificial intelligence, etc. So if you have any additional questions about the project or our capabilities or our role in this project, feel free to reach out. Thank you.
Thank you, Dr. Segu. Nancy's session is now finalized. Short break will follow. Yes. And yes. Not the VS.
So practically, we would restart at 1:25.
Yes, with 6G bricks project.
Yes.
Thank you.
Ladies and gentlemen, it is time to continue the normal flow of our schedule. Now we have reached to session 5, which is about an overview of 6G Infrastructure Association SNS experimental infrastructures. And we are happy because we have presentation covering 2 among the 3 ongoing European projects in this area, the 6G BRICS project and the 6G Sandbox project. So we will start this 5th intern session by inviting remotely Professor Christos Verikoukis, also representing Athena Industrial Systems Institute. He will present the main scope and the context of the 6G BRICS project. If we have Christos online, we can give him the stage. Then I will continue with some more concrete information, and then Dr. Harilaos Koumaras will conclude by presenting the 6G Sandbox project. So we are waiting for the connection of Professor Verikoukis. Christos, I hope you can hear and see us.
Hello, I can hear you, but I cannot see you. Cannot see anything. Can you see me?
You can see. We can see you perfectly on the screen.
Yeah, perfect.
We are waiting just from the control to confirm that you may have access and share your presentation.
I think I'm able to share my presentation. Let me see here. Let me share this. No, let me, okay. Let me stop sharing. To move it to another screen. Okay, here is better. Let me see. And now you can see my screen and my presentation.
Perfect, Christos.
There, okay.
Okay.
You can still, yeah.
Okay.
When you give me the light, I can start.
The stage is fully yours.
Okay. Hello, everyone. I'm Christos Verikoukis from the ESI Athena, a research center in Patras. I'm here to present you the 6G, brief presentation of the 6G BRICS project. It's a building reusable testbed infrastructures for cloud-to-device breakthrough technologies. I will give a high-level presentation, and then Yannis will, in the next presentation, will explain you the innovation streams for this project. This is the outline of my presentation, a brief introduction why we presented this project, the main objectives, high-level description of the architecture, brief overview about the testbeds. I will mention the innovation streams, and then I will explain you the use cases, and then our open call for companies to join our project. So, why 6 BRICS? We have a very good track record in EU-funded projects on beyond 5G and 6G. The partners participated in the Marshall project, in the Molby 5G, in the RI6G, in the Radar, proposing breakthrough ideas and technologies for beyond 5G and 6G solutions. Moreover, the team that participates in the 6G project has a mature experimentation tool based on the ICT 41 5G Media Hub project. There will be a presentation, I guess, during this event. And we have that this facility has the capability to federate testbeds in the 6G BRICS project will federate two very well-established beyond 5G testbeds in KUL and in Eurocom. From our previous experience, we saw that there is enormous effort and complexity to integrate all these software stacks and offer interoperability. And this is a big challenge that in order to make them cloud technologies and engineering for building testbeds. In particular, we have distributed processing and experts from the area of distributed processing and reconfigurable intelligent surface from self-free. And based on this, we adopt the principles of modularity and softwareization in order to deliver to the scientific community the first truly modular end-to-end 6G experimentation platform. We adopt the concept of the Lego bricks. We have different modules that can be plug and unplug. And the experimenters that can easily adapt and plug their solutions and carry out some tests, some experiments. These are the 6 very well-defined objectives to deliver an evolvable 6G experimentation facility that will integrate, in our case, several 2 breakthrough 6G run technologies to validate and showcase advanced use cases in metaverse and digital twinning. We're also planning to adopt virtualization, softwareization, and opera interfaces in order to promote the modularity and the reusability of the solution. The solutions offer a decentralized management plane, supporting zero-touch orchestration based on explainable AI. We also offer a compute continuum abstraction framework in order to support disaggregated wireless X-Hall. And finally, we deliver breakthrough 6G RAN technologies via distributed self-free and RIS enablers. Overall, the project started 1st of January 2023. It will run for the next 36 months overall, for the next 24 months. We have a budget of 8.4 million euros, and 1.7 of them are for open calls, for experimenters who can bring their solution, I will explain at the end, and test their solutions in our facility. I will be serving as the project coordinator. Kostas Dramantas from eQuadrat will be the technical manager of this project. You can follow us in the different social media. We have a very well consolidated consortium of 17 partners from 8 member states. We have on board 6 large companies, 5 RTOs, top-tier research centers and universities in Europe, and 5 high-tech SMEs. This is our architecture. As you can see, we have 3 big blocks. The experimentation facility hosted by ESI Athena in Patras, and the 2 testbeds. We decided to keep the testbeds like local, even the DMO or the DMOs are inside the local testbeds. And 1 testbed is in Eurocom, where we integrate for the first time a RIS to the open interface to a cellular system, and we design a new RIS controller. And the other one, the self-free one, is in KU Leuven, where we leverage the developments that we had in the Marshall project in order to offer a real-time end-to-end, at this time, self-free solution. Regarding our experimentation facility, it's a tool which automates experiment execution, and this experimentation engine offer automated onboarding experiments. And for the first time, we offer the possibility to the experimenters to run and touch radio units via the Open Run compliant exams. We also, this solution also offers a business support system and a service catalog with SLA definition support for the service level intent here. Then for the testbeds, we have two very well-known testbeds. The first one is Open Interface, provided by Unicom in Sofia in France. The testbed includes an ORAN platform, and it's compliant with the MEC ETSI solution. It's a full end-to-end testbed that's also open source. The idea is to upgrade this testbed with risk capabilities. Sorry for this, this did not happen. And run some interesting use cases. The second testbed is located in KUL. It runs cell-free massive MIMO since 2014. They are based on, the testbed is based on National Instruments USRPs, and it will be upgraded with some DUs from the IS wireless, and will offer millimeter wave connectivity to and advanced features such as full duplex communication and joint communication and sensing. The data is processed locally, and at the end of this project, the data sets will be offered to the scientific community. Finally, since we have a facility and we need to secure the facility, we propose a new security framework based on software-defined perimeter and VPN as a service. And we offer zero trust security. The SDP gateway management plane will be connected with the SDP controller and the security orchestrator that is deployed in our site in ESI. Then the VPN as a service we used for simplified establishment towards cross-site VPN encrypted tunnels, even outside of the GIANT solution. And finally, we can dynamically configure zero trust environment where we can split, we have privileged infrastructure that's completely isolated from the less privileged one. These are also, in addition to this, let's say, innovative environment, we have some innovative solutions that Yanis will explain in the next presentation, like network-controlled open RIS platform, algorithms for distributed cell-free massive MIMO processing synchronization, algorithms for multi-band millimeter wave cell-free massive MIMO, integrated communication and sensing for RIS and cell-free, explainable AI and machine reasoning for unified and zero-touch orchestration, and overall we offer a platform as a service, as a service abstraction for a self-synthesized compute continuum. All these ideas will be tested as a proof of concept in 2 use cases, and each use case has 2 experiments. The first use case, in the first use case, we will test holoconferencing in a virtual meeting room and virtual team building activities. In this case, a multi-point control unit application handles the real-time processing of the holograms and the streaming of 360 VR. And the technologies that we develop in this project, like cell-free, will ensure spectrum efficiency, an increase of the spectrum efficiency by a factor of 2, and an 80% reduction of the blocking probability in order to improve the quality of experience, while the pass enabler will help us to exploit a continuum of resources to facilitate the computational offloading and real-time migration of the services. The second use case is related to Industry 4.0, and we have autonomous robots in Industry 4.0 and AR inspection of digital twinning. And in this case, we use some of our technologies like joint communication and sensing this technology requires efficient tracking and beam steering. And with our solutions, we offer low latency and 100% coverage, no disconnection in the communication using the proposed RIS platform. Finally, to close my presentation, we have open calls. The call will open by the end of this month. We invite the scientific society, we invite SMEs, we invite big companies to bring their solutions and plug them in our experimentation facility. Some indicative points, bullets of that lies in our interest are digital twin solutions for RAN emulation, NWDAF functions for ORAN ML frameworks, experimentation XApps, RIS data devices that can be plugged to our ORAN RUs, explainable AI-driven causal reasoning and anomaly detection module for the 6G bricks orchestrator, IoT edge computing platform for expanding the proposed 6G bricks compute continuum, technologies for joint communication and sensing, digital beamforming algorithms and or synchronization algorithms that can be plugged in the KUL testbed and use their datasets, and or any other technology that can expand the 6-brick facility. That's all from my side. I would like to thank Giannis for organizing this amazing event. And if you have any questions, I'm at your disposal.
Thank you so much, Christos, for joining for this detailed presentation that has provided us the full flavor of the 6G bricks intended facilities, use cases, infrastructure, the full innovative scope of this very interesting European project. And we are quite happy you are coordinating this, let's say, much promising effort. Thank you, in addition, because you have given me the stage in order to proceed and provide some more details in the presentation. So I will continue the scope that has initially been presented by Professor Verikoukis. I'm waiting.
Let's stop. I will stop sharing.
And also okay. So based on the framework that has initially been presented by Christos, Professor Verikoukis, what I intend to do in this, let's say, sequence of the previous presentation is just to focus on the intended core objectives of the 6G bricks infrastructure. However, as a short introduction, just to correlate what we are doing within the framework of 6G Infrastructure Association SNS, Smart Network of Services, and why we are doing this. The answer is given here. Because for certain reasons, because of commercial deployments of 5G infrastructure giving new capabilities, because of the enablement of the use of new applications and new business model, new innovative, let's say, applications like holographic telepresence, immersive communication, there is a need to extend and enhance the current 5G networks based on the existing KPIs, key performance indicators, and promote a new sort of infrastructure that will allow us to go further. And this is the vision where the 6G bricks project is actually located. Some further concerns here. 5G has already started a trend towards software-defined infrastructure and software networks, which has practically revolutionized the way we see, we conceive, we understand, we assess, we deploy, we commercialize, we benefit from such an infrastructure. This has been strongly correlated to the framework promoted by the Radio Access Network via the Open RAN initiative. Such aspects strongly implicate for drastic modifications regarding reduction of OPEX and CAPEX, so they have direct applicability in the market. However, the complexity of 5G standards and existing software stacks is an obstacle for experimentation platforms regarding end-to-end applications, and this is actually the challenge where 6G Bricks and 6G Sandbox face in order to promote solutions for the market. That is, to provide the possibility for the market actors, various market players, to use these sort of test beds in order to support work for inclusion of 6G-related innovative aspects. And so this is practically the vision, as Professor Verikoukis mentioned. The project considers cell-free networking and RIS, reconfigurable intelligent surfaces, considers 2 existing test beds in Belgium and in France that will be federated under a common cloud node in Greece. And so, continuing our discussion, this is actually the first open 6G platform combining cell-free, open air interface and RIS, intending to adopt the principles of softwareization, open source software stacks, and practically this takes into account efforts from previous 5G PPP projects in order to make evolvability and scale-out efforts challenging and promote the inclusion of market actors. I will pass this very quickly. The aim is here to go beyond the current testing as a service capabilities of current initiatives and allow experiments also on devices via Open RAN principles and being compliant with X applications, which is a very important consideration for our approaches. This slide implicates that what we want to do also takes into account results from previous European projects. So we have some mature results, we go further, and we implicate the inclusion of CF and RIS technologies. We also consider explainable artificial intelligence and machine reasoning in our approaches. And as Professor Verikoukis mentioned, what we are actually doing is that we want to have all these enablers to be delivered in the form of reusable components with open APIs, which these are termed as bricks. This is important for the market for the reasons you can see. It is an open facility allowing third-party consortia, vertical application owners, and experimenters from the vertical and component industry to join and participate. So now just to see one by one the proposed objectives. First of all, as we mentioned, this is an evolvable 6G experimentation facility that will integrate 6G technologies and federate two well-established platform or test best under a common set of experimentation tools. Here, the scope is about delivering an open experimentation and business support layer, taking into account options for enhanced management capabilities, and also towards the support of a managed user equipment farm layer, so that to push the computation down to the device tier. The next one is about validating and showcasing several advanced use cases, as previously mentioned, like those mentioned here, which are purely within the scope of the actual 6G vision. Here, we intend about capacity, reliability, location accuracy, and of course energy efficiency, which is a high demanding requirement. And then we want to evaluate the effect of these network KPIs and edge continuum deployments on extreme 6G service KPIs, that is to pass from the 5G to the 6G, and identify potential obstacles, trade-offs, and whatever we may need for further progress. And then, following to this, we pass to the definition of key value indicators, taking into account experiences and knowledge already gained from previous projects like Marshall, the Reindeer, the RISE 6G, and the XIX project. Another objective is about the support of fully disaggregated and SDN infrastructures. How? By adopting virtualization, SDR, and Open RAN interfaces. Here, the intended actions are briefly mentioned. As you can see, we want to deliver open and reusable bricks for all involved technical domains, offer programmable infrastructures in the compute domain and the network domain simultaneously, host third-party experiments and vertical applications compared to what I just mentioned, the innovative use cases that go along to the 6G vision, and support RAN slicing and radio resources management down to the remote unit level, allowing low-level control from the experimenters via the XApps I mentioned before. Continuing our, let's say, technical discussion, or technically oriented discussion if you want, because this is a mixture between technology and business challenges, another option is to provide a fully decentralized management plane that will support zero-touch orchestration of compute and communication resources. And this will be based on explainable artificial intelligence. Here, there are several challenges. The first one is about defining a scalable architecture of domain manager orchestrators, then to implement a zero-touch policy engine, considering explainable AI, define an explainable AI and machine reasoning for root cause analysis, and defining both these two to help experimenters. This part is also theoretically oriented in order to allow the realization of what we intend to do. Then we pass to the offering of a compute continuum abstraction framework. Here we also identify some actions like the option of delivering a continuum of solutions, as you can see here, offering primarily a platform as a service abstraction framework, and delivering multi-agent deep reinforcement learning agents. All these are correlating to a new consideration of a proposed compute continuum framework in our approach. Then we intend to deliver breakthrough technologies towards a 6G RAN approach via cell-free and RIS. Here is a little bit more complicated, but clear for a technician. The first time, intended integration of RIS and Node B to demonstrate and experiment with RIS technology by using end-to-end service. This is a pure innovation of the project. And also, we want to define novel cell-free algorithms to implement selected algorithms as software bricks, taking into account the methodology the project introduces, design these multi-band algorithms and implement them as a selection of these following to the concept of the previous mentioned software bricks. Of course, always the challenge is to have a secure and trusted experimentation facility, so security and trustworthiness for multiple tenants and related platforms is again a priority, and this is a high challenging issue, because for these requirements we have to support zero trust establishment. We intend to offer VPN as a service for the reasons you can see here, and deliver a security orchestrator in order to enhance trustworthiness and security in the intended experimentation facility. And finally, the maximization of the impact will cover aspects like dissemination, communication, potentially standardization, and of course related to the market exploitation activities. So, just some overview, some concluding remarks. The 6G project brings together specialists on technologies intending to investigate and analyze the vision of 6G. In our case, we consider cell-free networking and RIS technologies. This focuses upon structuring the various architecture tiers around the concept of the well-known Lego bricks, and lowers the barrier of entry to an end-to-end experimentation platform for specialists, thus enhancing the transition towards 6G and promoting the inclusion of investments of interest by the market actor. And finalizing, this intends to serve as a playground for testing advanced vertical application, but also validation testing and showcasing of the clear benefits and capabilities of 6G. Multi-tenancy is among the pillars of our intended activities, and this directly correlates the entire effort to the market, because it will be an open activity. It will offer opportunities to those who do not possess the necessary amount of money, resources, whatever may be, to investigate 6G, and this is also an opportunity strongly promoted by our project. So that's all, ladies and gentlemen, by my side. I tried just to give another view, policy-oriented view, and the innovations promoted by the project, so that we have a full image of the concept of the 6G bricks project. And thank you for your attention. Now we are quite happy because we have Dr. Haris Koumaras from the National Research Institute of Democritus. Haris will present us the next interesting experimentation facility. So we would like to hear about the 6G Sandbox.
Thank you, Yanni. Yes, actually, 6G Sandbox is a sister project of 6G Bricks. Hello all. I'm Harilaos Koumaras from NCSR Democritos, the National Scientific Research Center of Greece. Just to mention that Democritos is the biggest national research center and covers a quite wide range of disciplines across different research institutes that operate within the campus. One of these institutes is the Institute of Informatics and Telecommunications, and where our research group, the Front, Future Communication Network Research Group, is operating. I'm going to present you the 6G Sandbox ecosystem, which is actually a sister project of 6G Bricks. This means that we're dealing with 6G experimentation and the provision of 6G technologies for testing and validation purposes. Just a few details on the ecosystem. Let me go a little bit faster. Okay. So the overview of the project of this 6G Sandbox is built, first of all, around 4 experimentation end-to-end 6G platforms across Europe. Now, on top of this 5G, 6G infrastructure, we built some common features which enhance the capabilities and the functionalities of the platform. So, very briefly, we can mention that multi-tenancy, digital twin, intelligence, and security are the common characteristics that we built on top of these 4 platforms. And on top of that, we have the experimenters, which interface with a common way across the 6G sandbox ecosystem. And there is an automated way in order this experimenter to be able to design, to deploy, and execute the experiment on top of these platforms. The main concept of the 6G Sandbox project is that each experimenter is using its own trial network. This means that during the design of the experiment and based on the requirements that the experimenter may have, the system and all this automated tool creates a specific trial network dedicated for the specific needs of the experimenter. Now, the trial network can be composed of either physical, virtual, or hybrid network components, depending on the requirements of the experimenter, but also on the availability of the specific components by the platform itself. Another important actor is the component contributor, which is actually technology providers, 6G technology providers, that can contribute to the platforms external components that can further enhance the offerings of the 6G sandbox ecosystem. Now, all these components are hosted in the 6G library. So the experimenter, during the composition of the experiment, can select which 6G components match better to her own needs, and based on this selection, to deploy his own trial network. Some further details on top of the platforms. First of all, we have some 6G candidate technologies that we are further developing during the lifetime of the project. We have ORAN technologies, reconfigurable intelligent surfaces, RIS, satellite, non-terrestrial networks, beyond 5G, and integration of terrestrial and non-terrestrial networks, deterministic communication, and of course, security and AI, ML components and models. How we realize the trial network? We realize it using the trial network manager, plus providing the infrastructure with coding capabilities. So infrastructure as a code in order to be able to support programmability on top of the 4 platforms. The platforms that host and realize the 6G ecosystem is Malaga platform, supported by the University of Malaga, Berlin platform, supported by Fraunhofer, Athens platform, supported by Δημόκριτος and Cosmote OT mobile operators, and also University of Oulu, supported by the 6D initiative and the University of Oulu. Finally, we have also, I forgot to mention, the digital twinning capabilities. So this means that anything that physically cannot be supported, we have the capability to support it through a digital twin. And this is not an experimental, so much experimental activity, because all the digital twin components are offered in the project by Keysight. Keysight is the project coordinator. So all this realization of the trial network is technically supported also by Keysight equipment, which is equipment commercially available, but also very accurate and very stable equipment. Then we move to the measurement toolbox and testing capabilities. Here we have a very long experience from the 5Genesis project that we developed an automated experimentation framework for executing an experiment, but also collecting the data and displaying the data, visualizing the results. We have further evolution of this framework, experimentation framework, focusing on KPI and KVI evaluation, but also supporting specific use cases like extended reality, haptic communications, and also some sensing, advanced sensing, immersive, let's say, use cases for remote audience, where we have people wearing special clothes that when you are watching a movie, either at home or a 6G-enabled theater, you can sense specific feelings based on what you are watching. So, for example, you can experience pain, you can experience water, and etc. And many more, not to waste more time. Here we have the 6G sandbox architecture. Some more technical details. Here we have the common infrastructure layer, where each infrastructure layer has also an infrastructure manager. More of the deployments that are taking place in the virtualized infrastructure of each platform is cloud native, is based on containerized. Central entity is the 6G library and the trial network lifecycle manager, which is handling, is interfacing with the platform and is handling the deployment, the realization, and determination of a specific trial network. Zooming in a little bit in the 6G library, you can see that we have two main entities there. We host the 6G sandbox experiment automation tools, the ones that we develop for the automated experimentation and execution, and many other auxiliary tools that the experimenter is using during the composition of the trial network. So we have the user requesting a trial network descriptor. We have the trial network templates that can be used as an initial step for designing a trial network. We have the realization and the deployment across a specific platform. And, of course, the user has used also specific components from the library that are also used for the composition of the trial network. Now, focusing a little bit more in the Athens platform, we can, first of all, mention the large-scale 5G/6G deployment that currently exists, and the plurality in the 5G technologies that we offer. So we have different core technologies, Open 5Gs, with exposing capabilities, NEF and CAPIF. This means that these networks can use in order to expose their own data for AI ML applications. And we have also different RAN technologies, either commercial grade, like the Ericsson deployment, the Amarisot 5G RAN that is interfaced with different core networks and can be used for a variety of experiments. There is also Nokia, but also there is millimeter wave that is planned to be deployed in 2024. This equipment is supported both by Cosmoti and Dimokritos. There is emulated satellite integration with terrestrial network, either with different deployments, either with SDN-controlled satellite or with multipath TCP. The idea is to integrate this solution as a 3GPP access in the whole network. The fact that we offer an emulated solution is very useful because minimizes the cost of an experiment. And this activity is performed in combination, in collaboration with Infolysis. This is a high-level topology view of the Athens platform. Very fast to mention that we have two different domains. Here we have the Cosmoti domains in OTE Academy. Here in blue is the Dimokritos domain. Both domains are connected through a dedicated fiber, dark fiber, And we have both data plane connectivity and control plane connectivity. The 5G core is hosted in OTE Academy premises, where we have, which drives different RRU units. And through this dark fiber link, we drive also three RRU units, 2 indoor units and 1 outdoor unit, having in such a way a very large-scale deployment across the 2 domains. Moreover, we have also another 5G SA deployment in Dimokritos. This is the Amarisoft one, with different 5G core technologies and with exposing capabilities, NEF, CAPIF, and some native AI components that can be also used in a complemented way for specific experiments or for handover experiments between the 2 5G equipments. Finally, we have the emulated satellite deployment provided by Phonlysis that can be used for experimentation either between the 2 domains or inside the same domain or between 2 5G networks. So we can have different setups depending on the capabilities. Here we have the same view, but with a lot of technical details. Not to go to many details, here is Dimokritos, Cosmote. We can see that we offer all the different core technologies, but also different virtualization capabilities. We can have Open Nebula as a cloud computing platform. We support also Proxmox, but also other technologies like Kubernetes and Lico for service mesh orchestration, and etc. So it is a very large-scale and complex experimentation platform capable of supporting a great variety of experiments with different requirements. There is also, in Cosmote, just to mention that there is also an actual satellite deployment also as well. Last, and I'm closing, I know I am late, another characteristic of the Athens platform and Malaga platform in 6 Sandbox is the network openness and programmability. And today happens to be the day that we also release the results of the project Evolve 5G, the Evolve 5G service pack. This is a service pack that includes all the tools, the SDK, the NEF emulator, CAPIF, and etc., that any third party can use in order to develop a network application, an application that can be successfully integrated with the core network of the 5G and 6G. This is the results of a project that lasted 3 years, and based on these results, we provide, this is open through our wiki, we provide to the research community, to the startup community, all the tools that can help them to build 5G and 6G applications. That's all from me. Thank you very much.
Thank you so much, Haris, for this detailed presentation. Indeed, as you mentioned, this was another view, but with interesting approaches, also focused on market-related applications, but also giving innovations for technical assessments and technical realizations, quite impressive. And I hope, I also knew the Evolve 5G, which was a very interesting and quite reliable activity that has been completed successfully, as I may suppose. And thank you for joining this session. Thank you for providing this opportunity and for giving us the option to correlate to similar, let's say, experimentation approaches, considering end-to-end connectivity.
Thank you very much, Yannis, for organizing this very nice event and for inviting us. Thank you again.
We will now pass to the next session, session 6, which which is about the establishment of novel frameworks for novel architectural frameworks for the support of 5G and beyond 5G. Here we have 4 presentations oriented to the framework of the Marshall project, which is a very innovative ongoing approach. We will hear about that. And correlated to this, we have also incorporated 2 presentations coming from the HORSE and the Android 6G project. We expect that these 2 extra presentations further extend the novelty relating to the architectural approach for the support of beyond 5G or 6G infrastructures. So I would like now to invite Dr. John Vardakas from iQuadrat, Spain, to give us a presentation regarding the innovative architectural scope for beyond 5G based on the Marshall approach, and we will continue with the other speakers. Thank you for joining, John. Thank you for supporting all of these initiatives these years, and we are waiting to hear for you about the Marshall framework.
Thanks a lot, Jan. Thank you for the invitation. Good afternoon, everyone. My name is John Vardakas. I'm the coordinator of the Marshall project. And I would like to briefly present Marshall. And then, since we are going to listen to other presentations regarding this project, to focus on the innovations of my company, Quadrat, under the framework of Marshall. So, Marshall is about has started at the beginning of 2021, focusing on the proposal and the development of a novel architecture for beyond 5G and 6G networks, by focusing on 3 different pillars of innovation. The first pillar is related to the network design, where we are working on the development of a access approach based on the distributed processing cell-free concept. We are also incorporating wireless millimeter wave solutions for front-hauling connectivity, while also being in line with the Open RAN Alliance. The second pillar of innovation is related to the virtual elastic infrastructure, where we focus on the development of solutions regarding the elastic edge computing, the optimization of the MEC functionality, and the optimization of network slicing. And finally, at the network security design, we have innovations related to machine learning-based mechanisms targeting to guarantee privacy and security in multi-tenancy environment, while also considering both end users and tenants. You will hear a lot about Marshall in this session, so I would like to focus on our work. Our work is under the framework of the second pillar, under focusing on the network management, and our work was triggered by the fact that dynamic service orchestration and adaptive resource allocation became a necessity for the operators that want to manage the growth of the number of users and the support of bandwidth-hungry applications. So the providers must maintain and must improve the service performance, and also reduce the operating cost by optimizing the placement of the different functions that are needed to run for the connections. So the division of the network infrastructure in multiple domains, as it happens in beyond 5G and 6G networks, remains the main obstacle in resource management optimization, because there is a high complexity. So the optimal setting of the network functions, which is well known as the service function chaining, becomes a very complex problem. In order to deal with this problem, we have developed a framework, and an AI-based framework, which we call it Schema. It comes from Service Chain Energy Efficient Management, which is actually multi-agent, energy-aware, distributed RL-based service orchestration framework, targeting to minimize the service latency in multi-domain beyond 5G and 6G networks, where multiple RL agents are deployed in different domains and perform the orchestration of the VNFs in each domain. And since we have different domains, we need also inter-domain migration, which is achieved by offering benefits both at the local level and at the global service function chaining orchestration. So, our approach, Schema, and actually this is Schema 3, which is an improvement of the previous versions of the approach, specifically designed for the Marshall architecture, which is a multi-domain approach. It enables VNF management orchestration in multi-cloud networks by instantiating intra-domain agents for the local placement of VNFs, and then a global approach for inter-domain VNF migration. So we define different domains in the network, where each domain is actually a server. We consider in our approach the parameters related to the computational resources, to the communication resources, and for the energy consumption. Of course, we take into account the fact that the edge domains provide low latency access to the end users, and that services are comprised of a chain of functions. So the idea is to design a framework to operate in a totally decentralized way. And since we want this, we have introduced an auction mechanism, which is actually a module for introducing, which is introduced, to enable inter-domain migration of VNFs. So our approach can be considered as a distributed decision engine with multiple agents at the different domains of the network, targeting to eliminate this centralized point of failure where the auction mechanisms can be instantiated anywhere in the network. Another advantage of our proposal. So, as mentioned, this auction mechanism enables inter-domain VNF migration in a distributed multi-domain networks. And in order to do that, we have defined a specific set of steps. The first is about the initiation of the auction, where we select the next service VNF and showcase the distributed domains, the requirements of the placement. The second step is about distributed operation, where the different RL agents generate their local auction and they propose it to the central authority, to the mechanisms. The third step is about global operation, where this auction mechanism receives all the information from the local agents, the confidence metric of each domain, and then based on its functionality, it selects the highest bidder or the domain with the maximum confidence metric. And then it notifies the candidate domain with an acknowledgement response. And finally, we have the orchestration, where we have different approaches, sub-steps. If the candidate domain is different from the current domain that hosts the VNF, the inter-domain migration is initiated, or the domain agent performs inter-domain migration to the node with the highest confidence metric. And this procedure is repeated indefinitely as long as the network operates. So one of the main parts of this approach is the auction mechanism, which is, as mentioned earlier, responsible for the domain communication. And a very important advantage of this mechanism is the fact that it can be deployed quickly at any node of the network, thus eliminating the single point of failure in the system. And in order to evaluate the performance of this approach, we have compared results of our approach with state-of-the-art VNF algorithms, and we have considered different metrics in order to evaluate the performance. One is the rate of VNR rejection, the average service delay, where our approach performs better compared to the state-of-the-art, as well as regarding the ability of our approach to prevent reconfiguration, VNE reconfiguration. Finally, our approach tends to consolidate the VNFs to minimize the number of hops to the end user, and this, of course, implies that the average delay is reduced compared to state-of-the-art solutions. This is our approach. We are in the final step of evaluating the algorithms. We have already published this approach in a IEEE journal, and we are in the phase of apply this approach in our testbed in our company to further examine the performance of the algorithms. So this is the fact sheet of Marshall. Going back to Marshall, as I mentioned earlier, we have started at the beginning of 2021. We are in the final phase of the POCs. Of course, more details will be presented in the next presentations during this session. So thank you very much, and we also would like to thank again Ioannis for inviting us to this event.
Thank you, John, for your presentation, for your support as a whole in all these events. And we can continue with the next speaker, Mr. Dimitrios Kytharidis from Infocom, from Intracom, apologies, I mean Infocom, but okay. Based on the framework of the Marshall project, we will hear about activities towards 6G networks, wireless 6-hole evolution.
Hello also from myself. My name is Dimitrios Kytharidis, and I work in the R&D department of Intracom Telecom. I would like to thank you, Dr. Hochliuris, for the kind invitation. We will make a short presentation of our work in the framework of Marshall project that John just presented. The title is Wireless 6-hole Evolution, and we will talk about requirements of evolution in the transport network, as we call it X-hole, which includes backhaul, mid-hole, and front-hole, in order to converge to what the 6G vision is in order to support it. So, in the framework of Marshall project up to now, we had the opportunity to work in two main areas. And these are specifically, as we see here, necessary transformations that the cellular network demands from the transport network in order to move to the 6G era. The first one is a new use case that is unveiled for the X-hole networks, the inter-DU communication for the specific use case that we're focusing in Marshall, Open RAN, cell-free, massive MIMO networks. And the second one is the demand for the introduction of a novel interface, as we call it, the innovative X-hole features, which includes advanced synchronization capabilities in order to support what cell-free has to bring in the network. So starting with the first one, the inter-DU communication, the background is that in a cell-free massive MIMO environment, communication is being done by jointly pre-coding transmission information from the base stations towards the users. So this is not a very new approach. It's a pretty old approach, but it's something that has come up again within 6G. It's called now self-free massive MIMO, and is a really promising concept for beyond 5G systems that promise to enhance network coverage and capacity. The inter-EU interface is a non-standard novel interface that allows to extend the self-free massive MIMO to RUs, radio units, connected to multiple DUs, further extending the gain provided by this architecture. What this is that when in a self-free architecture, a user equipment is connected to not one base station, but to multiple specific Open RAN RUs, which might be that they are under the control of different DUs. In this case, in order to coordinate the transmission to the UE, there should be a new link between the DUs, as we call it inter-DU communication. In order to coordinate correctly and in time the data that has to be transmitted to the EU. The objective of this setup and integration was that to prove that an efficient inter-ODU communication based on containers is feasible with the use of high data rate, low latency millimeter wave link. What the use case, as we imagine it in a real deployment, is we have the Open RAN DUs and RUs. We have a distance which has to be covered. We propose to cover it with a millimeter wave link, a high data rate, low latency millimeter wave link. These are the two DUs and the RUs that are dependent on the specific DUs. This was a work that has been done with our colleagues from ICE Wireless in Poland, and the work was integrated in our labs in Athens. So what the setup was that two ODUs from ISW in the form of containers were installed on the same physical server. Each DU was associated with a different network interface, and data from the first DU were sent to the second DU through first a fiber optic cable, a real loopback with a 10 gigabits optical fiber, and then we introduced a millimeter wave link which had the capacity of 10 gigabits per second, obviously with SFP plus modules. And we measured the delay in the first phase of the project between these two for the whole round trip, between the first DU to the second DU. So that's the setup. The two DUs from ISW in a Docker environment in Linux, we acquired a server with two 10 gigabit NICs, and we introduced in between the two NICs a link with at E-band, a millimeter wave link able to support 10 gigabits throughput. So the results were that we were able to measure at the first phase of our test the latency. We can see here the demo setup and the Grafana representation of the data. First, we introduced with a fiber a loopback for the server, so we were able to measure the baseline latency that the DU1 to DU2 had through just the Linux and the NICs, and then which was around 130 microseconds. Sorry, 130 microseconds was the complete one, we will explain that. And then we introduced the millimeter wave link through these fibers, and we saw that the complete latency was increased by around 60 microseconds, which is pretty negligible. So the whole setup was measured in the area of 130 microseconds, which enables us to support with this kind of proposed inter-DU communication, innovative, the 5G communication, hopefully for 6G networks. Now, going on to the second experiment we performed, The need, as we described in the beginning, of advanced synchronization for 6G networks is coming also in the area of transport network. So transport network has to evolve in order to support these advanced requirements that 6G networks would require. One of these is synchronization. So with the evolution of coordinated multipoint in the form of cell-free, as we said before, we need tighter constraints for synchronization. So there is the need for evolution of synchronization distribution of the transport network. In a packet-based network like where we have the mobile networks of 5G and 6G, ITU-T and IEEE have defined two protocols. ITU, synchronous Ethernet, IEEE 1588-2008. Both of these support timing synchronization between in a real packet-based network and end-to-end. So we can have a network like that where the grandmaster can synchronize at every stage of the network the different nodes of the network. In our case, we are supporting in our E-band platforms IEEE 1588, and we realized, we studied, and we saw that for beyond 5G networks and cell-free, the precision time protocol 1588 has to be in the class of C or better. Up to now, the projects that are currently in the market and support 5G are in the range of class B. So we set out to improve this classification. So we proceeded with a specific platform we have in our product line, the E-band product, Ultralink 680. We created a link and we intervened in the FPGA design. We created a new architecture based on TC, not on the transparent clock mode of 1588. So we combined hardware acceleration through the FPGA, innovative frame-based synchronization algorithms, and innovative coding schemes. Through this, we were able to accurately measure, more accurately than before, measure the delay, the latency from one node to the other, and we were able to characterize that, and from our measurements, we were able to showcase that the product in a transparent clock mode was able to be characterized as class C. So we can see that the limit for class C is this purple line, and all our measurements are below in the maximum time error graph. Similar situation in the constant time error graph and the dynamic time error graph. These are measurements that are demanded for 1588 in order to be characterized in a specific class. So through this work, which was a work we've done internally in our R&D, we were able to evolve a specific synchronization class for a transport link, 80 GHz E-band transport link, which is suitable definitely for 5G and promising also for 6G, to improve the classification from class B to class C, which make it a successful candidate for next generation cell-free wireless transport based on the requirements we indicated before, that the coordination of multiple DUs and RUs towards a specific single user require. Thank you very much. I try to be as fast as possible.
This innovative proposal, actually, we expect to see further progress, maybe in the scope of some future European research activities. Quite interesting.
Yes, indeed. And it's interesting that also with our colleagues from ISW, we identified that there is also commercial interest for the Open RAN architecture. So we are thinking of exploiting that further. Obviously, also in the area of research proposals, of course. We plan to continue that. Thank you very much.
Thank you again. We will pass to the next speaker. As far as I can be informed, Mr. Kouzinos will not
No, I'm Georgios Kotos. Mr. Kousinos, unfortunately, could not attend today.
I knew that somebody is to replace him, but actually I wasn't aware of the exact name because of the pressure. Okay, so you can realize his presentation.
Yes, I will try. I will try to fill in his shoes. This presentation focuses around the two European projects that our lab is part of, namely the Marshall and the Serrano project. We have already attended two very nice presentations on Marshall.
If you can go just a little bit.
Yes, thank you. So I will briefly discuss Marshall and then move on to Serrano to present more elaborately. So here we present the two primary challenges of Marshall. Basically, the core idea, excuse me, is to create a continuum of resources that span all the way from the edge to the cloud. By doing this, we allow applications to harvest the unique benefits that each layer possesses. For instance, the near edge comprises low capability devices, but they are situated in close proximity to the data sources and therefore can provide immediate responses. On the other hand, the cloud offers an abundance of resources, but the few data centers are located in distant areas, and therefore higher delays are incurred to transmit the data there and back again. Now consider, for example, a delay-sensitive application, anything related to an autonomous vehicle, for example, pedestrian detection, anomaly detection, automated steering. This can utilize the immediate responsiveness of the edge, while something more complex, like the training of a heavy machine learning model, can take advantage of the virtually infinite resource pool of the cloud. So the goal is to create a virtual elastic edge cloud infrastructure to cater for all these heterogeneous demands. To address these challenges, Marshall adopts several techniques and technologies, mostly machine learning based for the scheduling. And then in the networking front, we have technologies like SDN, software-defined networking, that provides a global view and a global control over the network. And another key concept is the concept of cell-free architecture that gets rid of the traditional cell-based architecture and is supposed to be a cornerstone as we progress and move towards the sixth generation of mobile networks. All right, so this ever so briefly sums up Marshall, and we can move on to Serrano. So the Serrano project aims to provide a more centralized approach to the aforementioned problem of orchestrating a distributed edge cloud infrastructure, but it has a decentralized twist. So I wanted to focus on this bullet here that states hierarchical closed-loop control. Essentially, what is happening in Serrano is that we have a central entity, a central orchestrator, that takes high-level decisions and directs a pool of secondary lower-level orchestrators. We will more on that later. So here we analyze what exactly the edge cloud continuum comprises. We have storage devices of different capabilities spanning the infrastructure. On the computing front, we have what we call here typical resources, and we also account for hardware accelerators, GPUs, TPUs, FPGAs, ASICs. Now, let me remind you that the resource capacity of the edge is far more constrained when compared to the cloud. So a typical resource on the edge might be a basic computer or a Raspberry Pi, while a typical resource on the cloud might be a powerful server with hundreds of CPU cores and terabytes of memory. So this shows just how heterogeneous the resources are. The figure here is also very important. It introduces a core element of Serrano, which is the central telemetry system. More on that later, but let me just say that if you want to make informed and intelligent decisions for allocating all these resources, you need to have an accurate and clear view of the status of all the networking and computing components. So that's what telemetry does. Okay, so here we elaborate on the hierarchical management capabilities of Serrano. We have the service orchestrator, which is the central entity I mentioned before. It takes as input all the workload and the deployment requirements, and based on its analysis, it offloads decisions to the secondary orchestrators that can utilize either standard Kubernetes or the corresponding lightweight platform of K3s for the communication and for the management of their specified domains. Now, a detail I want to add is that the figure might be slightly misleading because it implies a one-to-one mapping between the local orchestrators and the logical layers of the infrastructure. This might not always be the case. For example, there might be a node on the near edge and another one in the far edge or even the cloud, and all these nodes might be in the same control plane of the same local orchestrator. So this is very important. This is the heart of Serrano, because by employing such a hierarchical management, we have a robust, centralized decision-making system while also maintaining some of the agility and responsiveness of localized control. Here we take a closer look at the most crucial part of Serrano, of the architecture, the central orchestrator. We have the orchestration API server that comprises the access interface that acts as an entry point for orchestration services, and the dispatcher that is connected to an etcd base to fetch and manage data such as heartbeat signals or other cluster information. Moving down, we have the orchestration manager that is responsible for the overall scheduling of applications and tasks. And I want to focus on the decision engine, the most important module here, and especially for me, because when I write a paper designing and implementing a new scheduling algorithm, this is where it will be actually implemented and executed in the decision engine. So the decision engine that has the algorithmic intelligence takes as input, on one hand, the deployment requirements of the applications, and on the other, the infrastructure status. The latter is provided by the central telemetry system, which is in general responsible for harvesting, processing, and presenting telemetry data to ensure that the health and performance of every component is constantly monitored, and that effective countermeasures are taken in events like node failures or network link outages, fluctuations in traffic, and events like that. Now on the right, you can see something like a flowchart indicating the interconnections between the different components of the central orchestrator, and it demonstrates the journey all the way from the resource orchestrator to the decision engine and back. And finally, here we have the persistent monitoring data storage interface, which is responsible for fetching and demonstrating historical telemetry data upon demand, upon user query. As you can see in the black box down there, we have things like the CPU usage, the memory usage, the count of restarts, and on the rightmost part, we have the timestamps that indicate when these metrics were actually collected. Okay, so that was faster than I expected. This concludes my presentation. Thank you very much. I hope it was okay.
Thank you for your presentation. Maybe faster, but quite comprehensible, and thank you for that. And also the correlation between Serrano and Marshall in the beginning, just to go to a step further, at least according to my knowledge, was quite interesting, and thank you for giving the presentation. Okay, we will continue this session. The next presentation has been prepared by one of my colleagues, Dr. Alexandros Kostopoulos, who is not present, however, and for this actual time slot, he is traveling by plane, so he has prepared a short video for the fourth internal presentation. We can play the video. Δεν το πρόσεξα αυτή τη φορά.
Researcher in OTE. In this presentation, we will focus on business and market aspects in the 6G ecosystem, and in particular, we will focus on how the Marshall solution, the Marshall architecture, could enable new business roles in the market. Marshall aims to provide an evolved architecture towards beyond 5G, offering flexibility and closed-loop autonomy at all tiers of the infrastructure, Moreover, it aims to provide significantly improved spectral efficiency via cell-free networking. Here in this presentation, we will focus more on the status of the beyond 5G market, as well as how the Marshall architecture could be positioned in this market and which are the new business challenges. 5G technology highly affects countries' economic performance and GDP. In their updated version of the report, The 5G Economy, How 5G Technology Will Contribute to the Global Economy, HIS Market has increased its previous estimation for the potential global sales activity across multiple industry sectors from $12.3 trillion to $13.2 trillion in 2035. This figure serves to illustrate consolidated findings industry per industry. Regarding the AI domain, AI industry is witnessing a migration of AI to the edge. In particular, in a recent research report, the edge AI training and inference market for chipset sales is expected to grow to $10.5 billion in 2025 at a CAGR of 35%. Regarding the network slicing domain, zero-touch service management and 5G cybersecurity market is forecasted to thrive. In terms of estimating the market opportunity, it is not straightforward to find relevant analyst reports, but the network slicing market is estimated to grow up to $921 million by 2027, with CAGR of 23.7% between 2020 and 2027. We observe that media and entertainment industry is projected as one of the most lucrative segments. In another research report, we observe that the global network slicing market is expected to reach $1,284 million by 2025, with CAGR of 51.5% between 2020 and 2025. With regards to the 5G security market, it is estimated to grow to $5,226 million by 2026, with CAGR of 44.3% between 2020 and 2026. In Marshall, we defined two groups of use cases. The first scenario has to do with dense user-generated content distribution with millimeter wave front hauling, and the second one has to do with ultra-dense video traffic delivery in a converged fixed mobile network. The second group has to do with cognitive assistance and smart connectivity for next-generation sightseeing, while the second scenario is more focused on data security and privacy aspects in multi-tenant infrastructures. In the first experimentation scenario, which is about dense user-generated content distribution with millimeter wave front hauling, we may identify different stakeholders, for example, cell-free massive MIMO infrastructure provider, cell-free VRAN VNFs provider, RAN intelligent controller and X apps provider, millimeter wave front haul provider, millimeter wave transport network, as well as network equipment manufacturer. The idea here is to present how a new technology can create new stakeholders entering in the business market, and of course, which are the new business roles that are enabled. Of course, one stakeholder could play more than one role in the 6G ecosystem. In the second experimentation scenario, which is about ultra-dense video traffic delivery in a converged fixed mobile network, we can identify the following stakeholders: the optical access networks and fiber infrastructure provider, the radio intelligent controller provider, the RAN components provider, as well as the network equipment manufacturer. The next experimentation scenario is focused on cognitive assistance and smart connectivity for next generation sightseeing. The idea here is that we have two types of applications, a real-time video analytics and visual guidance, and a cognitive assistance virtual representation of an artifact projected at augmented reality glasses. Here we tackle with aspects of load balancing, network slicing, using MEC capabilities, etc. The stakeholders in this case include the end users, the user equipment manufacturer, the network equipment manufacturer, the connectivity provider, the service provider, the service virtualization platform operator, as well as the applications developer. Again, here we can consider that several roles could be played by the same stakeholder. So in this presentation, we provided a conceptual overview of the current status of 5G and beyond 5G market, what are the most interesting domains for the Marshall solution, and we also presented the new stakeholders and the new business roles that are enabled with the experimentation scenarios that are considered by the Marshall project. Thank you very much, and please let me know in case you have any questions.
Okay, we have, I hope you can hear me. Okay.
Yes.
Okay, we will now proceed to the next presentation. These four presentations, either directly or implicitly, have presented aspects originating from the Marshall project. The next presenter is Mr. Dimitrios Kastrinakis from 8Bells. He will present a work based on the HORSE project, which is about holistic, omnipresent, resilient services for future 6G wireless and computing ecosystems. And the stage is yours. Thank you for joining.
Hello, everyone.
All your colleagues from 8Bells, we do appreciate the fact that you are always close to us and always provide your support and, most importantly, your goodwill.
Thank you for organizing this interesting event, Dr. Hochliuros, and it's always our pleasure to be here. My name is Dimitrios Kastrinakis, and on behalf of the project's consortium, I will present to you HORSE. To your interest, HORSE stands for Holistic, Omnipresent, Resilient Services for Future 6G Wireless and Computing Ecosystems. And although this title might sound quite fancy, in future slides, as we dive deeper into HORSE's concepts, we'll understand and get a better grasp of what HORSE stands for. So I'd like to begin by saying a few words about 8Bells, our company. 8Bells is an innovative research and technology firm based in Nicosia, Cyprus, as well as here, Athens. And at 8Bells, we research the development and application of different information and communication technologies, especially in the fields of defense, security, space, telecommunication, or even e-health and environmental protection. In doing so, we utilize our expertise in systems and network engineering, as well as cloud computing, cybersecurity, AI, and software development. I believe that 8Bells' growth in the past few years has been driven by very specific and rigid development plan that focuses on investing in high value-added stuff and hence the management approach is employee-centric. Now, of course, 8 Bells is not alone in this project. There is actually 14 different partners spread all around Europe that are contributing in the HORSE project. And in my opinion, this is what drives success in research and innovation projects in the European Union, this multidisciplinarity that is present in such projects, and partners that come from industry and academia as well. So, in our project in HORSE, CNIT is our coordinator, the National Inter-University Consortium in Italy, and along CNIT, many different universities, including the Hellenic and Capodistrian University of Athens, the Technical University of Braunschweig, as well as the Technical University of Catalonia, many industry partners like Atos, Ericsson, IFASEC, and of course quite a few SMEs like ourselves, 8 Bells, Zotenet, and so on and so forth. I shouldn't forget to mention HoloLight, which is a very crucial industry partner in this project as well. So, in order to understand what HORSE is all about, I'd like to put yourselves in an imaginary scenario where you are the provider of a light rail service or an underground service, and if you were a provider of such a service, you would find yourself having to deal with multiple problems every day in terms of faults. For example, a broken truck is a common fault that occurs, or geolocation data transmission to control centers is another common fault. And you would understand that because you're dealing with people, you would have to find a way to timely address such issues, as they can lead to disastrous effects. Nowadays, this can be done with ordinary state-of-the-art communicator devices, but you would find out that such devices and such systems of communication lead to low resilience in disaster recovery and low availability in terms of remote operation. Of course, latency is a huge problem. Now, if you would imagine yourself in the second scenario, where you would be a VR architectural solution architect, and you're requested by a manufacturing plant to provide the users, the employees in the manufacturing plant with smart glasses that would facilitate their training and help them restore potential damages, you would find out that the process of analyzing this data is quite tiring, and sending such data to the cloud, process them there using machine learning algorithms, and then returning them back to the facility plant would cause quite a high latency. And at the same place, the renderings are not quite impressive at this stage. The prototype costs are high, and time to market is also not speedy. Of course, when you're talking about sensitive data, this would have quite a few security and privacy concerns, and of course, latency concerns. Now, those two are not random examples, but these are the real HORSE use cases. And at HORSE, we've set measurable and quantifiable targets to improve such problems, the ones that I aforementionedly explained to you, such as improve the downtime in terms of resilience and disaster recovery, or the availability by 20%, or the capability to calculate the operation statistic data almost in real time. The same goes for the remote rendering example, where we're trying to decrease the faults by an astonishing 90%, reduce the cost by 50%, and bring prototypes into the market 20% faster. And HORSE's scope is not simply to facilitate those specific use cases, but to validate the technological components that it proposes onto those two use cases, so that in the future, third parties can use the components that HORSE proposes to facilitate and solve similar problems. And the HORSE does so by analyzing the foreseeable 6D scenarios, and on top of those analyses, develop an AI model that will proactively identify such problems, that is human-centric, that is explainable, and it's extendable to any third use case, any third-party use case. Now, the architecture of HORSE it's quite simple. First of all, HORSE addresses such cases in all three levels, such as a functional level, a network level, and a service level, and does so by monitoring the data through a smart monitoring tool, sending those data to a trustable AI that is built on top of horses policies such as security and the dream of a greener industry, and ensuring reliability, trust, and resilience. At the same time, because most AI decision-making processes are within a black box, the horse early modeling interface includes a digital twin model that will enable the end user to visualize the decision-making process onto their monitors. And of course, all this will be built on top of an intent-based interface where third parties will have the opportunity to bring their own use cases and adapt them on the horse technologies. Now, in doing all this work, we've identified potential organizations for standardization of the procedures, and our ambition is to propose a novel, human-centric, open-source, green, sustainable, coordinated provision and protection evolutionary platform that seamlessly combines advancements in several domains as they get added to the system. In doing so, we're using virtualized and multi-vendor 60-based infrastructures and embrace features of computing, automation, smartness, trust, privacy, and security. Thank you very much.
Thank you for this very interesting presentation, also for being within the time frame. And now I would like to invite the final presenter. We started with John, we will close with John, but this time he will provide information about the Android 6G project.
Yes. Good afternoon again. I'm here on behalf of the Android 6G Consortium to present Android 6G, which is about the distributed artificial intelligence-driven open and programmable architecture for 6G networks. This is an SNSJU project. We are in the end of the first year, so a lot of work has to be done until the end of the project. So, in the outline of my presentation, I will start by giving an overview of the project, then the objectives, a high-level description of the architecture. I will also present the innovations and the three different proof of concepts that we will follow in this project, and finally, how Android 6G will impact on standardization. So, the overall concept of our project is to propose a disruptive set of innovations in the architecture of the emerging 6G networks that will be able to make changes, fundamental changes to the way the future networks will be designed, will operate, will implement it, and of course maintained. And in order to do that, we have defined a set of objectives. The first is related to the architecture, to propose the novel 6G system architecture that will integrate distributed AI framework for combined communicational and computational and resources, and empowers the convergence of networks and IT systems to enable new future digital services. The second objective is about the AI-driven management orchestration design and control framework design for 6G networks. The third one is about to architect a disruptive and secure crowdsourcing concept. The fourth one is to develop energy-aware models for multimodal representation learning. The fifth objective is to evolve the infrastructure of the cellular network in order to allow the true integration of deep edge devices. The sixth one is to enable non-terrestrial networks connectivity for high reliable industrial IoT services. The seventh one is to extend and demonstrate the use of decentralized AI for D2D communications. The eighth is to support data plane acceleration. And finally, the ninth objective is about the proof of concept to integrate and demonstrate the potential and the user value of our project. So we have, from the proposal phase, we have defined the general architecture. This is a high-level presentation of the general architecture, which comprises of three main parts. The first part is the AI-driven management and orchestration framework, which provides the logic and the analytics for network management. The second one is the BDI and AI-driven unified and open control framework, which provides real-time and non-real-time control loops for network automation. And the third part, the third main part, is the fully distributed and secure AI/ML framework for crowdsourcing AI, which provides all this, the entire set of machine learning and AI algorithms for network management. And we are currently working on the definition of all the details of the architecture, and we are looking forward to provide all this work in the end of the corresponding work package and the deliverable that we have to submit for this reason. So for this architecture, we have set up three different innovation streams from the proposal phase. The first one, of course, is about the AI/ML powered optimization, targeting to go beyond this centralized approach that we have today and propose crowdsourcing AI, utilize distributed agents and use regenerative models. The second is about cloud-native network, where we focus on the design of virtual base stations going to the far edge and edge cloud for non-terrestrial networks. And finally, software-driven zero-touch automation, targeting the automated management and operation of the network, and of course to apply open programmability. Specifically about the innovations of the project, as mentioned earlier, we focus on these virtual base stations, where we have UEs as virtual base stations in the network, in the far edge part of the network. We are also working on the development of a novel decentralized AI framework for device-to-device communications, based on this approach of BDI, the belief, desire, and intention agent. The third innovation is about crowdsourcing AI, targeting to minimize the carbon footprint of the application of the ML approach. The third one is about sustainable data usage and generation, learning representations of data collected at the edge and at the far edge using the virtual base stations. The fifth one is about network management, the zero-touch management. And the final set of innovations related to network automation and self-optimization through a closed-loop orchestration in this multi-layer network approach that we have in Android 6G. Regarding the proof of concept, we have defined three POCs. The first is entitled Immersive XR Holographic Teaching, where we have a teacher which provides the lecture at his home or at his a different office, while the students are at the class. And it's not like the lectures during the pandemic, but we target for the students to watch the teacher's holographic entity delivering the lesson. The second POC is about collaborative robots in construction, where we have different robots, different set of drones. They need to coordinate in such a construction site, and this coordination must be conducted not in 2 dimensions, but since we have drones, we need 3 dimensions in order to avoid collisions and enable efficient collaboration of all these devices. And the third one, which actually has 2 parts, is the terrestrial 6G industrial IoT, where we consider a production line, and this production line of an automated manufacturing process, we have different set of sensors and a set of actuators that need to communicate with each other and take actions in very small time intervals, sub-millisecond time intervals. executing different functionalities. And the second one is about the incorporation of non-terrestrial networking, where trackside industrial IoT devices and on-train terminals that send data to a remote cloud are considered. And for these three POCs, we have defined a specific set of KPIs and values for these KPIs, and we aim to demonstrate these POCs under this set of values. We have also identified a set of societal indicators, or KPIs, regarding the innovation, the democracy, and the ecosystem. Regarding the contribution of and the impact of our project to standards, we have set targets, goals for different contributions to different standardization entities. For example, the contribution to the ETSI ENI working group through our work on crowdsourcing AI. To the ETSI ZSM and to the ETSI MEC working group, where we seek to contribute through our work on distributed closed-loop automation. Also, the contributions of the UE VBS computing continuum concept to 3GPP, and finally to 3GPP SA2 group, where we target to contribute through our work on non-terrestrial networking solutions. This is the project overview. We have, as I said, as I mentioned at the beginning, we are at the end of the first year and beginning of the second year of the project. We have 13 different partners from 10 countries. The coordinator is Professor Verikoukis, who has joined the previous session, and the technical manager is Professor Vasiliou from Science, from Cyprus. And more details about the project you can reach our coordinator, Professor Verikoukis, for this. Thank you very much.
Thank you, John, for this presentation. I don't know if, in order to pass directly to the next session, which comprises of two presentations, we have Mrs. Theodoropoulou in connection. Otherwise, we will have a 10 minutes break. I don't know if she has already been connected or not. We can ask her if she wants to make her presentation now. Otherwise, we will have a short break.
Can you hear me?
Elena, I can hear you.
Okay. So I can proceed? I am ready if we can.
Okay, Elena, thank you. Because for the sake of the economy of time, if we can start earlier, thank you for joining this session. Actually, this session will comprise of two presentations that practically demonstrate how we deploy infrastructures for the support of 5G. I will give you the stage to give more details.
Can I share my screen? Because I have some animations in my presentation. Can you see my screen now?
Not yet. We can see you, but not your screen yet. Maybe you try sharing again.
Now we can see your desktop.
Oh.
Elena, Elena, better to upload already your presentation on your desktop and then try to share.
Okay, let's move with the version that you have, and I will ask from you to change the slides. I don't want to waste your time.
They say they cannot. Maybe if you can upload your presentation on your screen and then share. Open the PowerPoint, have it uploaded on your screen and then try to share.
But it is uploaded. Yanis, could you please use the one that you have and...
Okay, they say that they can play, but we will not see the presenter. We will only hear comment from the presenter. They say we have a problem. If you can try for one last time, Elena, maybe, because there is no feedback. If they upload your presentation, then you will not be able to see and comment.
Okay.
Just have your PowerPoint on the screen, not in a folder, because sometimes when you want to share and you have to go in a folder, these tools like Zoom do not work properly. Just have it on your screen and then try to share your screen, if it may work like that.
Ελίνα, τη βλέπαμε πάντως στην οθόνη σου κανονικά πριν.
Και έτσι.
Τώρα το βλέπουμε το desktop.
Okay. Excellent.
Excellent. At last. At last.
I know you insist and you always find solution even in hard cases. So I had no doubt that you will reach.
Okay. Thank you very much. Good afternoon, everyone. I am Elena Theodoropoulou, Mobile Network R&D Program Section Manager. I wish I were there physically, but force majeure forced me to go online. Before starting, I would like to thank once again Yannis Koklouros, who keeps this organization alive with high dedication and professionalism, and has made this Infocom workshop an event that we are all looking forward to participating every year. I will give you the background and the overview of the project that I am going to present, the 5G Seagull project, and I will say a few words about the key objectives and the use cases envisioned. First of all, the 5G Seagull project is a SEF digital project. This program is implemented by HADEA, aiming at boosting the investments in 4 key areas. The cross-border corridors, and this is the area where 5G Seagull falls into, the 5G smart communities, backbone networks, and synergy projects in digital, transport, and energy domains. the infrastructures that are being funded to be implemented will remain in the state members after the end of the projects, and they have the ultimate goal to play a key role in Europe's transformation and competitiveness. The main goal of the 5G Seagull project is to provide seamless and uninterrupted connectivity along a significant part of the Orient-East Med corridor that comprises one of the major European transport paths and includes the Greek-Bulgarian border crossing of Promachona-Skulata. This ambitious goal will be achieved with the deployment of beyond state-of-the-art 5G standalone network, including access, transport, core, and edge segments, along 473 kilometers from Velestino in Thessaly to Sofia, Bulgaria. As a SEF project, it is an implementation-oriented project, although it has a research dimension, as you will see later. The consortium consists of 3 partners. Wings is the coordinator and 2 mobile network operators, A1 Bulgaria and Cosmotech Greece, that is also the technical manager of the project. 5G Seagull has a 3-year duration starting from 2023, and the total budget is 11.5 million euros with 50% funding rate. 4 are the key objectives of the project. Firstly, to provide uninterrupted connectivity based on 3GPP Release 16, capable of supporting selected advanced connected automated mobility use cases, including the cross-border section. Secondly, to investigate the optimal roaming configurations to support CAM traffic. A third objective is to validate the network and applications performance through extensive field trials. And last but not least, to deliver a thorough business and techno-economic analysis for the entire corridor. Some more details. We have started the implementation in phase 1 based on 5G non-standalone architecture, while in phase 2 we will deploy a 5G standalone core network. We will deploy uninterrupted 5G coverage at 700 MHz along the entire corridor, and we will enhance the border crossing at 3.5 GHz to achieve higher data rates. The support of CAM services requires at least 20 Mbps throughput, 20 milliseconds end-to-end latency, and 99% reliability aligned with the requirements of the 5GAA CAM use cases. Phase 1 will last until mid-2024, when phase 2 starts. In phase 1, among others, a new border gateway will be deployed and direct interconnection between the 2 networks, Thessaloniki, Sofia. While in phase 2, the edge network at Thessaloniki will be further enhanced to support the CAM services with the new UPF and additional functions. As far as the access network is concerned, a significant number of existing base stations will be modernized, and some new G&Bs will be deployed by both operators. Currently, the border crossing has already been enhanced at 3.5 GHz. And here you can see the plans of the 2 mobile operators per year regarding the implementation of the base stations. Regarding the roaming configuration, which is the research flavor of the project, we have promised to deliver a blueprint focusing on challenges, recommendations, and so on, to serve as a handbook for other mobile network operators to implement. This blueprint will be derived in synergy with peer projects, such as the Deluxe project, in which Deutsche Telekom is a partner. In both phases, phase 1 and phase 2, we will analyze the use cases under different roaming configurations, and we will evaluate the direct interconnection between COSMOTE and A1BG networks. Of key value for the project is the work done by 5GAA that has defined a wide list of CAM use cases along with their respective requirements that can be projected to the studies by 5GPPP. Based on them and inspired from them, we have selected a short list of use cases that we will focus on and demonstrate. The validation will be performed via extensive field trials against requirements and KPIs that we have identified and analyzed. In addition to the conventional cars with OBUs and smartphones and so on, we are trying to proceed with synergies with the peer projects so as to have vehicles of higher level automation capabilities available. The business and techno-economic analysis will take into account the stakeholders and their role, business models, procedures to configure and operate the networks, security requirements and the relevant audit results, as well as the experience gained from the 5G MOBIX, the 5G PPP project that dealt with the CAM services at the Greek-Turkey border crossing and COSMOTE participated in. Now, regarding the use cases, the project has selected 5 use cases. The 2 basic ones, packet switched voice and video as relevant to the validation activities. Through them, we will validate the ability to maintain a voice call during network reselection and inter-PLMN handover without the call being dropped. And as far as a video call is concerned, without the call being dropped or freezing for more than a few seconds. In the diagram, you can see the roaming interconnection between the 2 core sites. The other 3 use cases are CAM-related use cases. One belongs to the convenience category and more specifically infotainment. We will demonstrate video streaming while the vehicle is on the move. In the diagram, you may see the streaming application hosted at the cloud. The other one is about transport safety, convenience and sustainable goods transfer, where the 5G technology enables transport logistic companies to improve their services. Vehicles will be equipped with 5G-enabled cameras and sensors to monitor the transfer in real time, and the 5G network will provide high speed and low latency for visualization of alerts in case of a problem, enabling the cameras and sensors to capture and transmit data in a reliable manner. In this use case, the Wings platform will be used. And finally, the 5th use case belongs to the safety category, in which we will focus on data sharing for real-time situation awareness and traffic information. Low latency is of ultimate importance for hazardous events notifications. To achieve this, the application server needs to be hosted near the access network, which is depicted in these diagrams on the 2 sides of the borders. The vehicle will be again equipped with a variety of sensors, such as GPS, accelerometer, gyroscope, cameras, LiDAR, wiper sensors, light sensors, and so on. Each OBU will collect data from those sensors, for example, in harsh weather conditions, slippery road, heavy rain, and so on, and periodically uploads them to a traffic management system. It will also detect events such as an unforeseeable obstacle, or an accident, or a traffic jam, or construction works in the area, and instantly sends them to the traffic management system, while receiving data and alerts from other vehicles in the vicinity. The traffic management system receives and processes the data shared by the vehicles and instantly sends alerts to the vehicles residing in the specific road segments. And at this point, my presentation comes to its end. I will be happy to answer to your questions, if any. Thank you very much.
Thank you so much, Elena, for the detailed vision, the scope, the use cases, the challenges, the objectives. It's a challenging effort, but it progresses well. And I feel it is important also for the audience to see that some development activities, which also implicate for some research part, are at the forefront of investments nowadays. Both the European Commission and member states promote development of infrastructures, and this is a characteristic example, the cooperation between two operators in Greece and Bulgaria in order to realize this 5G coverage for the related corridor. Thank you for your presentation.
Thank you very much. Thank you very much.
Okay, we can now pass to, thank you again for joining. We will now pass to the second part of this session, which is a presentation, again in a video, prepared by Dr. Kostopoulos. As I said before, Alexandros is traveling and he is potentially
Hello,
on the
everyone.
plane.
My name is Alexandros Kostopoulos.
You have it? You can play the video.
Yes, yes.
Okay.
Hello, everyone. My name is Alexandros Kostopoulos. I'm senior researcher in OTE. And this is a joint presentation with Ioannis Kochliouros about Ambitious Project, a project about boosting digitalization across European regions. Here you can see some basic information about the project, the call, the type of action, the proposal acronym. The full title of the project is Advanced Computing Continuum Solutions for Boosting Digitalization Across European Regions, and the duration of this project is 3 years. The main goal of Ambitious is to provide a fundamental technological infrastructure which will offer advanced data aggregation and cleanup, analytics, AI-enabled forecasting and secure information exchange mechanisms via a transparent computing continuum infrastructure to be integrated with existing mature services of at least TRL6, Technology Readiness Level number 6, of the relevant stakeholders, unleashing for them yet unforeseen functionalities and opening up new pathways of commercial exploitation. The envisaged fundamental infrastructure, which will be provided via the development and deployment of technological pillars, which will interact with existing services towards supporting and envisioned functionalities. The purpose of a pillar is to provide the same generic functionalities to diverse services, demonstrated by a diverse set of specific use cases as a concrete processing chain aiming at avoiding unnecessary redundancy of resources and budget. New participants can easily join via the open calls the project will organize. Ambitious Project aims to address a number of the challenges that are important to European companies to be competitive on the world market. By advancing their expertise in areas such as data analytics, AI, 5G, computing continuum, and IoT, the European SMEs can address challenges both within Europe but also grow and become more competitive in the global market sector. Ambitious is focused on safety, including surveillance and monitoring, smart water management, precise agriculture, and innovative digital health and well-being services, while simultaneously it aims at improving competence and attractiveness in European SMEs. The core of the project is focused on scaling up digital innovations, currently at minimum technology readiness level number 6, demonstrators of state-of-the-art technologies such as data analytics, AI-enabled prediction mechanisms, 5G, computing continuum, and IoT sensing capabilities, plus contributions to the overall of the digital value chain by supporting collaboration between different EU member states, SMEs, and the academia, and in particular via facilitating market uptake and scaling up of innovative R&D results. At the core of the ambitious project are activities and tasks to stimulate inter-region collaboration, technology transfer, and development of novel digital solutions. Ambitious involves 4 different countries and several regions across Europe. Ambitious will create links between public authorities, regions, authorities, industry stakeholders, SMEs, larger enterprises, academic institutions, and citizens. And Ambitious will also promote both the interregional exchange of technological know-how and the deployment of novel business models, not only for the participating SMEs, but also for third-party SMEs that will be attracted by related calls and project success stories. By providing several testbeds in Sweden, Finland, Italy, and Greece, participating SMEs will have first-class access to multiple sites to perform early technology tests and, most importantly, complete trials of digital products and services they intend to offer in the market. By providing several testbeds in Sweden, Finland, Italy, and Greece, participating SMEs will have first-class access to multiple sites to perform early technology tests and, most importantly, to complete trials of digital products and services they intend to offer in the market. In order to meet the requirements of their respective European calls, Ambitious is divided in 2 technological pillars, providing a virtual backend of raw data aggregation, management and analytics, generic AI-enabled forecasting mechanisms, and data communication and exchange platforms, all residing at a transparent computing continuum infrastructure that blends cloud, edge, and IoT resources. All these fundamental technologies will be exploited by properly designed use cases, which will integrate their own specialized mature services with advanced data analytics, prediction, and secure communication capabilities. These use cases will be evaluated in situ at appropriate regional, interregional demonstration sites that will act as our success stories, which will attract new stakeholders willing to exploit the proposed machinery for the sake of their own services and business plans. In this slide, we can see the main pillars, the main aims of our project, which includes advanced data aggregation, cleanup, analytics, AI-enabled forecasting, and secure information exchange. The technological pillar that provides the same generic functionalities to diverse services. The IDA pillar, an AI-enabled data analytics and forecasting platform, and the Agora pillar, which is focused on the cooperation and data security in health and well-being, and also the several use cases to demonstrate the added value is involvement of third parties. All the aforementioned aspects will be tackled via transparent computing continuum infrastructure. The IDA pillar will be focused on AI-enabled data analytics and forecasting, and in particular on real-time monitoring and surveillance applications, gather measurements, clean up noise, visualize analytics, as well as allowing humans to make decisions to improve utilization. The role is using computing continuum technologies, sophisticated data analytics engine, as well as AI-enabled event forecasting module. And the corresponding scenarios include social capital at cloud disseminated to several edge devices, providing advanced classification or forecasting tasks, as well as AI-enabled forecasting services at cloud, which will feed all interested applications with real-time streams of predictions and emergency alerts. In this use case, we aim to integrate a mature IoT platform with an AI platform towards AI-enabled forecasting prediction system for marina surveillance and emergent incidents in real time, as well as to extend current services of the platform towards semantically enriched information. The solutions include detection, open area surveillance, berth allocation optimization, and the corresponding demo sites are Patras Mega Yacht Marina and Egaleo Public Park. The second use case focuses on smart water management. Here we aim on having novel AI operations for advanced analytics and also to extend existing solution and implementation of intelligent management tools for water supply and distribution networks. The solutions include leakage detection, prediction of water and energy needs, as well as prediction of potential urban flood. The demo sites here are Patras Mega Yacht Marina, Egaleo Public Park, and also Savonia UAS Kuopio in Finland. The next use case is focused on precision agriculture. Here we aim to boost precision agriculture towards increased yields and efficiency, utilize smart devices and sensors in existing platform, and extend the platform with a sophisticated data analytics engine and an AI-enabled prediction module. The solutions here include a plant disease detection by using captured images by UAVs, as well as crop irrigation optimization to predict water needs using historical data and current environment conditions. The demo sites here are farms in western Greece, where a wide range of IoT sensors, actuators, and cameras will be installed for collecting, processing, and analyzing this data. The next use case is about intelligent living as a service. Here we aim to assess the ambient living conditions of the end users, to perform a primary screening of the end user's health status, and extend the current platform with a data analytics engine and an AI-enabled prediction module. The solutions here include herd malfunction detector, as well as fall detection, which actually is algorithms implemented and executed on the edge based on acceleration data collected by wearable devices. The demo sites here include the installation array of IoT devices to collect vital data in Western Greece, an elderly care in Western Greece, and an elderly care unit in the municipality of Egaleo. Last but not least, the fifth use case is focused on innovative digital technologies for real-time monitoring. Here we aim to provide a holistic solution for supporting real-time data acquisition of high bandwidth streams, integrate real-time data streams with an IoT cloud solution for large-scale data processing, and the definition and implementation of distributed functionalities for task allocation and placement at the edge cloud continuum. The solutions here are capable of data handling, device management, security, and visualization, as well as using different communication technologies, including 5G, Wi-Fi, Ethernet, mesh topologies, etc. The demo sites here are LTU, testbed, the 5G testbed in Sweden, as well as Patra Mega Yacht Marina, where edge computing testbed, an edge computing testbed for testing interoperability and compliance will be used for evaluation. Thank you very much for your attention, and I will be glad to answer to any questions you may have. Thank you.
Okay, with this second presentation, we have concluded the related session, which was about activities for deploying infrastructures or providing facilities in general. We have seen the first case, the 5G Seagull, which is the activity for the deployment of 5G connectivity and appropriate infrastructure between Greece and Bulgaria. The second project, the ambitious project, promotes some IoT-based applications and solutions, considering also artificial intelligence, and intends to offer opportunities for third parties to access as well the intended platforms that will be developed by the partners. So both projects demonstrate that research and development are not far from the current needs, are very close to what the market really implicates for. And I hope this was a good overview in order for the audience to collect related feedback. We will have a short 10 minutes break, and we will pass to the next session that will cover aspects from 4 projects: the Phonics 2X, the Tracy, the CyberSec Dome, and the Rewire project. Mainly, the aim of this session is to identify artificial intelligence for the support of cyber resilience and cybersecurity in the scope of modern 5G and beyond infrastructure. We have 4 speakers, and we expect to hear from these presentations the particular role that AI is to play to perform towards this aim for the support of resilience and security in cyber-based environments. But for now, I think that we can have a short break. We have 4 projects that will discuss aspects about AI inclusion for the support of cyber resilience and cyber security. We start with Mr. George Daniil from the University of Patras. He will present several aspects coming from the Phonics 2X project. The stage is yours.
Thank you very much. Hello, everyone. My name is George Daniil. I'm here representing University of Patras, the coordinator of Project Phoenix. Phoenix is a European cyber resilience framework with artificial intelligence-assisted orchestration, automation, and response capabilities for business continuity and recovery, incident response, and information exchange. The clicker is not working. Excuse me, the clicker. Perfect. Today we will cover all the different aspects of this amazing project. Let's start by focusing on Phoenix framework. Phoenix aims to design, develop, and deliver a cyber resilience framework providing artificial intelligence tailored to the needs of operators of essential services and their national authorities. Of course, we are aligned with all the EU directives. Phoenix, in general, will assist operators of critical sectors achieve cyber resilience and also support national authorities in enhancing national cybersecurity capabilities, cross-border collaboration, and national supervision of the critical sectors. Operators of essential services will gain lots of things by working with Phoenix. enhanced situational awareness with AI-assisted prediction, proactive and reactive resilience automation, orchestration, and response mechanism, increased preparedness through relevant serious games, timely and actionable information exchange between them and their national authorities. Here you can see the conceptual architecture of Phoenix. You can see that it has 7 different blocks that are interconnecting and focus on Phoenix's main goals. Also in this slide, you can see the most important part of our architecture, the baseline prevention tools, that when they work simultaneously, can all address very important issues and that can all be beneficial to our stakeholders. Let's see now our 6 main innovation directions. To begin with, we aim to be ready when an attack takes place, so our preparedness through cyber range and serious games can be beneficial for our partners. We focus on AI-assisted situational awareness, prediction and response, and provide multiple assets to our clients, like user and entity behavior analytics, CTI discovery, analytics threat hunting, attack prediction, response recommendation, and adaptation. Also, we provide risk impact assessment and prioritization. We work a lot with playbooks in order to create automations through aspect-oriented playbooks. Our playbooks will be adaptable and contextualizable, customizable, shareable, translatable, and we have the support of a lot of different what-if scenarios. As I mentioned earlier, Phoenix focuses a lot on business continuity of our stakeholders. So we're doing that by providing a resilience, orchestration, automation, and response mechanism with resilience playbooks and with an adaptation and a small extension that we did for Cacao Oasis specification. Our predictive maintenance uses supervised and unsupervised learning approaches to predict intrusions and propose specific actions to proactively prevent whatever attack may occur. Our last main innovation direction is connected with the national authorities, alerting, reporting, and information exchanging mechanism that provide the ability to operators of essential sectors to conduct their appropriate national authority with a specific way. Let's focus now to our use cases. We have 3 different use cases. The first one that you can see here is based in Greece and supported by Cosmote and PPC. NCSA is overseeing it. The transport use case based on Spain, and finally the healthcare use case based in Cyprus that is also supervised by Cyprus' relevant national authority. Let's see now the different incident scenarios that we are bringing in each use case. The first use case, we have 2 different incident scenarios. In the first one, we will be a massive cyber attack against smart meters at either residential houses or even at industrial customers. The second, though, attack will be DDoS attacks against the MII headend. On the second use case, we will provide data security and integrity for the whole end-to-end IoT solution. We will also focus on alert generation and data integration that, as we know, is very important in the railways. On the third use case that we said that's in Cyprus, our incident scenarios will be based on supply chain attacks to the public healthcare system of Cyprus, such as unauthorized commit, malicious deletion of a source code branch, and also some malicious use of a compromised library that may be inside their software. Our next steps, you can see them here, but also in general, it's to mainly continue the creation and integration of all these tools while keeping in mind the holistic concept and vision of Phoenix as we described it 1 year ago. This is our consortium, and we would like to thank especially Cosmote, Mr. Liberopoulos and Mrs. Theropoulou for inviting us here, and Dr. Chochliouros for organizing this event. Thank you very much.
Thank you. Thank you very much, and in particular, thank you very much for summarizing all this rich content within the requested time frame. Very interesting approach. Thank you for your support, and hopefully we can see you again in a future presentation.
Thank you very much.
Thank you. I would like now to invite Dr. Manolis Tsangaris from Performance Technologies, who will present aspects from the TRACE European project, another view, challenging and interesting, as you will find out.
Thank you very much. I'm very happy to be here. Thanks for the invitation. I'm giving this talk instead of Nikos Avgerinos, who's actually on a different talk the same day. So we're going to talk about Tracy, which is a big data analytics methodology e-evidence system in the context of an EU-funded project that we'll see at the end. Probably you have seen this cartoon a lot of times. It's from New York Times. It is the cartoonist depiction of crime resolution, and you can see pictures on the wall and strings attached to them relating the suspects together. This looks like old-fashioned, but actually this is, to a certain extent, how things are still done today. So they all lead back to this ball of yarn. So it's actually a very convoluted piece of evidence. So the work they do in the law enforcement agencies is to go from evidence to suspects and then to some resolution. So everybody is innocent until proven guilty. The evidence links suspects to crimes, and the job of the detectives is to iterate through this all the time. So how can we help them to do this job? Oh, I realize I have a screen here, I see. So, you know, before Tracy and other systems that actually do similar work, law enforcement agents had to process a ton of data. And if you have to process tons of data, then you're going to miss some of them, which include eyewitness reports, material from cameras, license plates, and also the so-called mobile non-content data. So as they collect this data, which is the evidence, then they try to link them together in this hypothetical problem. I'm trying to trace criminals that have created, have participated in some crime, and I have various, at various locations and different times, evidence about them. So how can we piece this thing together? Because very quickly it becomes so convoluted, and even more than that. Typically they have hundreds, if not thousands, of suspects and lots of pieces of evidence, okay? And then what we come to do here with Tracy is to provide answers about suspects, scores, and their relationships. So we're going to piece together the evidence graph, and then from there separate the suspects depending on how much guilt they appear to have based on the evidence. So it is really, it looks like this, where we, based on various properties of the evidence, we put together this, we separated the two red lines which correspond to two suspects, and two key pieces of the evidence shown here with the yellow stars have actually played a determining role on that, okay? So as any analytics approach, we need to piece together an ontology, okay? The ontology describes the problem, and the ontology really has to do with how do you model the world. So without going into a lot of detail, we have evidence data, which is images or license plate numbers or eyewitness reports, and of course mobile network non-content data, which approximately trace how the persons have moved around. We also have some other evidence information that is derived from the evidence data. So an image can produce a face, and the face can be attributed to a particular suspect. A license plate number can be extracted from images, and also trajectories of terminals, such as the one you saw in the previous picture, can give you an approximate trajectory of the person, or actually the terminal that the person was supposed to be holding. And then we have created a suspects model, which is related, it captures the presence of suspects on different locations and times, and also the suspect-to-suspect relationships. As you know, they work together usually to commit a crime. And then the event model is everything else that we have here. And now armed with the ontology, we can go on and apply constraints onto the evidence and generate the graph that suspects that gives the best matches. Okay? And also provides observability in this process. One key thing of Tracy project is to have observability, to be able to see through the black box. Actually, the black box is not such a black box. All the algorithms and the steps and intermediate information is available to the police detectives so they can check through the process of how this algorithm works. And then interactively, they can loop through, apply more evidence, more constraints until they get to a resolution. So to make it more concrete here, let's assume that someone has been seen near A. A is the scene of the crime. This is a map of Athens. And then it has been seen also near B. What has it been seen is through a sequence of cameras, the same suspects have been, let's say, traced through a series of private or public cameras that moved about there. And then those guys went and left their a stolen car, a stolen motorcycle rather, that they used during the crime, and it was found on C. And then they stayed, they passed C at approximately 1:10, according to the eyewitnesses, and then it went to their safe house, which is D here, and they stayed there. So the constraints we have is near A around 1 p.m., near B around 1:10 p.m., and so on and so forth. So those constraints, if they apply to the evidence data, hopefully they can give us some best matches. So one key element and one key evidence data that we use in this project is the so-called non-content data or mobile signaling data. It is true that if the criminals have used terminals, they have used mobile terminals, then they leave a trace behind it. And although going from the network data to the actual location is a process that is very approximate, it has been seen through simulations and from actual data that it can be very close. And in addition, when we apply the constraints, then we can separate out the people, the terminals that were present at A at that point, and then they went up to D. And there are much fewer candidates, victims, that satisfy those constraints. So what Tracy will do is to give the best matches, as you can see in the red bullet there. So it's going to tell you that terminal 1, we have decided not to be concerned with the user of the terminal, but stay at the terminal level. And yes, the criminals, exchange terminals and change SIM cards, etc. But for the sake of this project, we trace terminals and not people. By terminals, we mean mobile terminals. And so at the end, they're going to produce a score, and which are the most likely terminals that match this profile. Okay? And that seems to be appears to be a very valuable tool to the law enforcement agents, as we have seen from all the discussions we have with them. They do it today, but in a very rudimentary and very kind of primitive way, not through observability, not through analytics and tools. They use, sometimes things like what you saw in the cartoon of New York Times. Okay, so hopefully Tracy will be used to prove that it can do this. But how can it do that? This picture is probably familiar to you. It's kind of elementary for other audiences, but pretty much it shows how the handoff between two cells happens depending on one major condition, which is the signal strength. There are other reasons that handover happens, but there's a relationship between the serving cell and the location, and that relationship in urban areas is kind of tight. Of course, modulo, umbrella cells, and reflections and things like that. But we're looking for a correlation, not necessarily determining exactly the position. So if we get this data, then along with the other evidence data, we can go on and produce interesting results. However, it doesn't seem to be easy to get this data. Although the law enforcement agents, as you know, collect non-content data today, they're not available for any public consumption, research, etc. And also they're very spotty because they use multiple data collection requests. So in order to overcome this problem, of course, we had to simulate ourselves out. So I'm going to skip this slide to go directly to that. We have used some open source tools and added some integration logic to simulate the mobile network traffic of a town segment. So if this is a town segment, then we can simulate residents, vehicles, and visitors going into the segment and moving about it for a duration of time. And then simulate, of course, people motion in a kind of satisfactory degree. Of course, you can never simulate exactly what people do. And then also simulate the mobile network events of a hypothetical mobile network serving this area. Having all this, now we're getting a synthetic data set, which we have been using for developing those algorithms, because we hope that we will get this the chance to try the algorithms on real data at some point in the middle of the project. I'm also going to say that the Tracy synthetic data set has been validated with data we have collected from the network using our own devices from the side of terminal to kind of get a feeling if our simulator is realistic or not. Okay. So the benefits and the challenges of this project is that we want to bring methodology, analytic methodology to LEAS, because believe it or not, this methodology is not that present there. Okay. We want to help them using that technology to faster converge into crime investigation and also be able to assume the resolution of many more crimes. We want to give them full observability so they can check that the algorithm is correct and trust it. And there are challenges such as mapping real cases into the Tracy methodology, as exists with anything we do, and how to collect and curate the data from mobile network providers. Right now, we're in the first year of the project. We're developing the capabilities, and we're getting ready to resolve real cases. Okay. They'll have a website, Tracy Project EU, where you can find more information and some pictures. By the way, their last 3 pictures have been generated by AI, which is kind of interesting. And they pretty much depict everything that I like the cartoonist more, by the way, but those have something interesting. And finally, a few things about the consortium. Of course, it includes users, end users, Hellenic Police, Romanian Police, Moldova. We have Cosmote. We're very happy to have Cosmote as a member of the consortium, and other partners from all over Europe. And we're moving along fast to converge and deliver the project, okay? And I hope I'm okay with time. All right, thank you very much.
Thank you very much for your presentation. Quite interesting to see how such applications are also correlated to activities for the support of law enforcement agencies. Another view, quite important, we will see such applications as artificial intelligence and modern technologies penetrate further in our everyday life. Now I would like to invite the next speaker, Mr. Dimitrios Papanikas from OT Group, IT department. He will present an overview and some aspects from the ongoing CyberSec Dome project. Thank you for joining, and we are waiting for your presentation.
Thank you very much. My name is Dimitris Papanikas. I work as an IT security architect in the IT security services department of OT Group. And in cooperation with the IT Innovation Center of OT Group, we take part in CyberSec Dome project, which is an Horizon 2022 project. It's a fresh project as it started 3 months ago. And the project title is an innovative virtual reality-based intrusion detection, incident investigation and response approach for enhancing the resilience, security, privacy and accountability of complex and heterogeneous digital systems and infrastructures. This is the project consortium. As you can see, they take part from several domains, from the industry domain, OTE, the Athens International Airport, from the university domain, the Technical University of Munich and so others, some SMEs and an association concludes the consortium. The project objectives of this European project is to increase the preparedness, the disruption preparedness and resilience of digital infrastructures. As it is a new, fresh project, in this other development, some security tools. The CyberSec DOM security tools suite will be developed to detect and recover from security attacks as quickly as possible. By leveraging the artificial intelligence, the security tools will use algorithms in order to better detect incident, assess the ongoing risk on an organization or an enterprise, and respond to attacks and recover from any security incidents. Also, by utilizing virtual reality and digital twin technology, the project will develop an interactive, collaborative user interface in order to provide to the CyberSec DOM users better situational awareness and of the system that is under attack in each moment. Also, they're going to be provided the dynamic cyber incident response capability for the digital systems and the infrastructure of the organizations and the enterprises that will use the CyberSec DOM security suite tools. The project consortium will develop a dynamic and adaptive incident response tool that will ensure the selection and adoption of the responses to cyber incidents. We tend to dynamically, quickly, and autonomously respond to any security incident in order to optimize the response time of the security teams. Also, by using artificial intelligence-based methods, we will provide effective and real-time management in a proactive way for leveraging the security posture of an organization. And also, an intrusion detection prediction tool will be developed with the use of intelligence that will by leveraging the artificial intelligence, the project consortium will build algorithms for deep analysis of network traffic and threat-related information. Also, the virtual reality interface will offer interaction with algorithms and human users in order to offer better visualization of the security incident response teams and remote collaboration support with the other teams that are related to a security incident. Finally, some automated penetration testing tools will be developed and are tend to be used with data-driven artificial intelligence in order to automate the penetration testing method. OTE's participation in this project is as a pilot user. As you know, we have a digital, very complicated digital infrastructure. Therefore, we can be a unique pilot that handles a vast amount of sensitive and personal data. So we are going to evaluate the CyberSec DOM security suite that will be developed in terms of some KPIs that we will see in the next slides. Our challenge in this project is that we need to strengthen our security posture against new types of cyber attacks by using up-to-date detection and prediction tools. Also, we operate as a traditional security operation center, and we need to provide more flexible security monitoring solutions to our security analysts. It is expected to improve its cybersecurity systems and monitoring processes, as we said, through the use of the CyberSec DOM security suite. All the cybersecurity issues will be recognized by CyberSec DOM and will be evaluated against the tools that we currently use for the same processes. And we will evaluate also the virtual reality interface in terms to facilitate the monitoring process of the security analysts. In our pilot use cases, we will implement 3 attack scenarios: the distributed denial of service attack, ransomware scenario, and Windows domain privilege escalation. The cybersecurity DOMS tools will be evaluated against the monitoring tools that we now have for these types of use cases. And we have some KPIs for the evaluation. We believe that we will try to evaluate the new tools in order to reduce the downtime during an incident, reduce the amount of time that the security analyst needs to detect an incident, and also we will check the number of reported incidents compared to the CyberSec DOM security suite. Thank you very much.
Thank you very much also for being within the preserved time slot. And now I would like to invite again Mr. Alexandros Dimos from 8 Bells. He will present some aspects originating from the context of the Rewire project.
Thank you very much, Mr. Dr. Chouchouros, again, for inviting us in this event here today. I'm Alex, and I'm from 8 Bells Ltd. Our company is based in Nicosia, Cyprus, and Athens, Greece, and we specialize in a wide variety of research fields like defense, security, space, and telecommunications. And we also deploy a strong arsenal of technical capabilities in our company. Also, 8 Bells empowers a more than competent staff in order to support and deploy those capabilities. In the context of the Rewire project, we are part, of course, of a larger consortium spanning all across the European Union with 13 partners from 8 European Union countries. These include 3 industrial partners, 3 service providers, 4 research institutes and universities, and 3 small to medium enterprises like us. In a nutshell, Rewire aims to provide a holistic framework for continuous security assessment and management throughout the entire life cycle of IoT devices under the zero trust concept, while at the same time adhering to the security by design principle. The duration of the project spans from October of 2022 until September 2025, and as we can see, the European Union has allocated a significant fund of over 4 million euros in order to make this happen. In order to better embrace and understand Rewire, we must first embrace its vision, which is never trust and always verifying. So, Rewire envisions a holistic security management framework that safeguards the development of IoT environments through the entirety of their life cycles. This means from their design phase, from their initial design phases, all the way up to the runtime and real-time and real-world applications. It plans to do that by deploying trust-aware defense mechanisms, which are based on today's emerging technologies, including formal verification, theorem proofs, blockchain, trusted computing, open standard instruction set architectures, as well as artificial intelligence. In order to get a little more technical here, Rewire will be a 4-layered security sandbox that offers a harmonized toolchain to efficiently protect IoT developments, always under the never trust and always verifying umbrella. These 4 layers include the formal verification of cryptographic protocols, firmware and software security updates and patching validations, runtime attestation for verification of IoT devices, operational assurance, as well as the blockchain-assisted AI misbehavior detection in a distributed fashion. Here we can see the architecture of these 4 layers, where with the different components of the layers and their interconnections and how they work with each other in synergy. Moving on to the objectives of Rewire. Rewire is indeed a very ambitious project, and first and foremost, the most critical objective is the continuous security assessment and management of IoT devices throughout their entire life cycle, as we've already said, always under the zero trust conception. It also aims to ensure security by design through verified open source softwares and open standard hardware designs in order to minimize the attack surface of IoT applications and devices. It aims to ensure runtime monitoring of IoT trustworthiness through cryptographically verifiable security proofs and efficient attestations. And I would really like to stand on the objective regarding the simulating, validating, and evaluating Rewire framework in the field of smart cities and smart satellites, as well as smart automotives, because these are the use cases that the Rewire will be demonstrated, and its efficiency and holistic nature truly shine. Finally, we must not forget the communication, exploitation, and standardization strategies in order to adopt Rewire's outcomes after the project is finished. Here, we can, I really think we need to examine the use cases of Rewire. First and foremost, it will empower public safety in smart cities by ensuring secure device onboarding, a collaborative misbehavior and threat detection mechanism, as well as software and firmware updates of critical IoT applications. It also aims to ensure automotive safety by the correct authentication and authorization of prior to any software updates to assess the trust level of possibly unreliable sources for these updates. And finally, the smart satellites use case, where Rewire deploys and isolates applications, services, software, and security patches on spacecraft in a secure way. Finally, we need to let's assess the impact Rewire we expect Rewire to have in the future. First and foremost, we truly believe it will strengthen the European Union's cybersecurity capacities and European Union sovereignty in digital technologies. It will lead us to more resilient digital infrastructures, systems, and processes. It will ensure increased software, hardware, and supply chain security, as well as new secured disruptive technologies. It will also help us develop smart and quantifiable security assurance and certification shared across the European Union. And finally, it will help us build reinforced awareness and a common cybersecurity management and culture. This was all from me and the Rewire project. Thank you for your attention. Please stay in touch with Rewire through their website and their social media on LinkedIn, Twitter, etc. Please feel free to ask any questions.
Thank you again for this excellent presentation, directly to the point.
Thank you very much, Mr.
Not so many stories, exact identification, and to the target.
Yeah, Rewire.
I'm really happy having presenters like you.
Thank you very much. Rewire is a complicated project, so we tried to stay short and make sure everything is passed to the audience. Thank you.
We will now pass to the next session, please. The introductory slide. Yeah. By the way, here I would like to invite my colleague, Mrs. Christina Lessi, who will act as a moderator and will coordinate this session, which is practically based among the greatest part on the ICT 41 call of the European Commission, which was about the development of network applications for the support of third-party services in vertical sectors. Here we have three ICT 41 projects, the 5G Media Hub project. Then we have two presentations coming from the 5G Era project. And we almost conclude with the Vital 5G project. However, we extend Vital 5G's expectations and concept by a relevant ongoing activity, which is based on the TRACE European project. So we will see various applications in various verticals. However, the common, at least between the four among the five presentations, is the orientation towards the structuring of network applications. So I would like to invite Christina. Thank you, Christina, for supporting me in this event. And practically, you can coordinate.
Thank you very much, Dr. Hochliuros. Welcome to session 9, 5G innovative actions for vertical sectors with third-party services. We can now start this session. So let me welcome the first presenter, Mr. Michalis Fakianos, who is Director of Technical Department in APART. Hello. The floor is yours.
Thank you. Okay. Hello, everyone. This is Michalis Fakianos. I am the Director of the Technical Department of APART, an SME based in Athens, Greece. Let's start with a few words about our company. So, APART was founded in 2012. It's an SME based in Agia Paraskevi in Athens, Greece, and we're actually software developers. We are building turnkey software solutions for core organizations. OTA is one of them, Vodafone Group is another, the IDE, etc. And we're also very interested in the R&D sector. So we have 6 ongoing R&D projects, and we're also a member of the 6G Interested Association as an SME. And a few words about the project. So 5G Media Hub is an ICT 41 project. Consists of 17 partners in the consortium from 9 different countries. And is an ICT 41 project that is focusing on verticals, media verticals, and net apps development. So the aim and motivation behind this project, this is to serve the media industry and try to make tools that allow the media vertical application developers to test what they're building through a 5G network. So we are making use of 2 already existing private property 5G networks. These are outcomes of previous research projects, and these are federated. So what the project does is to try to bring these test beds, make them more easily accessible to SMEs or developers, independent developers who want to test how their applications work on 5G. Also, within the project, we are building some net apps. We will get back to this in a bit. And as you understand, we are trying to bring together the media world and the telecom world. These are two different worlds that speak different languages. So this is one of the challenges of the project. So some things about the NetApps, the network applications. This is a term that has been popular among the community in the past years. These are not over-the-top applications. These are middleware applications that stand between over-the-top applications and the infrastructure. Okay, so a real-life example of a NetApp would be a streaming server NetApp that exposes northbound APIs towards the over-the-top application, which could be YouTube, and southbound APIs towards the infrastructure in order to abstract some functionalities of the infrastructure. Actually, a stream selector API is one of the NetApps that has been built in the project, along with other NetApps such as VR streaming, multi-CDN NetApps. We'll see them in a bit. One also important outcome of the project is the implementation of the cross-domain orchestration, cross-domain service orchestrator of the project, the CDSO as we call it. So this is a centralized module that is responsible for handling all of the NetApps lifecycle. The NetApps are stored in the NetApp repository, which we can think as a marketplace for NetApps. And the cross-domain service orchestrator is responsible for retrieving them from the repository, retrieving the NetApps from the repository, starting them within one of the two 5G testbeds, and monitor their life cycle, perform some load balancing, destroying the containers when the experiment is over. So this is a centralized approach to how the NetApps are being deployed and how they run. Also, part of the project's outcomes are the experimentation tools. So this is a set of web applications, and actually they're all bundled together within a single portal. If we must remember that this project is aimed for third-party SMEs, and they will want to use the experimentation tools in order to facilitate how they experiment with the project. So within the web portal, they can start an experiment, they can reserve the engine, they can validate and verify their NetApps or handle the NetApps repository, see what is inside there. So everything is built within this web application that we call the experimentation tools. And a few words about the business model of the project. So this project caters to third-party developers who want to test how their applications are performing over a 5G network and optimize how these are performing over a 5G network. Some of the 5G functionalities, like standalone 5Gs, are not available at the moment everywhere. Actually, it's not widely deployed at all. So with 5G Media Hub, the developers can test how their applications work in 5G and in various 5G functionalities. And this is the business model that we call it testing as a service. So the developers will pay in order to use 5G Media Hub and optimize how their applications work. Now, let's see some of the NetApps and use cases that we have run in the project. The first one is a very interesting one. It's 360 VR streaming. This is a NetApp that allows to stream only the viewing part of a 360 virtual reality application. So instead of transmitting the whole 360 sphere, which uses a lot of bandwidth, we're streaming only what the user can see. And at the same time, we track where the head of the user points at. So we change the viewport in order only to stream what we need and not the whole 360 sphere. This functionality comes out of the box from the NetApp, so the media vertical developers can use this NetApp in order to optimize how their 360 VR applications work. Also, another NetApp here is the elimination of the need of outside broadcasting vans. You may have seen these vans outside football stadiums or other venues. So instead of having the camera crew and the director and the whole production team at the venue, we can have them at the studio, and from the venue just stream all the camera angles through 5G back to the studio. And this way we can optimize and cut down the costs of the production, because the whole team does not need to be at the venue. They can be at the studio and from there manage the mainstream. Another very interesting use case that we run in 5G Media Hub is the co-creation of media. This aims to make advantage of the very low latency of 5G because it allows for musicians in two very remote places, Trondheim and Barcelona, to play together music, and it needs very, very low latency in order to synchronize with each other. So we have run this through the use of the Stream Selectronet app, and we managed to synchronize them, and also have an audience at the third site that can listen live to the audio and the video. This use case concerns interactive 8K video content. So we have two screens here. One is the main screen, that where the actual part of the story takes place, and the user has a second screen, that can be their mobile phone, where a different kind of video is being presented, and they can use their second screen in order to interact with the main video. So according to what they do on their phone, the content of the main window changes dynamically. And our final use case is a multi-CDN network application. It aims for the distribution part of media companies. This is a centralized console that is responsible for selecting the correct CDN network and optimize how the content is delivered across different sites. Okay, so that's it for 5G Media Hub. Thank you for giving us the opportunity to present our work. I hope you find it interesting. Thank you very much.
Thank you very much, Mr. Sfakianos. Really interesting presentation. Hello again. I'm Christina Lessi. I'm network engineer in OTE. I'll be the next presenter. The presentation is about robotic systems in 5G environment. Especially, I will focus in 5G era research project solutions. Robotic systems are introduced to serve different sectors, such as healthcare, civil protection, and so on, by using innovative services for benefit people. 5G ERA is a European-funded research project which focuses on the deployment of such services, especially in 4 different sectors: healthcare, public protection and disaster relief, transport, and Industry 4. 13 partners from 7 European countries participate in this project. "5G technology was introduced targeting to increase the abilities of the network, offering opportunities for new applications to be adopted. It is based on a new architecture approach, different from the one that was previously used. The 5G standalone architecture, which is used in 5G era, has introduced to offer new capabilities, and at the same time, the ability to combine network with cloud computing nodes offers a high degree of autonomy, allowing external processing and a high degree of autonomy, and robots in this way will be able to get information from the environment, making decisions locally. So 5G era solutions target in 4 use cases, as I said before. The healthcare sector, where robots are manufactured to transport medicine and consumables to patients, and also take biometric measurements like patient's temperature, which is very useful in situations where patients are under restraint, like in COVID-19 pandemic. So in this way, doctors and nurses only came into contact with patients when necessary. In civil protection sector, robots are equipped with sensors, cameras, and metal detectors, so they can avoid obstacles, create maps in case of emergency. For example, when there is a need for evacuation, robots will be able to autonomously navigate in the space and lead people to the nearest exit. In the transport sector, robots can deliver products to end customers in cities and technological parks using the shortest path and in shortest time, calculating and using the optimal route. And finally, in the Industry 4 sector, robotic arms were constructed to ensure that the industrial production won't stop by any machine failure by performing automated inspections with images and lasers. Here you can see the 4 robots that are manufactured and used in 5G era in all 4 use cases. All the solutions that were presented are implemented by combining the capabilities of autonomous robots and cloud. The 5G era has implemented for that purpose and has implemented the model that you can see in the figure, which is separated in several layers. The interface layer, which is responsible for accepting commands and presenting the information. The application layer, which manages the activities and is responsible for performing tasks. The domain layer, which generates intent-based network policy. The infrastructure enablement layer, which is responsible to manage virtualized hardware resources. It also ensures the compatibility, scalability, and transparency of the testbeds. The infrastructure resource layer, which provides connectivity, computing resources, and storage. And finally, the smart event bus, which contacts events across the layers. In this environment, 5G and beyond 5G networks are not introduced to redesign the production line, but to enable operating models with networking characteristics that enable added value services. The 5G standalone architecture is able to offer higher reliability and availability than 4G networks, as well as higher throughput and lower latency. Additionally, slicing is a feature that will be very useful in these cases, since it offers better resource management, ensuring that the required resources are available for the robots, making their services more reliable. So 5G era takes advantage of slicing and treating two robots in a quite different way than we usually do. Generally, in networks, a user equipment is used to receive and send data. In 5G era, robots, which are the user equipment, are also used, apart from sharing data, to interact with a network. Robots are able to request for information about the available resources and also ask for a specific amount of resources. In order to do that, we have introduced the architecture you can see in this figure, where apart from the already known components of a 5G infrastructure like 5G core and a new radio for RAN, we have also integrated two extra components, middleware and slice manager. In the diagram below, you can see exactly the mechanism that is used for slicing. We have created default user profiles in the packet core, and we have mapped each user profile with one specific slice. So by default, initially, the robot is registered to the default slice. Then the middleware, which is an external component, requests for information about the available slices. So it sends this request to Slice Manager, and the request is forwarded to Packet Core. And then the Packet Core responds with the list of the user profiles. The middleware then makes a choice about what resources a robot needs based on the use case that will be used, and sends this request to Packet Core through Slice Manager. Then the Packet Core deletes the robot from the default slice and re-registers it to the new one. In this point, I would like to mention that the slice manager is a very important component since it is considered as a network component, while middleware is an external component. And the slice manager is useful as a security level because we could not connect directly an external component to packet core. So slice manager is a component between to offer extra security. So in this approach, we are able to scale up robots beyond what was visible in the past, allowing us to include them in applications that are useful for people. The network capabilities offer additional advantages, such as the higher speed and the lower latency in data transmission, while additional network capabilities, such as slicing, allow robots to interact with the network, becoming part of the whole infrastructure. Thank you very much. Thank you. And now, let's welcome the next presenter, Mr. Guillaume Gary. Mr. Gary is a research and development engineer in Robotnik. Guillaume, can you hear us?
Can you hear me?
Yes, yes, we can.
Can you see my screen?
Not yet.
Okay, I'm sharing it.
I can see your screen, Glenn. It's already shown in the Zoom, but I don't know about the conference.
Maybe.
Yes, Guillaume. Please go
I
on.
think that the Zoom I can show it in the Zoom, but I don't know. I don't see it on your live stream.
Yes, we can see your screen. Please go on.
Okay.
Thank
Perfect.
you.
Okay, so I try to be brief. So, hello everyone. My name is Guillaume Gary from Robotnik Automation. I am part of the research and development team in charge of 5G rapport. So, what we wanted to achieve in the public disaster relief or surveillance case, that what we wanted to show what we wanted to prove in the robotic using 5G era and 5G capabilities. First of all, what we wanted to increase is the computational capabilities of the robot beyond the onboarding capabilities. So we want to make it, because the robotic tasks are quite complex and CPU intensive, we want to able to use edge or cloud devices in an easy way for the robot developers. Related to this, we cannot put, even if we could, we cannot put very high capabilities computers inside the robot because it will drain the battery very, very fast. And if we all do the task that we do on the robot, we do it on offloading these loads, we will increase the battery range of the robot, so it will be beneficial for the robot community, for the mobile robotics. Also, we want to provide some of the capabilities that the robot is currently unavailable, like AI capabilities like object recognition, voice recognition, or all this kind of stuff that cannot do it on boarding that we wanted to do in the do it by offloading. And last but not least, we wanted to increase the network communications robustness using the cloud and edge capabilities in order to have an uninterrupted robot connectivity. So in the surveillance use case of public disaster relief, we are going to present that the robot is going to make a recognition and mapping of unstructured environment in a disaster area, and in particular cases also, as Christina pointed, recognize people and also lead the way to center safe points. As you can see in the left-hand side, The robot is equipped with different kinds of sensors like 3D LiDAR, cameras, etc. And it's also mounted with a 5G router. This will connect to the 5G era middleware, will be placed either the edge of the cloud, and we will ask some network applications, functions for the robots, to be clear, to run it in servers, either cloud or edge. So I think it's better to show it in the video. So we're going to play it and talk over. So this is the robot that we are going to use. The robot will, this use case has two phases. This is the init phase of phase 1. We are going to command the robot to go to unexplored area, and the robot is going to ask to 5G middleware to deploy some network applications remotely. First is the frontier explorations, that the robot will give goals to sweep some designated area in order to make a map. For making the map, we are going to ask the middleware to deploy a SLAM network application that will allow us to create a map that the robot understands, and this is done remotely with using the 3D environment. And after that, after that, we're going to ask a network application for detecting humans in order to track the position of the robots, of the humans, and after, in a second phase, go there. So the last part of this init phase is to return to the base, save the map, and ask the middleware to stop all network applications. So once the phase 1 is finished, the phase 2 will be started to going to this area that we are recognized, and we have the map in the phase 1. So the idea is to the robot will ask to deploy another set of network applications to the middleware, and the first one they're going to ask is the SLAM. This is going to locate the robot inside the map done in the previous phase, so the robot know where it is. So the human presence now is going to send the location of the last known location of the human, and is going to, and the frontier exploration now is going to give us a path to go to there, to the last known location of the person, and we're going to, using the 5G capabilities of the network, we're going to allow a remote teleoperator to give control of the robot, so we can lead the way of the trapped people to a safe place. So this will finish the phase 2, and this is how we are going to do in the public disaster relief or surveillance use case. The another important thing we are going to do in this way is they are going to deploy a signal quality applications that will allow us to create a map with the 5G signal quality and use it in robot navigation. This is especially important for us because in this project it's about outsourcing. For outsourcing, we need to have good quality signal of 5G because we are using high throughput and we require sometimes low latency. So we are going to we are going to build some map to telling the robot where the robot will have high good signal and avoid the places that are not with the good signal. As you can see in this video, this was done in the OT Academy facilities, and this is for the equipment that we use, the run node. This is the antenna, and this is the equipment we used in the laboratory. So the robot is going to start to sweep or move around the area, some rooms, and it's going to start to paint the floor in different colors. One, when it's green, is that it means that the signal is good and the robot can move there freely. When there is yellow, the signal is okay, it still can move around there, but when the signal goes to red, it means that the 5G quality is not enough to perform the assigned task. So this application will make a map for the robot to understand in order to make the robot to avoid these areas and have always connectivity to the edge on the cloud. As you can see, this is a live map, and this is the kind of output that provides for the robot to understand. And well, thank you very much for having this, and my presentation is just finished. Thank you very much.
Thank you very much, Guillem. It was interesting to see how robotic systems could be used in critical sectors like public protection and disaster relief. Thank you very much. We could now move on to the next presentation. The next presenter is Mr. George Churis, network engineer in OTE. George, the floor is yours.
Hello, thanks, Christina. I'm going to present the vital 5G third-party experimentation opportunities. Okay, sorry for the technical problems here. I'm going to talk about the experimentation opportunities for Vital 5G project. I'm going to start with a short introduction of the project, and I'm going to present you the 3 use cases that we have, and especially I'm going to emphasize the experimentation opportunities for the Athens testbed. We have the vision of the Vital project is to enable the creation of 5G enhanced services for the transport and logistics section. Our aim is to bridge the divide between the telecom sector, the application developers, and the transport and logistics sector. So in order to do this, we have 3 5G testbeds. We have the transport and logistic infrastructure of each one of the 3 use cases. We have network application development for these 3 separate use cases. We have created an experimentation platform, And we welcome any SME that wants to do third-party experimentation to come and use our platform and our hardware and software that exists in our 3 use cases. This is a high-level project overview. On top, it's our platform, which is common in all 3 use cases. And in the bottom part are our 3 use cases. One of them is Antwerp, one of them is in the Danube, and the last of them is in Athens. Our platform, which is used to bridge the divide of the telecom operators, the application developers, and the transport and logistics sector, is actually has released is in the final stages of development. So it's a very mature platform, and it's ready for you to test. Okay, I'm going to just pass through. We're using the network application concept as well as other projects. Actually, we're extending the NFV descriptors with our own, and we provide as well service chains formed by virtual and physical functions. Actually, you can see a service chain in the bottom part here, which, in this example at least, for network applications form a service. These are the 3 use cases that we have. One of them is in Antwerp, Seaport. This is for automated and remote vessel assisted navigation in a very busy port environment. The other of them is in Galati, which is again in a port, but in this case it's a river port, so different challenges exist. And the last of them is in Athens, in an Athens logistics hub, in Diakinesis, actually. This is the company that owns the logistic hub. This is the location of the third-party experimentation in Athens. The last use case that I mentioned. Actually, we have 2 sites. The first of them is obviously the Diakinesis warehouse in Asproprigos, where the actual location of the use case is running. We have equipped this warehouse with a 5G standalone and with 5G slicing, and OTE Academy building in Marousi. We have a similar 5G setup with the same capabilities for rehearsing and testing. This is the location of the backend equipment as well. And the third-party experimenters can use this location to do any rehearsing and testing before coming back to the Diakinesis. So if someone wants to be a third-party experimenter, I welcome you to be a third-party experimenters for the Athens use case. You can use our building in OTE in Marousi to do any rehearsing, to do any testing that you like. You can visit as many times as you want before coming back to the Diakinesis and do your final testing. There are a lot of assets on offer for the Athens use case and for the third-party experimenters that would like to use this use case. They can do optimizations of warehouse operations via intelligent algorithms. They have controlled access to HGVs. So if you want to be a third-party experimenter, you can have access to our HGVs. You can also have access to warehouse optimization mechanisms, both real and simulated, okay? And you can evaluate 5G, the standalone 5G version, and any network slice that you want. So if you become a third-party experimenter, you can evaluate your applications at a real 5G network, standalone, either in Marousi or in Athens, okay, or in the Akinesis, and get your KPIs, measure your application performance, do whatever you want actually with this 5G standalone testbed. We have also, in this pilot use case, available a digital twin, okay, that you can also use, okay. You can use also our network applications, providing your data probably for your experimentation. Obviously, you can use the data from the mountain sensors in the warehouse. Obviously, you can create your own slices. You can ask for your own slices with your own quality of service restrictions. And you can get all network KPIs or other KPIs at the end of your experiment. Here are some benefits for you if you want to become a third-party experimenter. You can use a 5G standalone network, obviously, as we have talked. You can have assistance from our experts for using our platform. You can use our network applications in chains with yours, if you want. You can provision new network slices and measure the performance in a real 5G standalone network environment. Experiment with our AGVs, and we do not restrict you. If you can think of anything else, you can do this, okay? You can contact us, our booths. We have 3 booths at OTE, from OTE and Cosmote, and 1 booth at Wings now. These are some contact points that probably you can, at least the 2 of us are in this room, Makis Stamatelatos and myself. Nelly Yanopoulou and Christina Carusato probably are outside, if you want to be a third-party experimenter. Also, you can visit us at the Vital 5G EU website. Thank you.
Thank you very much, George. Vital 5G platform has interesting and useful capabilities. Thank you for presenting us these capabilities. Let's now move on to the last presenter for this session, Mrs. Ioanna Mesogiti. Mrs. Mesogiti is Senior Researcher in Cosmote. Welcome, Ioanna.
Okay. Hi. Hello, everyone. In this presentation, we will discuss mainly about the vertical sector of logistics and how ICT technologies can help into the transformation of this sector. More specifically, we will have a look in brief at the logistics services vision, the enablers, the ICT enablers for this division, and also we will base our discussion based on the TRACE project, their technical concepts and its demonstrators. A few words about the project. This TRACE is a European-funded project which focuses on the transportation and logistics sectors and in the incorporation of transport engineering and intelligent transport systems towards the sustainable logistics services. It is funded by the EU and it runs all over 360 months with the collaboration of 28 partners from 15 countries, 10 research institutes and 18 companies. It's led by the National Kapodistrian University of Athens, and the technical coordinator is the University of Thessaly. So, however, first let's have a look at the vision of the logistics services and what is the focus towards their transformation. So, currently, logistics is one of the most energy-consuming industries. The vision is to transform this into a sustainable industry, achieving significant reduction of its carbon footprint. Right now, it consists of a scattered, distributed environment of multiple systems and multiple vendors. And the vision is to transform this into a unified synchromodal platform for synchromodal deliveries over one single, potentially, system, vendor, and operator platform. Right now, this domain includes a lot of manual operations, and the vision is to transform this into an automated operations sector for goods, services, and eventually automated deliveries. So, just to say that the vision of the logistics sector is reflected right now to the vision of the ICT domain, and it is directly and explicitly addressed even by 3GPP, which is a mobile telecom standardizations body. So, in brief, there are many ICT innovations that can enable this transformation of a logistics center from the current status to its advanced future. So, from the application viewpoint, automation, artificial intelligence, and blockchain technology techniques can contribute significantly into the transformation of the domain, along with virtualization and containerization, and this from the IT point of view. To this, advanced robotics and smart sensors, along with IoT servicing, can significantly contribute to the transformation of the domain, and we shall not neglect the network communications counterpart, which is the ITS and V2X network services, which will run on top of the latest generation 5G networks or in collaborative 5G and non-terrestrial networks. So, just to have a view and how this vision of logistics is reflected into standardization bodies. Right now, 3GPP standardization body has a dedicated series, 3GPP series, to vertical industries, and some of them address directly and explicitly the logistics and transportation services in terms of identifying the KPIs and the specifications of the services. These services that are tightly connected to logistics is vehicles platooning, advanced driving, extended sensors for awareness of local situation of the vehicle, remote driving, and vehicle quality of service support. Also, 5GAA, the 5G Automotive Association, works toward delivering these specifications and identifying the requirements from the telecom networks in order to achieve and deliver logistics services. Okay, the way, the positioning of trace in this environment is the following. The goal of this project is to reduce the current transfers in order to reduce eventually the carbon footprint while providing resilience in case of this disruptive event. Among its objectives is to optimize synchromodal operations and to integrate heterogeneous logistics services and technologies. The proposed solutions is to provide a universal platform which can tightly and automatically be used for the planning, scheduling, optimization, and events management, and to support smart context establishment and financial operators or operations at real time. The focus cases is the cases of logistics in the case of multiple vendors and multiple operators, in the case of use of shared resources, and to showcase its capability of mitigating the delays in case of disruptive events. And finally, and ultimately, to be used for the automation of logistics and the use of unmanned vehicles for the last mile deliveries. The project concept revolves around a layered architecture approach, which at upper layer consists of the vertical industry services and requirements, that is the logistic companies and their services. At middle layer, there is the edge infrastructure, which is actually the distributed infrastructure spanning from across all logistics locations, services, systems, and vendors. And the physical architecture and the resources. We shall say something that this layered service architecture is a total reflection of the network's architecture as it is right now in the 5G era, spanning from the infrastructure, the virtualized resource management, and the services. However, it doesn't include only the network part, but includes also the transportation resources elements. Over this architecture, Trace project aims to bring in innovations at upper layers, at the vertical service layer, related to streams and storage management, integration and harmonization of systems, workflow schedulers, and also the management of smart contracts and finance interactions, blockchain aspects, artificial intelligence and optimization modules. At the edge infrastructure layer, it aims to bring in AI intelligence in the orchestration of the resources, as well as blockchain-based authentication and encryption, for processing and sharing of communication resources and compute resources at the same time. At the physical infrastructure, these innovations are also reflected into providing functionalities and innovations related to in-vehicles artificial intelligence functionalities, blockchain-based authentication and encryption, data collection and communication. These innovations will be showcased in the 3 main demonstrators, one in Greece, across the Thessaloniki and Athens corridors, and at the National Kapodistrian University of Athens campus, one in Italy and one in Slovenia. Concerning the Greek demonstration, this will revolve around 3 pillars. The first being the delivery of synchro-modal and intermodal logistics operations across the Athens-Thessaloniki corridors, which is eventually an AI-based optimization of operations between different stakeholders of different modes of logistics, namely the Hellenic train and the ACS courier operations, towards maximize eventually all the performance, the KPIs of the logistics operations. The second pillar is showcasing the efficiency of the platform in the case of disruptive events through the automatic rescheduling of the logistics operations. And last but not least, the third pylon is to showcase the capability of fully automated deliveries through automated scheduling, automated planning, and eventually automated last-mile logistics at specific last-mile locations. Concerning the Italian demonstration, this will take place in Modena Automotive Smart Area and the Greek Diagonal, which is actually a cycling path dedicated to logistics, running from the city center towards an external logistics hub. And the focus of this demonstrator would be to showcase autonomous cargo bikes, either in the form of platooning, where one cargo bike will follow a lead cargo driven by a human operator, or a follow-me case, where one cargo bike will follow a walking operator in the case of a final delivery route. Finally, the Slovenian demonstration will focus on establishing an urban consolidation center, that is, a center consolidate multiple vendors and multiple operator logistics at AV Living Lab in Slovenia, where it will be showcased the capability of the platform to support more logistic companies and to develop and to support business models that revolve around resource and revenue sharing. This will be based on blockchain technologies. As said, this project is quite new. It has started in June, so there is a lot of work ahead, and also there is a lot of information that will come up with the progress of the project, and so you can follow this project and see how it evolves and how this can be realized. Thank you very much.
Thank you, Ioanna. It was an interesting presentation of the concepts for logistics operations. Now we could have a short break.
5 minutes only.
5 minutes, a short break for 5 minutes, and then we will continue with session 10. Thank you.
Frequencies. We need large spectra, I mean large bandwidth in the spectrum domain, in the spectral domain. We need many units, we have MIMO technologies, and all these things require for at least 400 gigabit per second per RRU in order to transfer the massive amount of data generated by the users. On the other hand, if we want to support more than one RUs, 2 or 4 of them, we would need even higher bit rates in the order of 800G and 1.6 terabit per second. The same thing happens in the edge data center interconnects, where we have traffic really to skyrocketing in the edge, and we have many applications that really need to be very, to have very strong amount of data handled in the edge part of the network. And that means that we aggregate data traffic which travels from the access and tries to reach the edge and, of course, the cloud. And all this traffic must be served by very high-speed interconnects. Finally, the most demanding operation, which is not so much, not 100% relevant to 5G, but it is, I would say, the other side of the same coin, is the data centers and their requirements. We have some switches there in order to connect the different servers. These switches really need more than 825.6 terabit. This is an error there, terabit per second in capacity for each switch. So that means that we need to really increase the rate per lane in order to reach this amount of 800G or more, or beyond that. So there are many products now in the market coming from these vendors who are mostly involved and in the optical communications. And we see that they are producing very fast new products which try to cover this need, the need for 800G or beyond. And of course, we have also the technology in the optical domain to also follow this and can really support even higher bit rates, because we have new lasers that can really respond above 100 gigahertz, and we have linear amplifiers and photodetectors also at the same huge amount of bandwidth. So the solutions, since we are more or less all of us are somehow follow the well-known notion which says that we transmit optically, we transmit photons, but we process with electrons. So we need electronic processing in order to handle this huge amount of data. And here we have many different new algorithms that are used in order to compensate for the transmission impairments in the optical domain. We have transmission impairments even in the fiber. We have dispersion, nonlinearities, etc. And the problem is that we have the DSP there, which accounts for almost 60% of the consumption of the pluggables, which are pluggables in the order of 800G and beyond. And this is another headache, because this really increases the power consumption, and power consumption is not allowed to increase a lot in this kind of applications. We have some analog solutions here which come and they want to provide an alternative solution, coherent or non-coherent solutions. I don't want to go in details, in many technical details. The main idea here is to use analog electronics, and analog electronics really consume less than digital electronics, but they are less versatile. They cannot provide the same functionalities. And another thing, another approach that really comes here, and it is quite promising, is to use photonic devices to process information. And this means that you have to offload a little bit the heavy DSP we have here. We have to make it lighter, and we have to transform a part of this processing in the optical domain. So what we propose in this project is to use photonic accelerators, which can really do some stuff in the photonic domain where the power consumption is very small, and try then to use the lightest possible DSP at the end. So the project is this one, it's Prometheus Horizon Europe. We have many partners from EU, and I think it is a very nice combination of academic and industrial partners. We have two universities from Greece, our university and University of the Aegean, DTU from Denmark, Ghent University from Belgium, Fraunhofer ISDM from Germany, QTI, it's a company in quantum communications from Italy. We have IBM from Zurich, iPronics from Spain, Innovation from Switzerland, and CLT from France. The idea is to build this kind of devices where we have here a photonic processor, we have here lasers, and we have the digital part here, electronics, and we are trying to do some stuff of processing here in the photonic core. And this processing can be very useful not only for edge computing applications, but also for quantum applications. This is another, let's say, significant component of this project. So here, what we use as a very simple processor, which is really very efficient in specific problems, is to use some filters, optical filters, this here, and they are placed in a loop, and this loop really provides a kind of a recurrent processing similar to what is offered by recurrent neural networks in the algorithmic domain. So what we use is many of these filters. We try to process different parts of the spectrum of the signal. We may have signals with a very large spectrum coming, for example, from 5G or from other applications. Each part of this spectrum is processed, let's say, separately from each of these filters, which are all fabricated in a silicon photonics platform. And then we use photodetectors and some very light processing in the digital domain, like a simple linear equalizer. And we have shown that we can really provide very nice results at very high baud rates in terms of compensating dispersion and other effects. So this is how the filter operates, just a technical demonstration. And here we show the same architecture for a coherent receiver. Coherent provides more information. You can really use complex modulation formats as the one used in the wireless domain. So here are some results which show that the bit error rate after the detection of a signal, it's much worse using simple DSP techniques. Even if we use very strong DSP techniques like an MLSE algorithm or something even more strong like a Volterra nonlinear equalizer, our system here provides better results. It can provide higher tolerance to dispersion, and it can really provide very nice results even with low bandwidth components due to this spectral slicing technique we use. So that means that we can support even a terabit per second transmission with components which can let's say, cover only 60 gigahertz of bandwidth. These results have been showcased experimentally in our lab, and here we have a collaboration with this company, Ipronics from Spain. We use their platform. This is a silicon photonics platform where you can design any filter you want. This is like an analog of the electronic FPGA. This is a photonic FPGA where you can provide any kind of processing in the chip. And we see that we can achieve very nice results at 100 gigabit per second. We cannot go higher because we don't have the equipment to see higher capacities, but we are in the process of doing some collaborations with some companies which have very strong equipment, showcase the technology even in 200 or in 400 gigabit per second. Some results here showing the benefits in terms of the power consumption and the capability of supporting extended reach. This is quite important for 5G because in 5G we need to have let's say a distance of 10 or 20 kilometers between the central office and the RUs. So we can provide this kind of very high bit rates even in this extended reach. And this makes our transceivers compatible with the 1.6 terabit per second, which is quite a need if we want to support 6G in the form of, let's say, analog processing and radio over fiber. So just to acknowledge my co-workers from our group, this is done in our group, which is called RNCP. This is the research unit in neuromorphic computing and photonics. And we are two labs there, and now we are working with 2 European projects and 1 nationally funded project. Now there is another project that was just approved and is going to start in a month from now. So this is our activities, and thank you very much for the invitation and for being here.
Thank you so much, Antonis, for the presentation, for the aspects, the opportunities. What can I say? There are no words.
Thank you.
Thank you so much. Now we will pass to the second presentation of this session. I will invite my colleague, Dr. Konstantinos Filis, from our R&D department. Konstantinos also is always present in all of our activities, and for him, many, many thanks for joining.
Thank you, Gianni. It's nice to be here. Very well-organized event, as always. So we will take a look now at next-generation ultra-low energy and highly secure optical networks, which is something that the Allegro project envisions. The Allegro project has a duration of 42 months. It started in January this year, and it's going to be finished by June 2026. The total budget is 11.8 million euros, funded by the European Union, and the coordinator is Fraunhofer. The consortium is a rather large one, 23 partners from almost all over Europe. And the concept is the design, prototyping, and demonstration of end-to-end next-generation optical networks. And now these networks need to satisfy 4 pillars. These are ultra-high capacity from access to the core, considerable reduction of power consumption, which means low cost and OPEX, autonomous network control management, and secure and reliable optical transmission. Allegro has 7 objectives in total. The first one has to do with the architecture of Allegro, which has to do with the design of an artificial intelligent machine language empowered, ultra-high capacity and energy efficient architecture, and also ultra-high secure. So this is the high-level architecture we can see here. Now, the KPIs associated with the first objective is more than 25% of energy savings from energy efficiency, less than 100 millisecond deployment time, more than 2 times reduction of OEO, that means optical, electrical, optical components, a reduction of more than 25% of the operational costs, and provision of end-to-end security able to support more than 90% of services. The second objective of Allegro has to do with the design, fabricate, and packaging of smart transceivers. These transceivers will contain 64 input-output ports able to connect up to 64 transmitter and receiver subsystems. We can see here in the figures, this is the concept of the transmitter, this is the concept of the receiver, and here we have the packaging of the device envisioned by the Allegro project. There are very strict KPIs associated with the second objective. Both transmitters and receivers will use dual polarization plasmonic IQ modulators with 125 gigabaud, 16 quadrature amplitude modulation per polarization. We will have photonic channel processing and power division precision of less than 0.05 dB, with phase shift precision of less than 0.1 rad. The third objective, this objective has to do with the realization of fast and lossless hybrid photonic switches with on-chip amplification for the O, C, and L bands. We can see in the figures, this is a photograph of the hybrid integrated switch, 1x8, and this is the hybrid integration using the flip chip bonding. KPIs associated with this objective are also very strict. We have programmable multiband optical switches that operate in the O, C, and L bands with multifunctional capability, low power consumption of less than 8 watts for the 16x16 O band and less than 0.5 watts for the 32x32 C and L bands, switching time of less than 20 nanoseconds for the O band and sub-millisecond for the C and L bands, and lossless operation. Objective number 4. This has to do with the design and development of an advanced secure data plane network for the quantum era. In order to do that, Allegro are going to use QKD protocols for increased security, physical security present in every node, flexible hybrid solutions that can dynamically build in new QKD links, and automatically adapt the key relaying when mobile users move. Objective 4 KPIs are also very strict. First of all, we have to demonstrate the hybrid end-to-end solution. Then we have a reduction of more than 50% in quantum bit error rate and increase of more than twice in secret key exchange rate with accuracy of more than 90% of eavesdropping detection. Objective number 5, design and development of secure and reliable control, monitoring, and orchestration system. Again, the target here is low energy and low latency. And also with the help of AI and ML. Now, this is the first attempt to visualize the architecture associated with the particular system. And you can see it in the graph here. Now, again, KPIs associated with this objective. Sub-second level provisioning for end-to-end networks, considering latency of only 100 milliseconds, decision-making in less than 10 milliseconds, very low power consumption, low latency and jitter, autonomous operation to reduce OPEX by more than 25%, high locomotion resolution of less than 1 meter, and wide sensing range of more than 10 kilometers. Objective 6 has to do with the demonstrators of the project. There are going to be 2 large demonstrators, one in Torino with the help of TEAM, and one in Bristol, in the University of Bristol. During these demonstrators, Allegro plans to demonstrate the integrated prototype of the proposed architecture. The goal is to have a reduction of power consumption of more than 50%, and the third KPI of this objective is to validate multi-service end-to-end. Finally, the 7th objective has to do with the reinforcement of EU leadership and the influence to industry to adapt the Allegro proposed architecture. Now, Cosmote's role in this project: we are leaders in the task on defining the architecture that the project proposes, and we are very active in the use cases definition. Cosmote will also participate in the assessment of this technology and in the dissemination and exploitation of the results. And finally, the IoT platform of Cosmote will be available especially for the demonstrator in Italy, in Torino. So that's all from me. Thank you very much for your attention.
Thank you, Kostas, for this presentation. Now we will pass to the next session, session number 11. As you can find out, this is dedicated to the design of a meta-operating system, or more than one such system, for the artificial intelligence of things edge cloud continuum. Actually, in this framework, we have two parallel projects, the AEROS project and the NEMO project, and also we have included as a complementary the Talon project. So we will start, and I would like to invite Mr. Spiros Georgoulas from Demokritos, if he is ready. And thank you for joining. I also I would like to thank Haris Koumaras for the cooperation, and so the stage is yours.
Hello. Thank you very much for having me today. My name is Spiros Georgoulas. I'm a research associate at NCSR Demokritos. And today I'm going to present to you a use case called Energy Efficient, Health and Safe, Sustainable Smart Buildings that aims to demonstrate the capabilities of the AEROS project. AEROS project is a meta-operating system for the IoT Edge Cloud Continuum. So, how it all started? The idea came during the coronavirus period because at the office buildings, essentially, it was a lot of restrictions that we had to adapt ourselves into, and we were no longer able to put all the people together in one room in order to have low energy consumption, because then we would have health issue problems. This is a collaborative work between Cosmote, the Polytechnic University of Valencia, NCSR Demokritos, and two very active SMEs in Folicis and Focus. Actually, Cosmote has an end-to-end application and is going to serve as both end user, but also as a technology provider. So you see that combining all these different metrics, the energy consumption, the health efficiency, the preferences of the employees, company policies, it's a very dynamic and complex problem. So we found the opportunity to work and try to solve it. So a little bit of context. As I said, Cosmote has an end-to-end application, has deployed a vast amount of sensors that actually collect data as we speak now through sensors and IoT gateways, sent back to the back-end system and then analyzed. We have sensors like desk occupancy, luminosity, a lot of environmental sensors, carbon dioxide, monoxide, humidity, temperature, and so on. Motion detectors, and all this data, the goal is to combine these metrics, this historical data, but also the preferences of the employees and the policy of the company in order to build an intelligent system that is going to have actually three main goals. The first one will be to propose to the employee where he should sit or she in order to succeed to have the minimum energy consumption possible, but also have the constraints of a healthy office space. Some challenges during that process is that everything has to go around the energy efficiency. We have a lot of measurements from different kinds of sources, heterogeneous, that we will try to, and through the architecture of AEROS and the unique abstraction layer, to combine and in order to be homogenized throughout not only one building, but more of them. We are hoping to build a system that's generalized enough to be implemented in Cosmote buildings, that it is happening right now here in Athens, but also in more than one of its buildings. And some more extra capabilities that we would like to see at this pilot is to have a 5G standalone system to incorporate it to the communication technologies and with its capabilities. Okay, so here, at the right we have the cloud. This is the central point. As far edge, we identify the sensors and the IoT gateways that are on each different floor of the building. And as edge server, we consider each building of Cosmote, and we have a lot of applications deployed there, like Kubernetes. Everything is going to be containerized, OpenVPN access, Home Assistant for the whole management of the HVAC system of the building, and a lot more. Okay, and through a mobile app that the user, the employee, will have on his phone, is going to be able to work with all the system and actually get the notification on his phone where he should sit. This is more or less the same idea as the previous slide, but from a different perspective. Let's say that the two different blocks are, one is the edge and one is the cloud, and they are both interconnected with the Iris basic services. On the top, we can see the infrastructure components that are deployed right now. We have upwards, we have nukes and virtual machines and all the applications that we have on top of all the Iris. I will not get into much more detail about this. So we had to transform this theoretical problem into a more technical one with actual metrics to reach, and we have to do an extensive research on, okay, we want a healthy environment, but what do we consider a healthy environment inside the building? So the most basic metrics that we're trying to reach are the thermal comfort and the air quality, both accompanied by the temperature, the humidity with specific values, and also the carbon monoxide, the carbon dioxide, and the particulate matter. This can be enhanced also with metrics from sensors that we already have, like the luminosity and the sound level. So now more to the more intelligent part. I would like to say how we are going to succeed all this. So we have built, and we're still building and deploying AI algorithms, mainly time series forecasting algorithms that they are going to predict future values that are of our interest in order to be able to act before this. We have tried a number of them, the neural networks, the recurrent ones, the LSTM is performing really well. Also, the XGBoost models with the decision trees and the Facebook Prophet model are working well. And I have in my last slide here, I'm not going to explain all of this because it's too much, but I want to say that a very big part on all of this is the data homogenization, and we are following the NGS-ILD protocol. It's an information model that has context behind those data and let's say schemas and information that it's going to receive raw data, transform it to NGS-ILD format, and then through the context broker, each component of our architecture is going to receive the data, run the AI algorithms, train them, and inference, and then create some output, and then send it back to the context broker to be transformed to NGS-ILD in order to be understood easily by the whole aero system. We have three more main components. It's the AI, that's all the algorithms that we are building and make predictions. We have the recommendation system, as we call it, that is going to take input from the result of the AI algorithms in order to suggest to the employee where to sit. And we have the energy and health component that is going also to receive metrics from the intelligent part of our application, and pass it through an optimization process in order to suggest to the HVAC of their building how should set the metrics of the temperature, the air condition, etc., for specific time of the day and specific number of people in the room in order to achieve the minimum energy consumption that we are trying to reach. So yeah, this is all for me. Thank you for the attention, and happy to answer any questions.
thank you for your presentation. We will pass to the NEMO project. I will be the presenter the third time today. Okay. If we can have the presentation, please. So, NEMO is a European project. The main option or the challenge is about proposing a next-generation meta-operating system for making AI as a service an integral part of network self-organization and microservices aspects. Just an overview of the NEMO project to let us know what we are talking about. It's a 3-year duration project. We have completed 1 year, starting since last September. 26 partners from 9 European countries, 8 use cases, and 5+1 living labs and related pilots, as we will hopefully see. This is an overview of my presentation. Okay, I pass to an introduction. Some challenges. Fast expansion of the Internet of Things in parallel with 5G or beyond 5G infrastructure. This implicates for the growth and deployment of various interconnected things and the development of a great variety of vertical applications in a multiplicity of sectors. As we have the inclusion of the concept of the artificial intelligence of things, this creates a more converged option. However, it's not a simple challenge. We have several challenges, especially regarding issues about trustworthiness and security. The NEMO platform faces these challenges, acknowledges the need for on-device intelligence, and recognizes that this sort of intelligence shall be somehow an integral part of the related meta-operating system. In fact, NEMO intends to optimize task migration in a secure way and provide timely orchestration of the intended microservices. A key part is the support for the provision of an open and modular meta-operating system, ensuring easy deployment to any AIoT framework, better to say, instead of device, while maintaining stringent cybersecurity and privacy standards. So we keep in mind that cybersecurity and privacy are important aspects. So in this framework comes the project, considers the high penetration of the AIoT applications, and intends to give incentives to third parties via the proposed solutions and the dedicated use cases, especially for SMEs, to adopt the proposed technology. It is also correlated to existing ecosystems like the Gaia-X or the Eclipse IoT. For the first one, we had a dedicated presentation in the beginning of today's event. Coming now to a more conceptual approach, just to see what we are facing, what we intend to do, what we discuss. As I said, the AIoT is a challenge for social issues and also for economic growth. So it's something that will affect somehow very strongly the ICT sector and the technology and the market as a whole. Some options propose that fully distributed computing and federation solutions between heterogeneous IoT, edge and cloud nodes will introduce cybersecurity concerns, and they are right. Because, as I said before, security is a critical issue. There is no standard method until today just to describe all potential options of IDS, options for policy of or privacy enforcement, and so on. So we have a complexity to deal with, and this is the message I want to pass here. Complexity, lack of interoperability, this is a great challenge for those intending to propose solutions. We expect by NEMO to establish with the project a framework so that NEMO will be what we call the game changer of this AIoT edge and cloud continuum. This is also an important term because we have already discussed about edge and cloud continuum. Now we add the option of AIoT. All these three together converged, creating opportunities, but also challenges and occasionally difficulties. And this will be done via the introduction of an open source, modular, and cyber-secure meta-operating system, which is the core of the effort. We will consider existing technologies, and we will also use new technologies. And this is actually the challenge in order for the project outcome to have massive acceptance, the use of new technologies, liaison with open source communities, and pre-commercial exploitation components. Now about the core issue, the architecture. What we are doing in NEMO is to consider a close collaboration between various functional architectural modules. IoT fog clusters, semi-autonomous IoT nodes, far edge, near edge cloud, and so on. So a complexity, a variety maybe of various architectural modules. A collaboration model in order for the new generation IoT nodes to be equipped with intelligence so that to be able to work autonomously, to achieve reduction of latency, perform a number of operations, potentially complex operators. Federation is also an important aspect, and of course the local artificial intelligence models, various options you can see here, like federated machine learning, deep reinforcement learning, transfer learning, are key issues to include. As I mentioned before, IoT devices can get support from various parts of the nodes. During offline training, the federated machine learning models will be aggregated to an edge node. This is a consideration for our approach in the project. And complex and potential malicious functions will be executed at the edge node. Why? Not to make our life difficult, but to make our life easier. That is, to be ready in order to face potential threats. And this is the idea. I don't want to be to present this in details. Keep in mind that we have three separate layers: underlying technology, the NEMO kernel, NEMO service management, plus three vertical layers. Very quickly, for the first one. Here, the challenge is about realizing a transparent network connectivity that will consist of IoT, 5G, 6G network optimization functions, and dynamic allocation of self-aware resources. The aim is to offer ad hoc opportunistic cloud, and most importantly, zero delay failback by design. How? By introducing a meta network cluster controller. This can be found in the architecture, which is able to realize these functions, interfacing in an independent way and with different tools and protocols, and replacing one technology with the other. This is one of the innovations of the project. Now, regarding the NEMO kernel, here in brief we identify three fundamental challenges: offering the NEMO core functionality via an IA-based meta-orchestrator, offering security by design, again security in front of us, via a novel secure execution environment, able to implement various tasks with microservices and allow the use of the state-of-the-art in security, and also support of data sovereignty space design phase via the consideration of federations following examples and approaches like that of Gaia-X. The final one, above, here a critical challenge is to develop a Dev0 operational platform as a service, offering full-stack automated operations, flexibility, greater developers' productivity, and monetization and sustainability. And just for this complex system, we have 3 vertical layers. Just to mention this, one layer, which is about cybersecurity federated ML operations, one which is related to privacy, I mentioned before, data protection, ethics, security, and societal aspects, and another one one presentation if it is to discuss in detail what is doing what. Somebody might say, okay, are all these relevant to real market needs or are these theoretical exercises? The response comes directly from this slide. We have several pilots. You can see the activities and the vertical sectors. For the sake of handling the time properly, I will cover very quickly smart farming in Greece. Here we want to combine various types of microclimate, soil, leaf information stations, drones, semi-autonomous mobile robots. We have aerial precision and terrestrial precision biospraying using either drones or micro-robots in order to facilitate the correlated activities. The second pilot, it's about smart energy and smart mobility in Italy. Here we use sensors. We want to reduce impact on the grid due to voltage variations, so the project proposes AI, machine learning-based analytics to identify potential local energy grid discrepancies and monitor the power quality, and in the same way intends to improve renewable energy sources load balancing, so via electric vehicle chargers, and proposes an appropriate solution or management for such activities. Germany, the third pilot. Smart manufacturing and industry of the 4th generation. Here, we intend to improve mass production and safety in factories with less high levels of automation. First use case related to advanced driver assistance system manufacturing, and the second one in Industry 4, we have provision of high precision automated guided vehicles. And finally, in Greece, the last pilot, smart media, city, and extended reality. Here, for example, in an event like the Round of Faith Athens, we want to include a variety of devices that will be able to collect and interact between them and provide material to the involved users, so that for the audience to improve the contributions and interact for a dedicated event. And of course, what we call as extended reality time machine is a well-known application, use of extended reality, so that to provide opportunities to the involved users. To summarize very quickly, on-device intelligence, transparent IoT to edge to cloud continuum opportunities, open and modular MOS, massive IoT applications with high penetration in the market. These are challenges in the scope of the project. This is also a slide for a unique presentation. The project proposes technological innovations, strong correlation to the European competitiveness, and an expected impact covering various areas. So these are the opportunities of the project. in some areas, but I want to finalize with this one, which very smartly includes the innovations of what we call as a meta-operating system in a chain where we have the use cases, we have all the market, various actors, we have also digital interactive hubs, standardization, organizations, and so on. So this is what we imagine for the case of MIMO to be the game changer in this IoT Edge Cloud Continuum. I prefer to have this long presentation because for me it was a challenge either to remain at the technical level or just to present the use cases. I prefer to present both. I got 5 more minutes, but I feel this was good just to give you an idea because this is quite challenging progress, and thank you for your patience. That's all by myself. Okay, and now Mr. Dimitrios Kastrinakis, once again, for the last presentation. I got more time, but he will help us to normalize the case.
All right, thank you once more. This was a really, really well-structured conference, and it's impressive that even though it lasts 10 hours, we're on time after so many hours. So congratulations, Doctor. Now, for those who were in the room previously, I'm Dimitris Kastrinakis. I work for 8 Bells, and today we'll present to you Talon, Autonomous and Self-Organized Artificial Intelligence Orchestrator for a Greener Industry 5.0. And as we dive deeper into the slides, we'll get a better understanding of what Talon stands for. At this point, I would like to begin by briefly presenting the company I work for, 8 Bells. So 8 Bells is essentially an innovative technology and research firm based in Nicosia, Cyprus, and here in Athens. What we do in 8 Bells is researching the development and application of information and communication technologies in different fields, such as defense, security, space, telecommunications, e-health, or even environmental protection. In doing so, we utilize our capabilities in systems and networks engineering, in cloud computing, in cybersecurity, AI, and privacy. And I believe that what's driven 8 Bells' growth in the past few years is a very specific and rigid employee-centric management approach that invests in high value-adding stuff. Now, of course, 8 Bells is not alone in Talon. As a matter of fact, there are 16 different partners participating in the Talon project. The coordinator of the project is engineering, based in Italy. We have quite a few partners, both from the industry and academia, and I think that's what drives the project success, and that's what drives research and innovation project success as a whole in the European Union. And good examples of industries participating in Talon is Ericsson, Factor, and many research institutes as well, such as the International Hellenic University, CERT, and Polytechnic University of Valencia, as well as quite a few SMEs like ourselves, 8 Bells, Sidroco, InnoCube, Ubitech, Minds, Probotech, and so on and so forth. So it's important to mention that 8 Bells' initiative was to create a cluster of different projects that work on the AI research. And in this cluster, we've included projects such as Safe Explain, Sustain ML, AutoFair, along with Talon, of course. Our name is Trustworthy AI, and we're collaborating and working towards a trustworthy AI. Now, in order for you to understand what Talon is all about, I will, again, once more, present you and bring you into some hypothetical scenarios, some imaginary scenarios. And the first scenario will address a problem. The problem is that manual handling is not effective. Now, imagine that you are the owner or the technical manager of a facility, of a manufacturing plant. In this facility, you would have loads of equipment that would probably come out with some faults on a daily basis, and you would have to deal with such faults effectively. For example, you might have a belt that's transporting a product from a point A to point B, and this belt stops working. Now, the cause might be that the belt itself is broken, or the propeller is broken, or some human intervention has caused the problem. In identifying such problems, if we use traditional approaches, this proposes an AI orchestrator for autonomous, dynamic, and greener AI networks. So essentially, this AI... Now, in a second imaginary scenario, I'd like you to be the operator of a large-scale drone company, and you're working for the government. Now, what the government requests you to do is take video and pictures of different designated areas all around a country or different countries using multiple drones. Now, in collecting those data, you would have to process them somehow. A good idea would be to send them to the cloud, perhaps, and then machine learning algorithms and cloud applications would analyze those data to produce the results, and those results would be sent to the different destinations that is required. However, with the problem with this approach is that such an approach is not entirely secure, especially when we're dealing with sensitive governmental data. The solution is Talon again, with a distributed blockchain for high security, privacy, and trust. This would also decrease the latency, increase the resilience, security, and privacy, and will all work on the decentralized and hierarchical distributed blockchain-based mechanism. Continuing, latency is our enemy, and people working in research probably know that quite a bit. In this case, I would like you to imagine that you are an AR solution architect. So you work for a company, and you design smart glasses for specific use cases and specific clients. Now, those smart glasses will be used by end users working in manufacturing plants, and they will use them for training and to find solutions in different tasks that they have to undertake. Now, the problem with that is that sending such data to be analyzed again on the cloud is time-consuming, and latency is our enemy, especially when we're talking about high traffic and time-stamped sensors. So what Talon proposes to bring a solution to this challenge is edge computing. So all the data will be processed on the edge. The communication between the edge and the cloud will be managed by a smart managing tool, and this will resolve many of the issues that would otherwise exist. Finally, this is a rather more futuristic scenario that although comes to place nowadays as well, and this is about human and robot collaboration. And the problem in this collaboration is that AI is essentially a black box, and in order to understand the decision-making mechanisms of an AI tool, it's quite hard. What Talon suggests in this case is digital twins and human in the loop. Digital twins will bring the decision-making mechanisms of an AI tool onto your screen so you can monitor the decision-making process. Now, all those objectives are based on 4 pillars, and as you might have understood, especially if you were here in my previous presentation, is that these are not random imaginary scenarios. These are real-world Talon's test beds. And we test, and we measure, and we quantify by how much Talon is effective on each one of those use cases. We measure latency, we measure quality ratio, we measure time delay, and we have specific targets, and until now Talon's results are quite impressive and encouraging. Now, this is our project at a glance, and what I'd like to point out here is that those 4 test beds test all of those pillars horizontally. So it's not as there are separate technologies tested on each test bed. Those 4 pillars are tested horizontally on all of those 4 test beds. There are specific KPIs and specific actions that will be undertaken to reach the objectives and fulfill those pillars. Now, this is Talon's architecture. What's important to keep here is Talon access layer and the Talon information layer. This essentially collects the data, stores them in a data pool, and do some basic aggregation and preliminary analysis. Then, of course, the security layer is monitoring the whole process of Talon analysis, and with blockchain and the distributed ledger to ensure security and anonymization. In the AI orchestrator, there is the lifecycle manager of Talon that controls all of the processes, and the resource manager that essentially decides where, how, and what amount of data will be processed. And, of course, the AI cognition layer, where the machine learning models are stored, and the semantic model resides. And, of course, we have the slicing layer, where the digital twin controller lies. Now, our motivation at Talon is to pave the way towards a greener industry, and in doing so, we apply a fully automated AI architecture with processing data at the edge and a flexible, adaptable, explainable, and energy and data efficient manner. Thank you very, very much for your attention.
We have two presenters which practically give the answers why we say last but not least, because both are excellent presenters. My friend Mrs. Betty Charalampopoulos, CEO of the Geosystem Hellas, will discuss issues about dark vessels monitoring, a very challenging issue for security, for law enforcement agencies, for various matters. So, Betty, we would like to hear from you.
Thank you, Yannis, and thank you once more for inviting me to the Infocom session this year, 2023. As usual, our presentation is closer to the market. I have been following the previous presentations since almost 4 o'clock in the afternoon, and I see several tools that can be further elaborated inside the two projects that I'm going to present. Just a few words about the company. As Yannis have said, I'm Betty Charalampopoulos. I'm the CEO of GSH, Geosystems Hellas. The company started in Greece in 2009. We do also have a branch office since 2019 in Heraklion, Crete. It's a Greek SME. When we started in 2009, we had a minority German shareholder, Geosystems GmbH, that last year is fully acquired from OHB SE, from OHB Bremen. So it's good that it's a minority, so we continue as SME and we are not large enterprise. But by this change, we are diving more on space technologies and also telecommunication aspects. The company has several international collaborations. Mainly, we work on marine subjects and built environment. When I say built environment, we cover also critical infrastructures, and because for us, built environment, it's also cultural heritage, we do cover also cultural heritage monuments management as for security mainly. The company has all the ISO certifications in order to proceed to specific projects, and also we do have NATO secret, EU secret qualification. We do have 3 divisions. One is purely commercial, so we are involved in industrial projects. We do have a software development division, and also we do have R&D projects that from which R&D projects we try to combine outputs in order to feed commercial and industrial projects. For sure, for us, satellite technology on communication is a benefit. We use it as a tool. Means that we understand how important is the satellite connectivity that give us secure communication, and like that we can have uninterrupted and encrypted data in our projects. We understand that satellite communication ensures swift data transmission, real-time updates, and this is critical in order that we give to our customers enhanced decision-making. We fully understand that advanced threat detection systems ensure early identification and mitigation of cyber threats, so we are using what we say satellite communication as a benefit to our tools that with those we serve the market. As far that I will show to those two projects that I will present, we are using a multiple satellite technology. We are using satellite imagery in order that we can, with fast and enhanced imagery transfer and artificial intelligence, to secure the visualization of the object. We use the communication in order to have from other sources with secure communication, real-time information, and also deliver real-time information to the decision makers. And we want for that somehow to use the satellite technology in order to have global coverage and accessibility, means that to secure the communication as fast as possible and give to the end user the correct information. The task, it's little strange, is dark vessels. Dark vessels are the vessels that they do not use AIS, or they shut down their AIS because of a period of time not having, let's say, clear business as usual. So our task is that to detect those vessels, and to detect those vessels because at that period that we can detect them, there are a kind of illegal activities. The kind of illegal activities can be a real illegal activity that has to do with terrorism, or have to be an illegal activity that has to do with environmental protection, means there are such kind of dark vessels trying to go fishing to Natura areas, and like that there is biodiversity loss. Or another thing that they are doing is to pollute the sea with illegal, not illegal, but with waste, and this is another illegal action. So in order to detect on time those illegal activities, and there are also specific customers' interest for that, we are trying to use a seamless, holistic procedure in which various Earth observation data sets with the use of AIS and RF data, and of course artificial intelligence, can give us the correct output that shall be used in order we give a filtered information to our customers and users. I'm Now, moving on to the first project, which is the MAGNET project, is funded from the European Space Agency. And in this project, we collaborate with LuxSpace and List University in order to give a comprehensive solution for maritime security. We use all European Space Agency assets and Copernicus assets that can be used as Earth observation data sets. We use very high resolution complementary Copernicus imagery, SAR imagery specifically. We also use micro and nano satellite with optical and SAR missions, and night missions like that with artificial intelligence we can detect night lights. As far as we know, dark vessels, they move all over the world. It's not only an issue in Mediterranean Sea, but it's everywhere. And it's something that with these satellite capabilities, we have improved the detection, means that we can better now give the information specifically to customers like insurance companies, and also the accuracy. Like that, we have a service which is always in continuous state-of-the-art updates. Since satellite launches are a subject of change, especially when we speak for the micro and the nano satellites, a continuous change. On parallel of that, as company, we are involved also to the Greek CubeSat program in order to combine such capabilities on top of those services. And that's a small screenshot of how things are running. We can use also from microsatellites video data for the specific the case study. You see that the area that you see the images is not Greece, but it's southern to Larnaca harbor in Cyprus. Means that as a first case study that we can also show, we have used this area. It's very, very effective. The merge and the fusion of that kind of data means very high resolution optical imagery, video data, SAR imagery, very high resolution SAR imagery, and night lights radiance in collaboration with RF emitter information, and of course with fused, if any or not, ICE data. This service is a service that can serve also fisheries companies, because the fisheries companies are the ones that they lose, how to say, money, euros, because it's something that happens also in other areas. And this is the architecture of the idea, because illegal fishing is another dark vessel problem. We do have service for day and service for night, which at this moment is running in Mediterranean and also in Atlantic coast. The ESA project gave us some kind of food in order to go to an Horizon Europe project. Euromars project is a security project, is an innovation action. So we decided to go in because we are interested for the market and in which kind of market we can expand our tools. So Euromars project aims to develop a multifunctional monitoring platform for border surveillance in order to give to the authorities the correct information in the fastest way as possible. The output will be a platform that will contribute to improving risk and threat management and, of course, combine multiple technologies. The coordinator of the project is Eurodynamics, and we are several partners around Europe having the same ideas of how this output can be. Of course, we are responsible on the part of the maritime dark vessels detection that has to do with illegal immigration, drug trafficking, and others. What we would like to do is to enhance border security for Europe. I'm going to go faster. And Euromars consists of 4 sensing systems: coastal ground, low-altitude sensing system, high-altitude sensing system, and satellite-based systems, which is what we are trying to achieve. The idea is very, very similar on our side on what I have described to Maginet project. And the ambition is to make a flexible, interoperable surveillance platform in which, of course, with advanced data fusion and artificial intelligence tools, we can better have maritime situational awareness. The satellite communication and the utilization of satellite imagery can enhance, for sure, the maritime security. The satellite communication is certain to be further researched in the future to harness and give us the full potential in order to better use in maritime security. Thank you for your attention, and if there are questions, happy to answer.
Thank you, Betty, for these interesting works and applications which are directly relevant to the market, as you mentioned. It's good to see how several technologies do provide solutions, alternatives for facing actual needs, and this is a quite sensitive issue, the dark vessels, for various reasons, as you mentioned, for security, for environmental options, and so on. Very impressive. Thank you.
Thank you, Giannis. Thank you for the invitation.
Thank you. And now, okay, hopefully, we have the final presenter, Dr. Dimitrios Tsampelikos from the municipality of Egaleo. I don't want to say much, but you will see the slides and you will understand the work which is performed in Egaleo. However, it's not broadly known compared to other municipalities in Greece. On the other hand, you have the results, okay, and you can prove that you are doing and your work and you are promoting innovation in various areas.
Yes, we try to do that, yes, for sure.
As we will see.
Okay, thank you, Giannis. Thank you very much. I would like, on behalf of the Mayor of Egaleo, the latter one and the new one, to thank you for the invitation to come here and to present some smart application which actually take place in Egaleo. I would like just to declare here that the title, Egaleo Smart City, is a bit tricky because Egaleo, to be honest, is not a smart city. We try to be a smart city, and we believe that in a few years, we'll try to transform in a smart city. I'm Dimitris Jabelikos. I'm head of Directorate of Planning and Development in the city of Egaleo. Just to have a small presentation about Egaleo, because some of you do not know where is Egaleo and actually what is Egaleo. Egaleo actually is a municipality and situated in the west region of Athens. It's one of the oldest municipalities in Greece, and according to the census of 2021, we have about 65,000 people. This is actually not true because in Egaleo there is a University of West Attica with a lot of students, and the de facto and the real population of Egaleo exceeds 100,000 people. Regarding some other basic infrastructure, we have 3 metro stations. We are for sure an urban city, and we have a very promising region, which is actually located in the east part of Egaleo. It's the region of Eleonas. I think, in my opinion, is the big project in the next decade. So Egaleo organizes and develops initiatives in different fields because we are a municipality. We're not a private organization, in culture, sports, issues on social policy, environmental, technological, modernization, and serving of civic protection. I would like now to present not analytically some European projects that Egaleo participated and participated now. On the left column, you can see in the yellow colors some previous projects that Egaleo participated, namely 5G Ascent, Genesis, drones, responding to QSER. And the right is project which is actually under implementation. We have many projects in different categories. For example, the first one, Transformar, deal with how the Egaleo increase the awareness and how to prepare for the climate changes. The second project also seems to be a similar project with the Transformar, but with more theoretical tools and theoretical research. The UM School for City is a project with about the urban air mobility, because we have understood that a few years from now, we will use our air, for example, as a corridor in order to go through all the drones. So we have to open the discussion on what will happen in Egaleo, not only Egaleo, but in all other cities. We have some other projects. For example, the bin-to-bin project is a very important project for us, okay, because deal with how we can increase and how we manage the by-waste collections. This is very important for us, this project. Imafusa project is also very important because study how the effect of the noise of the drones will affect the urban environment. And we have 2 more projects, ambitious projects. Also, we collaborated with OTE and the scientific team of Yannis Kochliouros. And the last one is the project Rock the Block. It's a new project, the biggest one we have for Egaleo. Also, in this project, we are a coordinator. This project belongs to the new European Bauhaus framework and deal with affordable housing. Just a comment from my side here, from 2017 and now, and nowadays, we have budget from a European project over 3.5 million euros. I mentioned that because in Egaleo, we need, let's say, some economical finance capacity to implement some application. We use the national funding, but we need more money to make some advances and to bring some new technologies to our citizens. So let's go further with the first one application. Okay, this is very simple. It's a GIS platform. It's very important for us because the majority of the data of Egaleo have been, let's say, set it in a GIS-safe format. So this is, for us, the basement in order to transform in a smart city, because all the data actually have been digitalized and put in this platform. The second one is some e-services. Don't forget that all municipalities in Greece have important and some specific certificates that actually do not be supported by the national government, for example, the eGov. So we have developed a platform, so our citizens can use the platform to send the request, and then we come back with a digital document which actually be used. The third one is a practical example. We have created a smart square at the entrance of our municipal grove, Baroutadico. We made this project for two reasons. First of all, to test the LoRa network telecommunication, the protocol, because in the next slides, on the slide after the next, you will see why it's important for us. And we just put it some environmental station to measure the environmental data in the location in the entrance of the state, in the entrance of the grove of our municipal park. Also, it's very important. We have some monitors in order to our citizens, because don't forget, we don't have citizens, young citizens, we have older citizens with big age, so we need someone to go and to see the results. This is the Smart Square, and we have another application. It's very common. It's the Novel application. It's a platform which actually uses our citizens to exchange some information and some requests from the daily life. For example, we have a light off. Someone can make a request through this platform, and then the services of Egaleo just go and repair this problem. This was the biggest project for us. This is the energy upgrading of the lighting of the municipality of Egaleo. Actually, from 3 months from now, we have a contract with a company, because we have already now finished the tendering process. With this project, first of all, we changed all the lights, the conventional lights of Egaleo, and the number is quite big. It's about 8,700 lights with the new lights, the LED lights. So we have an energy reduction from the lighting, but the most important is the next one. Through this project, we elaborate 15 to 20 LoRa gateways inside the network of Egaleo. So every new sensor that actually will be used, and it will be used in the future, we have to collect all this data with all this LoRa gateway. So we have a platform, first of all, to manage all the lighting, and then all the sensor, different sensor, because municipalities have a lot of data and different data, will be collected and go further for analysis. The sixth project is our Smart City platform. This Smart City platform has been funded from national funding, from a national program. This platform has city guide maps. We have digital guide, recreation walks, and some other, let's say, application. Digital governments. We have consultation with citizens, citizen requests, digital certificate, and so on. Recreation and culture. This is another module, very important, because for the first time we make a virtual tour in Municipal Grove. The Asian Minor Culture, digital guest books, games and contents, voluntary action, the municipal library. Of course, behind the system, we have a business intelligence platform in order to help us, for the municipality, to take some serious decision about how we can use all this data. And we have some interfaces and some system with some other applications. This is the logo, and this is the site, which actually we can go through and see all these sessions. This is the 7, let's say, applications. Through the SIM2E project, European project, we have made a 3D model of a part of the region of Egaleo. You can see here. This one. This is a real picture. So take a small, not a big region of Egaleo, make a 3D model, take some attributes from the national statistical our national statistical agency. So for each apartment, we have how many people live inside, about the age of the people, and if there are some people with disabilities. So this is the first one. So on the left picture, you can see distribution of the population generated for the Gallo case study area. I would like just to denote here that this not produce all this research from a Gallo. A Gallo participated in the project, so we have relative partners which actually develop the algorithm and, of course, all the necessary running of the code. The second, let's say, figure categorized population by the walking speed. So we have the third picture here, which actually make the visualization of the evacuation center. This is actually a behavior model. So we have the behavior of the people in order to make an evacuation model. This is very important for us. It's the first time this type of research take place in our municipality. The next one is the Transformar project. It's more practical project for us. We have some predefined solution. We set some smart climate station. Nowadays we create a citizen application engagement. We also make some action regarding the awareness and the raising modules. We made a climate innovation hub. It is also for us in advance, and make a demand analysis for social services and infrastructure. Here you can see we actually now, at the end of the month, we set 21 environmental stations. 6 of them will be commercial microclimatic stations, which actually measure temperature, atmospheric pressure, relative humidity, parts per million particles, rainfall, wind speed and direction, and CO2 concentration. And 15 custom environmental IoT stations with actually can measure temperature, atmospheric pressure, relative humidity, parts per million particles, and CO2 concentration. This here is a distribution of the environmental station. Why I say that? Because EGALO cross-cut it from national roads. This here, you can see here in this is a national road of Athens to Thessaloniki. This is a road of Athens to Corinthos, and this is some basic roads. This is Thivon Avenue, and this is Iera Odo Avenue. I say that because, as you can see, EGALO has a lot of national roads, a lot of pollutants gathered in the region, different regions of EGALO. So we decided to put all these stations at the border of our city in order to have an estimate, first time real estimate, not estimate from literature research, what happened in EGALO. This is actually very important for us project. Also, we use this data from our partner because we have a strong collaboration with Demokritos, collect all this data and make some prognostic method regarding the weather. We have a prognostic duration for 2 days taking all this data. So you can see we have the environmental station, climatic station, from the data which actually will be analyzed from Demokritos, and all of this you can use it by EGALO, and also from our application, which actually will be free for our citizens. So our citizens have a clue about the environmental situation in EGALO. Also, EGALO go through with the urban digital climate twin, what actually do in this direction. Through the Rock the Block program, we actually, we actually renovate from a perspective of new European Bauhaus framework, at least 10 private buildings. So we make some advances in these buildings. For example, increase the energy capacity of the building, make some other, let's say, aesthetical intervention. Also, all this intervention will be free for our citizens. Of course, we set a collection and a process how we collect and how we can proceed with these buildings. But this is the first time that the financing from European program goes towards to our citizens. Also in this project, in this 10, for instance, 10 buildings, we set environmental and consumption sensor inside the buildings of the private buildings, and also some other application and sensors. Just go to this one. We'll try and EGALO all this data to collect data from different sources. For example, IoT sensors, which actually will be implemented in Galileo, Earth observation data with collaboration with Demokritos, social-economical data, also is very important for our studies. Citizen-collected data through workshops, questionnaires, and electronic surveys. So we have many other, let's say, sources for data. We have understand how important it is to collect data, but the most important is how to use this data. These are, let's say, next big project for us. The last one is the Climate Innovation Hub. It's a very new building room for us. We have created through our European project. We use this innovation hub in order to make some hackathons to educate the young people from the schools in Galileo to come to understand, play with some sensors, and to understand how the climate influences their lives. That's from my side. Thank you very much.
Thank you, Dimitris. Thank you so much. For those who remain here, I can declare that we can finalize and close the scientific session, the scientific workshop comprising of 12 distinct sessions of this year Infocom World Conference. I would like to express my thanks to all speakers for their presentations, to the presenters, and to all of you who remained here till late now. And as far as I can see, the remainders are also speakers. They are all invited to the social event we have announced to the partners of this event that will take place at Hachiko restaurant, area of Neopsychiko. Thank you all for joining, and hopefully we will try to organize a better event next year. Thank you so much.